Hello everyone and welcome to this video on the Power BI full course by Edureka. Power BI developed by Microsoft is a leading business analytics tool that transforms raw data into meaningful insights through interactive dashboards and reports. It seamlessly connects to a variety of data sources, enabling users to visualize and analyze their data in real time. Key features include data connectivity, transformation, modeling, and robust visualizations. With Power BI, organizations can easily share insights, collaborate effectively, and make data-driven decisions. Its user-friendly interface and powerful capabilities make it an essential tool for business intelligence and analytics. With that said, now let's outline today's agenda for this Power BI full course. We'll begin with an introduction to Power BI, covering what it is and exploring its components, architecture, and building blocks. Next, we'll cover how to build Power BI dashboards. You will learn about the components of a dashboard, how to connect to data sources, and how to use visuals, charts, and KPIs to create interactive and effective dashboards. We'll then explore Power BI Desktop, showing you how to create various types of data visualizations. We'll then dive into Power BI Charts, where you'll understand the different types of charts available and how to use them to represent your data effectively. We'll then introduce you to Power BI DAX and how to use DAX to enhance your data analysis. We'll cover various Power BI integrations, including Power BI Azure, Power BI Python integration, Power BI KPI Indicators, and our Power BI integration. You will learn how to connect and use these integrations to extend Power BI capabilities. Next, we'll explore Power BI Report Builder, in which you will learn how to create detailed and professional reports using the tool's features to represent your data's insights clearly. Following that, we'll guide you through practical Power BI projects, giving you hands-on experience. You will work on real-world scenarios to apply what you have learned. We'll also discuss Power BI certification process, the benefits of getting certified, and how to prepare for certification exams to validate your skills and knowledge. Then we'll compare Power BI with Tableau, highlighting the strengths and weakness of each tool. Finally, we'll cover frequently asked Power BI interview questions and answers. This will prepare you for job interviews, helping you to confidently demonstrate your knowledge and skills in Power BI. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also visit the Edureka website for Microsoft Power BI Plus, certified by PwC, the link to which is given in the description box below. Now without further ado, let's get started with our first topic, Introduction to Power BI.
Now, why should you choose Power BI? Before I answer this question, I would like to answer something a little more fundamental. Let's start by addressing the most essential and fundamental question: what exactly is business intelligence? Now, in an age where business intelligence has become a bigger domain than most trending technologies, if you ask 20 different people what the term means, you're likely to get at least 10 different answers. So let me try and put it in the simplest of terms without having to lose the technicality of it. Business intelligence is a set of techniques and tools for the transformation of your raw data, meaning your data sets, into meaningful and useful information to take important business decisions. To put it simply, business intelligence is the technology which gets the right data to the right people at the right time, so that they can take more effective business decisions. Over the years, the process of business intelligence has grown and adapted to help solve almost all the challenges while dealing with data by involving newer tools and techniques. The change that business intelligence has seen over years can be divided into three waves. So let us continue with our tutorial and take a look at the first wave, IT to end user, or the technical wave. During the first wave of business intelligence, the end user had to be dependent on the IT department for data insights. This is because it was not possible for end users to create visualizations or reports on their own, as tools available required some technical or coding knowledge. This dependence on the IT department for insights resulted in more efforts and time consumption to get the updates done. Now the second wave, which is analyst to end user, or the self-service wave. Now, the second wave gave analysts access to BI. Now, people with some knowledge of analytics could use BI tools. This meant more teams had the access to BI and more people could have better data insights. This eased the role of the IT teams. And finally, the third wave, which meant everyone, which means the power lied in the hands of the end user. The third wave made it easier to access data and create reports and visuals to get better business insights. The introduction of tools like Power BI, Tableau, ClickView, and Spotfire made this transition easy. Now, anybody who had a basic understanding of data could create reports to build intuitive and shareable dashboards. This was about the three waves of BI. And in the third view came a very important aspect, data visualization. Now, data visualization is nothing but the pictorial or graphical representation of information or data. It provides insights into complex data sets by communicating the key aspects in a more intuitive and meaningful way. Data visualization lies at the intersection of design, communication, and information service. Even though your data visualization has been termed as the key skill for research in the 21st century, it goes way, way back. It existed in the late 18th century and can be traced back to when William Playfair invented the geometrical charts. His bar charts were used to represent Scotland's imports and exports of 17 countries in 1781. These bar charts constituted a pure solution to the problem of discrete quantitative comparison. Now, obviously, we have grown to learn about more and more charts as the years pass by. We also have a few hybrid charts to make our jobs easier and our calculations more granular. The way our human brain processes the information is easier to use images, charts, and graphs to understand and visualize large amounts of complex data than going through tons and tons of spreadsheets on reports. Take the quote, "An image is worth 1,000 words," for example. This is completely true because as a human mind, images aren't just a mere collection of pixels. They hold a lot of information. This information in visual form is easy to understand than reading the same facts in text or number form. So let me give you an example. Suppose there's a company which deals with a lot of products, like Amazon, and it's widespread over the world and has many vendors that sell through this platform. So obviously, there's a lot of data being generated in a lot of different formats. People use Excel, Access, different databases, SQL Server, so on and so forth. Some people even make all these spreadsheets and upload it to the web. So obviously, all that has to be brought to a single platform to analyze. And then these are the reports that go to the CEOs, CFOs, and the CXO position, all the big people in Amazon. Now, you can't just take 1 million or 10 million rows of data to a person to look at and infer something, right? You need them to know what's going on. What is going on inside the company? How is the market outside of the company? And this cannot be done with hundreds and thousands of numbers. This is where data visualization comes into picture. It's about giving them an idea of what's going on inside their company in different departments without having to look at tons and tons of numbers. Well-designed graphics have the power to put this complicated data into simple pictures. And this is where modern BI wins. Data visualization is a quick and easy way to convey concepts or information in a universal manner. It can help to 1. Identify key areas and hidden patterns, 2. Get factors that give better customer insights, 3. Analyze and associate data and products properly, and finally, make proper predictions. And obviously, presentation has a big role to play in this. So pardon me for my analogy, but if this was a beauty contest, let's go ahead and look at our winner. Now let's see why we need Power BI. Now there are a few points that make Power BI one of the most prominent tools for data visualization. Now this tutorial would be incomplete without understanding these points. Firstly, Power BI can spot trends in real time. Traditional BI tools like Tableau or ClickView restrict you to historical analysis. By using Power BI, you can access real-time information so you can identify trends early. By doing so, you can identify issues and improve performance. Secondly, Power BI can automatically search hidden insights. With Power BI, you can auto-search datasets for hidden insights in seconds. With Quick Insights, users can simply ask questions and Power BI Q&A will answer their questions with an immediate effect. Third, advanced analytics and custom visualizations. With custom visuals, Power BI allows you to visualize data in almost every way possible. As long as you can imagine it, you can put it on your dashboard. Thus, you're not limited to something that lies in a box. Finally, Power BI is enterprise ready. With Power BI and Power BI Desktop, you can securely connect to your own on-premises data sources. With the on-premises data gateway, you can connect live to your SQL server and other data sources. It gives you a secure, scalable, and reliable enterprise-grade information technology. And these mentioned reasons make Power BI very important in context of data visualization. So who can use Power BI? IT professionals, developers, companies big and small, subject matter experts, and plain analytics enthusiasts. As long as you want to, you can all use Power BI. Now let's continue to understand this by knowing what is Power BI. Now Power BI as a name has been in the BI market for quite a long time. The Microsoft team has worked for a long time to build a big umbrella called Power BI. And this umbrella is a combination of strong visualization, data analysis, data sharing, aggregating, and cloud integration. To define it, Power BI is a business analytics service provided by Microsoft. It provides interactive visualization with self-service business intelligence capabilities where end users can create reports and dashboards by themselves without having to depend on information technology staff or database administrators. It also gives you cloud-based BI services known as Power BI services, along with a desktop-based inference called Power BI Desktop. It offers data warehouse capabilities using data prep, data discovery, and interactive dashboards. In March of 2016, Microsoft released an additional service called Power BI Embedded on its Azure cloud platform, which enables the user to analyze data easily and perform various ETL operations and deliver reports with Power BI. The Power BI gateways let you connect with Access, Excel, SQL Server databases, analytics services, and many other sources to your dashboard in Power BI. And reporting portals embed Power BI reports and dashboards to give you a unified experience. What you see on your screens right now shows Power BI's general workflow. You have thousands of data sources which are being connected to Power BI Desktop, which then can be published into the service and gives you an option of connecting your organizational data live through your Power BI gateways. In the end, this can all be accessed through your tablets, laptops, and cell phones with you, your colleagues, and everybody involved in your business decision. Now that you understand what Power BI is, let's go ahead and look at a few of its benefits and why are we using this. Firstly, it has pre-built dashboards and reports for popular software-as-a-service solutions. Power BI helps you create powerful visualizations in the form of dashboards and reports, and you can do them without any technical knowledge at all. All you need to do is have a little bit of analytical sense, and you can use this service to your advantage. Next, it has real-time dashboard updates. As I had mentioned before, Power BI works real-time and it can forecast trends in the coming few years as well. Third, secure live connection to your data sources on premises and in the cloud. Through the Power BI gateway, you can establish connections that are secure and your organizational data can be connected to live every time that you want to. The best part about this is it is scalable and very, very secure. Fourth, Power BI also provides you intuitive data exploration using natural language query. You do not have to know the query language to explore your data in Power BI. just using your everyday English or your natural language, data exploration can be made possible. Fifth, integration with familiar Microsoft products to utilize commitment for scale. Power BI can integrate with a number of sources and a number of Microsoft products, which makes it highly scalable compared to other BI tools. And finally, immediate deployment. Power BI is known for its quick deployment, which makes your job quick as well as easy when you have to take critical business decisions. And that was all about Power BI. In the section ahead, we are going to discuss a few components of Power BI. Now, Power BI has a few components. You have Power Query, Power Pivot, Power View, Power Map, Data Catalog, Data Management Gateway, Power BI Q&A, and Service. Starting up, we have Power Query. Now, this is a component which can be used to search and access and transform public and internal data sources. It is the Microsoft's data connectivity and data preparation technology which enables business users to seamlessly access data stored in hundreds of data sources and reshape it to fit their needs with an easy-to-use, engaging, and no-code user experience. Next, we have Power Pivot. Now, you can use this for data modeling, for in-memory analytics. It extends a local instance of Microsoft Analysis Services Tabular that is embedded directly into your workbook. It enables you to import millions of rows of data from multiple data sources into a single Power BI workbook. It helps you create relationships between heterogeneous data, create calculated columns and measures using formulas, and build pivot tables and pivot charts and further analyze the data. Then you have Power View, which is a data visualization technology that lets you create interactive charts, graphs, maps, and other visuals that bring your data to life. Now, Power View is available in Power BI, Excel, and other analysis services from Microsoft. Then you have Power Map, which is also another feature in Excel. It is for exploring map and time-based data. It lets you plot geographic and temporal data, visually analyze that data in 3D, and create cinematic tours to share with others. Next, you have Power BI Services. So this is a collection of apps, dashboards, and reports built to deliver key metrics for your organization. These apps are interactive with each other and helps customers work with their own content. Then we have Power BI Q&A. It's basically a feature which helps you ask questions and get immediate answers. Sometimes the fastest way to get an answer from your data is to ask the question using natural language. So you can use Q&A to explore your data using intuitive natural language capabilities and receive answers in the form of charts and graphs. Next, you have the Data Management Gateway. So basically what this does is it connects your on-premise servers with your Power BI in the cloud. If you want to refresh your data in the cloud with the data that is on the premise, you will need to have the Data Management Gateway configured and available to your tenant. And that is how this works. And finally, we have our Power BI Data Catalog. Now this contains the metadata for facilitated search functionality in Power BI. Now your metadata gets stored in Power BI Data Catalog in the cloud for a shared query. It gives you a search access list for the query to determine which users and security groups can find and use this shared query. Now that we've seen how the components work, let's continue with this tutorial and understand the architecture of Power BI. Now, broadly describing, Power BI's architecture has three phases. The first two phases partially use ETL to handle data, and then you have the presentation of your data. So let's take a look at these phases one by one. First, you have data integration. An organization can be required to deal with data that comes in from different sources, as I had earlier explained in my Amazon example. Now, this data comes from different sources and can be in different file formats. Now, the data is first extracted from these sources, which can be your different servers or databases, so on and so forth, from wherever you can pull in data. This data is then integrated in a standard format and then stored at a common area called as a staging area. Then we go to our second step, data processing. Now the integrated data is still not ready for visualization because the data needs processing before it can be presented. Now this data is pre-processed or cleaned, as we can call it. This is also known as transformation of data. For example, missing values or redundant values are removed from the data set. After the data set is cleaned, business rules are applied to the data and it is transformed into presentable data. Now this data is then loaded into a data warehouse. And now that you have extracted, transformed and loaded data, your ETL is complete. Finally, you have data presentation. So once all this data is loaded and transformed, it can be visualized much better with use of various visualizations that Power BI has to offer. You use reports, dashboards, and help one represent data in a more intuitive manner. These visuals, reports, help business end users take important business decisions based on these insights. With that, let's move on to the building blocks of Power BI, where we can talk a little more about these insights. Now, everything you do in Power BI can be broken down into the following building blocks. A good understanding of these building blocks would help you understand concepts and will let you create detailed and complex reports. So the basic building blocks of Power BI are the following. You have visualizations, datasets, reports, dashboards, and tiles. First up, you have a visualization. A visual representation in the form of graphs and charts and maps of a data is called visualization. For example, a chart or a graph can be used to represent data visually. Power BI gives you different visualization types which keep getting updated with time. Now, some of the commonly used visualizations are map representation, card visualization, stacked area chart, tree map, and pie chart. Now, these visualizations can be simple or complex. However, visualizations aim at presenting data in such a way that it gives you more insight in the context, which is otherwise difficult to discern from simple data files. Next, we have datasets. Now, we know that a dataset is nothing but a collection of data or information in the form of spreadsheets. Now, Power BI can harness this data to create visualizations. It can be a simple dataset or a combination of many different sources which can be filtered and combined to provide a different dataset altogether. For example, you can pull together data from many different sources like different database fields, an Excel table, and online results of some email campaign to create your dataset. Having said that, you may want to filter your data before you bring it into Power BI. Filtering lets you focus on the data that actually matters. With your dataset ready, you are now free to create visualizations and display different portions of the data that's set in different ways. And with this, you gain insights. Next, you have reports. Now, a collection of visualizations that appear together on one or more pages is a report in Power BI. In a collection of items, these reports combine to form a workbook and are all related to each other. You can create visualizations on multiple different pages if necessary and arrange them in a way that best suits your interest. What you see on your screen is the image of a sample report. Next, you have dashboards. Now, Power BI dashboard is a single page interface. It is often called a canvas that uses visualizations to tell a story. Now, a lot of you might be confused within the difference between a report and a dashboard. Now, this is because it is limited to one page. A well-designed dashboard contains only the most important elements of your story or your report. The visualizations you see on your dashboard are called tiles and are pinned to the dashboard from the reports. So in a way, you can say that your dashboard is a compressed version of large reports that you are going to present. Now, because this is limited to just one page, a well-designed dashboard contains only the most important elements of that story. The visualizations you see on the dashboard are called tiles and are pinned to the dashboard from reports. In Power BI, a tile is a single visualization found in your report or on a dashboard. It's the rectangular box that contains each individual visual. Now, Power BI gives you the freedom to move or arrange tiles so you can present the data the way you want to. Even while you're creating a report or dashboard, you can make the tiles bigger, change their height or width, and snug them up to other tiles any way you want. So this was all about Power BI's building blocks. Now I'm going to take this Power BI tutorial a step further with a demonstration of creating a simple report using Power BI. Microsoft Power BI is a suite of business analytics tools that helps you create and share actionable, intuitive reports for business insights. And now I'm going to show you how you can put your data to work with Power BI. We'll go through the basics of data visualizations and dashboards, and we'll go through how to create and modify data visualizations. We'll also look at how to join data from multiple sources and build a dashboard report to share with our colleagues. So, what we're going to cover today, in part 1, we'll be getting started using it. Part 2 will talk about joining data from multiple sources, and part 3 will talk about building and sharing a dashboard. And at the end of this, we'll have a demo. So part 1, getting started. In this section, we'll learn how to install the application. We'll talk about importing data from Excel to Power BI. We'll create and modify simple visualization, and we will save our report and publish to Power BI service. Now let's talk about installing the laptop application. First, what you want to do is go to http://app.powerbi.com. Here you'll sign in with your credentials. You'll run a simple wizard to install the application. Then you'll look for the download icon. It is here. It's an arrow pointing down with a line underneath it. So run that wizard. And the Power BI will be ready to launch, and it will automatically launch the first time that you run it. When you run it, you'll get this start screen. It is black and yellow. And you'll have access to forums, the Power BI blog, various tutorials, as well as some videos that you can watch and learn. But you don't need any of that videos because you have this one video. So let's go ahead. You can also access the Get Data functionality here from this screen. If you decide that you never want to see it again, you'll notice a checkbox in the lower yellow part of the screen that says Show this page on startup. Simply uncheck that box and you won't ever see it again when you run the application. So next up, you'll want to install some data. After you've installed the application, you're going to go to the Get Data button and you'll be able to pull in data depending on what you're using. You may be using data from Excel like I'll be doing further in this demo, or you may be using data from an example, a SQL Server database or an Access database. The options you have for pulling in data are a plethora. So there's a lot of available data sets, and we'll be sticking with the Excel for my demo. But keep in mind that you can pull data from a lot of different places. So after you have selected what data you're going to be using, you'll be given the option. Then in the navigation window, to select the exact data set what you want to pull, you'll checkmark a box. For example, right here, we have this box checked. And then you'll have the option to load the data or edit the data in the query editor. You'll probably want to edit the data in the query editor just to make sure that you'll pull in exactly what you want. Once you have pulled in the data that you want, you'll see that the data up here as a fields list on the right-hand side of the application. As you can see here in the sample data, we have a budget business team delivery day, but whatever you've pulled in will appear in the fields list. And you'll be able to use that data in the fields list to create your visualizations. So let's start here by creating a simple visualization. This is a very simple visual. It's simply a column chart with one number. So it's one column right here. It's the budget field that we pulled in. Drag whatever field that you want from your data. There is no strict rule to it, and make a visualization. You'll end up with a column chart like this. You can also see that there are a variety of charts available there. And then in the visualization box, you will be able to make modifications to it. And like I said, this right here is a bar chart, but you'll be able to make pie charts, column charts, line charts, and a variety of other visualizations in Power BI. A variety of modifications are available for visualizations too right here. We've highlighted where you can click on the lower right hand corner of the visualization and drag it up to make the visualization bigger or smaller. For example, you might want to make it smaller because maybe you want to put more than one visualization on the canvas there, or you may be wanting to make it large so that it can take up the entire canvas. So you can drag around the corners of your visualization to make it the size that you want. The format that Power BI saves reports says .pbix file. This is not the best way to share a report, but it's definitely the best way to save your work. If you're in the middle of something, you can go ahead and save your report as a .pbix on your machine or your OneDrive. Maybe even your OneDrive for Business or a SharePoint online set, wherever you're saving it. And so that way you'll be able to pick up later. If you're in the middle of building a Power BI report now, if you want to share your results of someone, the best way to do that is to publish the Power BI service. And you'll be able to do that using the Publish button, that is the ribbon, and that button is on the Home tab on the furthest right. We have highlighted it on the slide there. And then when the publishing is complete, you'll be given a link that you can click on in order to go see your workbook or your report. This will be there on your Power BI website, and you'll probably want to do that just to make sure it looks as good as you wanted it to in your tool. So this is the PowerBI.com interface. The PowerBI.com interface gets changed from time to time. That is also the reason for this particular tutorial, because it got updated in 2019 recently. It is a cloud service, and when new features come, you may see things in a slightly different place. For example, the search bar here, I believe, is slightly different now, but the gist of it is what we want. And you'll be able to use that search bar once you've published a lot of reports and have a lot of data sets available on your workspace. You'll be able to find them easily using the search bar. Or you can use the functionality of defined your recent reports, as well as when you'll be able to manipulate and share them using PowerBI.com interface. We're now going to go into part 2, which is using multiple datasets. So now we are going to be using multiple datasets and joining together in this section. We'll talk about adding data from other sources, joining the data from multiple sources, creating more interactive visualizations, as well as updating that published data on the PowerBI.com web service. So here we go with getting additional data. Now to get additional data, you do the same thing that you did before. You got your first data set, and it's really not very different from how you did it. You just are having some data you're working with. You'll go to the Get Data button, you'll push it, and our demo will be using Excel, but remember you can pull in data from a variety of sources. It is also good to keep in mind that they don't all have to be the same source. You could be using some data from an Excel spreadsheet, some data from, example, a SQL Server query, or from another database query. You can pull them all together in Power BI, create relationships, and manipulate that data, and create some great visualizations right here, just as you did before. You'll select the data that you want to load, and you'll probably want to edit your query before loading it, just like you did before. So whenever you're loading queries, you want to make sure that you have the data that you want and your data is in the form that you want it in. Before you pull it in, Power BI will load the data that you have selected, and there may be relationships in that data. For example, here we have some actuals and some budget information that we are loading in sample data. But you may have two different tables that you are pulling in, and they both have a month column. For example, in Power BI, the tool is actually smart enough to detect the relationship and join the data together. If it did not auto-detect your relationship, you'll be able to manually create it. But for most times, in my experience, it does it on its own. So I want to introduce here the Modeling tab. It's right next to the Home tab, and with the Modeling tab, what you can do is change some things with the format of your data. You might want to, for example, sort in a different way that then Power BI has already sorted your data, and you might want to change the format. If there's a number you want to change to a currency, or maybe you've accidentally formatted some numbers as text, and then it's important that you notice that you can't do any math because, of course, you can't do math with text, and your problem then is that it's formatted as text. You can easily go into the Modeling tab and change the format of the data over to the number format. So now you have pulled in data from multiple sources and you want to create some new visualizations. Well, keep in mind that the canvas view here, that's what we've highlighted. On the slide, that is the top of the three icons. You see there on the top, you've got the canvas view. Below that is the Modeling tab that we just talked about. And then there's also the relationship view, and we'll be talking about this as well. And in the demo, you'll be able to create visualizations using all of the sources of your data, and whatever you are using, you'll be able to create visualizations with all of your data combined. And that's one of the really powerful aspects of Power BI. As you create visualizations with your multiple data sources, you'll be able to modify those just like you did before. You can use the handlebars on the visualizations to drag and drop the corners around. Make the larger, smaller fit how you want to. Also keep in mind that you can have more than one canvas page. You certainly don't need to cram all of your visualizations onto one page. If you've used Excel before, it's kind of like making a new sheet. You'll see the bottom of the page and there's a little plus sign, and you'll be able to create a second, a third, a fourth canvas page and add more visualizations into the same report using multiple canvas pages. And made a couple of visualizations with Power BI. And right here, what I want is to highlight the fact that you can change the colors on your report to highlight certain things, for example. Right here, we've added some black to the columns, and Power BI actually gives you really strong granular control over, what your charts look like. For example, in a pie chart, you'd even have the granular control to change the color of one slice of the pie. So you really have a strong control on how your visualizations look right here. Now that you're done pulling in data from multiple sources, you're probably ready to publish. Now, whether you're publishing just for the first time or publishing again, it's just as easy. You simply go to the Publish button that's on the Home tab. Now, if this is your first time publishing, simply just publish it and then click on the link to go take a look at it. If it's your second time publishing, you'll be either given a choice to say overwrite a previous publication, or you're going to rename it and publish it again as something else. You'll get this wizard opening up, giving you the option to go to your published report. You'll go into powerbi.com's interface and view it. With that, we're moving into part 3. Now, this is the creation and sharing of dashboards. In this section, we'll talk about creating a dashboard, and we'll talk about pinning visualizations to that dashboard. We'll talk about modifying a dashboard, and we'll talk about sharing that dashboard with your colleagues or customers or business partners. So you obviously might be asking a logical question, what exactly is it? Well, most of you probably kind of know what a dashboard is, but what is it exactly? And at this point, it might be useful to make a distinguishing characteristic between data sources, reports, and dashboards. Now, we all know what our data sources are. Those are our Excel spreadsheets, SQL Server queries, or other data-based queries. When we've pulled in numbers and text and other types of data, then we've built a report on top of it using Power BI. Now, once we have created visualizations on that data, a dashboard is a really important aspect. It really is just a type of report, and what it is that visualizations from other Power BI reports are all pinned to one specific place that can be updated in real time so that your business partners and your business decision makers, your customers and your colleagues can look at the dashboard and instantly have the information they need to make those important business decisions. Basically, if you bring all your Power BI reports regarding that particular decision and put them into one canvas, that is when you have a dashboard. It is a compact form of your complete report. So now how do you create a dashboard? The easiest way to create a dashboard is to simply click on the pin icon, which you'll see on your visualization, and we'll then give you the option to create a dashboard. You'll also see, as we show you on the screen here, there's a plus sign next to the word dashboards in the Power BI interface. You'll create a new dashboard there too. Once you've created that dashboard, you can continue to pin visualizations to it. Here we go. There's that pin icon there. And you'll be able to click that and attach visualizations to your dashboard. And once you've done that, you'll be able to move them around and make it look like how you want it to look like. Eventually, of course, you'll have to share that dashboard with whoever needs to see it. The pin icon will ask you which dashboard you want to pin it to. Do you want to pin it to an existing dashboard or a new dashboard? If you need a new one, go ahead and select that. But you're building one dashboard at a time, and you're probably going to be sticking with your existing dashboard for a few visualizations at least. You can view your new dashboard with your visualizations, of course, and you want to look at it before you share it. Just to make sure that it looks how you want it to, go ahead and click and share and send it to some of your colleagues. You can modify your dashboard anytime, and you'll be able to click on the corners of your visualizations to make them larger or smaller, just like you would want it. Now, you won't have quite the degree of freedom you did with the canvas though. There are certain size settings for these visualizations. They can be so big, but you can't choose exactly how big you want them, like you could in the canvas. When you're in the web view, the predefined sizes is what they are called. When you're finally ready to share your dashboard, go ahead and click the sharing icon. So you'll type in the names or email addresses of the people you want to share it with. If you're dealing with a circumstance where you've got an internal and the global address list, you'll be able to simply type names from that. Or if you're sharing externally, you may need to use email addresses, and you'll type those in and go ahead and click share. You'll notice you have some options here, and you can allow the recipients also to share your dashboard. And generally, you do want to send an email notification when you share something with them. So then they'll know that it's shared with them and they'll be able to go access it. There's an option you can check as well. You can also share your dashboard once again by simply copying and pasting the URL. Once you've clicked that share button and added the person's email address or their name and shared it with them, even if they lose the link or they forget about it, they will never have to go through that process again. You'll actually just be able to copy that URL and paste it, and they can view your dashboard. Apart from that, there is also a QR code generated for every report for the very same purpose. Okay, so now we'll be going on to the demo, and every step that I had just explained to you, I am going to do it on Power BI and show it to you. So now we're going to start out by showing you how to download the application. You could either go to app.powerbi.com, and this will take you to the organization site. You have to sign in, and you'll sign in using your own organizational credentials, or you can do the same by going to powerbi.microsoft.com/downloads. Here you are going to select sign up for free and use your organizational credentials to sign up here. Then you're going to go to products, Power BI desktop, click on it, and then it'll open the Microsoft Store, and you can download it from there, or you have the download option right here at the bottom of your page. You're going to click on it and it will open the Microsoft Store. You'll see a button like this, an arrow and a line below it. You can click on that. You can get it for free. And then once the product is installed, you can go ahead and launch it. Then you have to click a couple of nexts, and that is how you will download Power BI Desktop. I actually wouldn't go through it and install it on this machine, as I've already got it. As you can see, it says the product is installed. But what you want to do is click run, and a simple wizard will open up, and what you basically do is just click next several times and you'll be able to install the application on your machine. Okay, so I'll just go ahead and close this. And I'm going to open the Power BI desktop. And this is the Power BI desktop opened up. And when you start, you're going to get this bumblebee colored theme, yellow and black start screen. Here on your left, you have your Get Data button, your recent sources, and open other reports. Here you have a couple of tutorials which will help you guide you through how to use your desktop app. You can go to forums, read a couple of blogs, look at what other people are doing with Microsoft Power BI. And as I had mentioned before, if you do not want the screen on your startup, go down. I will uncheck this box and then you can close it. And now your startup screen will no longer show when you open up the application. So we'll go ahead and move on. So this is your Power BI desktop application, and I'm going to start by pulling in some data because this is Power BI and data visualization, and it's kind of very useless if you have no data. So we'll go ahead and pull some in. So I'm going to pull in a few Excel sheets. I'll go to Get Data here. And here you see the most common options are here. You have Excel, you have Power BI datasets, data flows, SQL Server, Analysis Services, CSV, Web, so on and so forth. So I'm just going to go down here and click on More just to show you the full list of options that you have to start out with this particular tool. Of course, you have your Excel, you have your text files, your CSV files, maybe XML. You have SQL Server, you have Access, you have a wide variety of databases. Here you can select Azure, you have Azure SQL Database, a bunch of other options. You have online services, you have Dynamics 365, you've got Facebook, Google Analytics. So now this is how your Power BI desktop's interface looks. This area over here on your left panel, if you can see where I am highlighting, shows the report, the data, and the relationship workspaces. By default, the report workspace will be open, which is this canvas looking thing right here. Below the report workspace is the data workspace, which is used to see your imported data set. And the last tab is the relations tab, which gives you the relationship between different variables in a data set. That is just in case you import more than one data set. On the right hand side, you will see your visualizations pane and your fields pane. So we are going to start out by importing data. So let us import a sheet. Here you will get the options for your most commonly used formats of spreadsheets. You have your Excel, Power BI datasets, data flows, SQL Server. But I just go down and click on More so you can see all the different options available to you. You have your basic Excel, CSV, XML, and JSON files. If you go to file types, these are the ones which you import from your system. Then you have databases, you have your SQL Server database, Access, MySQL, PostGRE, so on and so forth. Then you have Power BI's sample data sets and data flows. You can also connect to Azure. Here's a wide option of databases. You have your Azure SQL database, data warehouse, services database, so on and so forth. Then you can connect to online services. You have your Dynamics. You can even pull in data from Facebook. And here are a few formats of data which are still there in their beta phases, like Twilio, tyGraph, Web Trends, so on and so forth. And then you have your other data types. Apart from that, you can also connect to Spark, R, and your Python scripts and pull in data from there. So I'm going to go up and select Excel because my data type is Excel, but you can go ahead and connect to any data type that you want. Just going to go connect, and I have a financial sample. So I'm going to go ahead and add the finance data set. And it's going to lead you to something like this. It's going to show you a preview of what your data looks like. Then it gives you these options in the bottom. You can either choose to edit or load the data. I am going to load the data. It'll take some time to load the data onto your model. And with that, you are done. This dataset won't be needing any editing. But just in case it did, you could go right here to your data view and you can make edits to this dataset. It's always a good practice to name your columns according to what is contained in them. If you take a look at this data, you would understand it. It's a simple dataset about a few countries and their sales in general. On the right, you can see all the fields that there are in this particular dataset. So now what I'm going to do is I am going to go to my workspace and create a simple report. So the first step is to select a visualization. I'd be using a clustered column chart visualization. So it is this one right here. You can make it as large or as tiny as you want it to. I'm just pulling up the size so that it's easily visible to all of you. So now that we have selected a visualization, I am going to visualize sales and profit on the y-axis and the date on the x-axis. So I'm going to bring down the date to axis, which is my x-axis, and I'm going to bring my sales to the values field. Now you can even drag and drop these fields. Suppose I pick profit, I can just drag and drop it and it'll form a graph of its own. But that is a story for a different day. Now you can resize this visualization just how you want it. This is how I want it, so I'm going to keep it like this. Now I'm going to be making use of the clustered type and I'm going to bring in something else for the y-axis. So I'm going to bring in profit. So you can see that the black ones are the profit columns and the green ones are your sales columns, right? So you can also change the graphics based on the timelines just by clicking. I am going to be changing the yearly representation of data to the monthly representation just by crossing out the rest of the options. I'm going to keep it as month and I'm going to extend this graph so that you have better visibility. Also below the visualizations panel, you have this paint roller sort of icon, which is your formats tab. You can use different color schemes to make your visualization more appealing and insightful. I'm just going to go to data colors and change this green to, let's say, yellow to match the Power BI color scheme. I'm going to keep it that way. And this image shows how you can basically change the color of the fields used in the visualization. Apart from that, if we went back to this particular fields tab, you can perform statistical operations like calculating mean, median, sum, and even filter the data by various parameters using this tab. You can go down to filters. You have your visual level filters, page level filters, report level filters, and drill through. It will help you aggregate your data before you use it in any visualization. And with that, we have successfully created a visualization. Now, creating visualizations in Power BI is as simple as this. You could either drag and drop. Because this is a smart tool, it will 9 out of 10 times get what you want it to. But for the remaining one time, you can always use the Fields tab. So I hope by now you might get comfortable with the idea enough to create visualizations on your own. I'm going to show a few other visualizations, so it will help you get comfortable with it. Now we have this. I'm just going to move this down here and show you some other fun stuff. So let me put in a pie chart over here. Let's see what we can do. I'm going to put in the different countries and let me put in the sales values. And it will show me Mexico, Germany, France, Canada, and the United States and how much sales have they gotten through the years. I can also click on each of this pie and see the value of the country's sales being reflected on this other graph. And this is called cross-highlighting. Now let's see what else. Now you can also use a tree map. So I'm going to go ahead and do that. And get your country and sales. Your tree map is basically like your pie chart, but it's much easier to visualize as it is more organized. And this is just about 5 countries, but if you had more countries, a pie chart wouldn't be of much help. In such case, you are going to be using a tree map. So you can choose the visuals that suit your requirement and experiment accordingly. There are a lot of visualizations to try and experiment. Also, when it comes to visualizations, no two individuals visualize data in the same way. So your reports may turn out differently than mine. But Power BI helps you create and edit reports according to your comfort and ease. Now here's a few tips before you get into visualization. For that, I'll have to go to this data view. First thing, you have to name the columns because you're building dashboards for a user. And all the naming conventions and data types are going to appear at the surface to your user, and you want it to be as interactive as possible. So if there's a column which has names of countries, name it country. If a column which has names of products, name it products. Units sold, manufacturing price, sales price, every column name should give you an idea of what is there in that particular field or column. Second thing, anything that's not absolutely necessary in the model, delete it. As you can see, I'm going to be using every possible detail that is there in this data set. If I had blank values or null values or a column which I was not going to be using, I would have deleted it by now. Because that's going to contribute to the size of the model and take up way more system resources while processing. Here I have nothing to delete, but I think if you do have columns to delete, go ahead and delete them. This practice might not seem that useful, but trust me, it is one of the best practices to own. Another thing I'll be doing is data types. Numbers have to be numbers and geographical data has to be geographical data. So go up to modeling and select the column country and change the data category from uncategorized to country. That way, Power BI knows what kind of data it's actually dealing with. So this looks good. And once you're done with all these transformations, you're pretty much good to go. Another good practice is changing the name of the page. Again, the same theory of renaming columns is renaming your sheet names. So I'm going to name this Introduction because that is what it was. It was your introduction to using Power BI Desktop. Let us now move ahead and take a look at one last topic before I conclude the session. So we are going to take a look at this use case and understand how Wirepass used Power BI to visualize a massive amount of sensor collected data quickly, easily, and effectively. Now, Wirepass focuses on providing the most reliable, optimized, and scalable device connectivity to its customers. With Wirepass, customers can digitalize their current business processes and innovate for new disruptive models. It also has its headquarters in Tampere, Finland, and offices in France, Germany, South Korea, and the United States. It was established in 2010 in Tampere. Now, it's a big company. What challenges did it face? Now, Wirepass technology collects a wide variety of data through its connectivity service. Every wireless device built on Wirepass software technology can collect and send a huge amount of data. Now, this data is collected in several ways and then stored in a database. Visualizing this data is key to getting an overview of the current state of things tracked by the technology Wirepass. Now, there were a few obstacles to overcome. The data was collected from millions of sources and in different formats. There was difficulty in displaying the large sensor data collected for a parcel tracking service, finding which parcel was at what location and when. And finally, what was the parcel status and how could end users understand the collected IoT data? Wirepass used Power BI to overcome all the above mentioned challenges. So let's go ahead and look at their approach. First, they acquired the data. The data that was imported from different sources in different forms was cleaned up using Power BI and Query Editor. Second, they designed the report using Power BI Desktop. Now, after importing and cleaning up the data from 1 million sensors, Power BI was used to design a dashboard that enabled the customers to get overviews of all the data and enable them to drill down to one single parcel and the parcel history. Third, they created a Power BI workspace. Now, to create the Power BI workspace in Azure, the Power BI CLI was used. Back then, there was no UI available to create workspaces for Power BI in Azure. Therefore, they used the Power BI command line tool for managing Power BI embedded workspace collections. And finally, what they did was they embedded Power BI in a web app. Power BI Embedded enabled developers to embed reports in almost every kind of app. This was the easiest way to embed the report into a website. And the architecture you see right now was used to overcome the overall problem. So first, they acquired data from .csv files for online customers. Second, they acquired data from SQL Server on-premises of the customer, not public. Third, they performed ETL on the data they had. Fourth, they designed reports on top of the data they had. Fifth, they created a Power BI workspace. Sixth, they uploaded the .pbix file. And finally, they used the Azure App Service and embedded Power BI to host the report. In conclusion, I would like to say that this was a smart way for Wirepass to bring their IP to the cloud in an easy and fast implementation. The whole project needed limited calling time, consultation, and implementation. For a Bosch connected world, this was an easy demonstration of the complex data based on Azure and Power BI embedded. Since the workshop, Wirepass has won several new customers who are using its products and dashboards powered by Power BI embedded. If you need a detailed understanding of this use case, you can refer to a link which I will leave in the description box below, which will direct you to a page where you can actually see the use case study. Now that we've come to the end of our demonstration, let's take a little look at the Power BI experience with Edureka. Now, as most of you might know, the job vacancy trend of Power BI is on the rise. Microsoft is recognized as a leader in the Gartner's Magic Quadrant for Analytics and Business again this year. Cognizant, Dell, KPMG, Hitachi, and over 45,000 MNCs across 185 countries use Power BI. And not just that, these professionals earn up to a lucrative $114,000 per year according to PayScale. Now, the Microsoft Power BI training at Edureka helps you achieve expertise in business analytics. At the end of this course, you'll master concepts like Power BI Desktop, Power BI DAX, Q&A, content packs, custom visuals, as well as Power BI integrations with the Azure machine learning and SQL services. This training introduces you to Power Pivot for data modeling, and this course helps you explore and visualize enterprise data using natural language. Not just that, here you learn at your own pace in your own time from a location at your choice. It helps you get completely industry ready by the end of your training.
It's time for a quiz question. What is the Power BI primarily used for? And the options are A. Data storage, B. Data visualization and business intelligence, C. Email communication, D. Project management. If you know the correct answer, please leave it in the comment section below. In the previous module, we covered the introduction to Power BI, including its components, architecture, and key building blocks. Next, we'll explore how to build Power BI dashboards, where you'll learn how to create interactive and effective dashboards to visualize your data.
A Power BI dashboard is quite simple to understand. It's a single-page story that is connecting multiple data sets, making it visually and conceptually meaningful. This one-page visualization in a dashboard is also known as a canvas. Dashboards gather data from multiple sources and systems, then combine them into a single interface for a detailed overview of the business. So to simplify, a single page visualization with multiple charts and graphs to tell a story is called a Power BI dashboard. Let's take an example to understand it more clearly. Suppose a business organization wants to gain profit more, so it can use customer segmentation dashboard. These types of dashboard will give the business organization a view of their customer details like most customer gender or age range to target in such an intelligent way that helps them to take beneficial decisions right away. They can share the dashboard with other departments like finance in a customized way that can ensure organization most precious asset, that is data security. Why are dashboards powerful? Number 1, data transparency. Data is any company's most important asset. However, it's of no use if no one can understand or access it. A well-designed dashboard provides on-demand access of important metrics. Number 2, access to data. A dashboard gathers multiple data sources, including Excel, into a single interface, meaning to see a detailed overview of your business in one quick glance. It reduces time to compile reports, so overall saving your time. Number 3, interactivity. Some of the best dashboards provide a dynamic experience rather than a static, boring information. You can filter data, interact with charts to see changes over time. This means that you can get as much or as little detail on specific metric. Better decision making. Dashboards provide an unbiased view of each department. So each department can have access to the dashboard and can provide a foundation for further dialogue and great decision making. For example, the sales and marketing department can align their data and experiences to increase customer acquisition and improve demand generation. Hands-on on creating a Power BI dashboard. Now here we are going to create a Power BI dashboard, but number one thing to be remember is we cannot create a dashboard in Power BI desktop. We can create a report there. So first step to do is to create a report. We have this following things going on in the Power BI desktop. Here is where we create the visuals. Here is where we can see the data. And in this segmentation, we can see the data relation. So the lookup table, the center table and everything. So that helps to understand the data. And here we can see the data in an Excel format. So you can see and analyze data. And here is where we are creating the visualization. So first you need to get the data. So here you can see there are many data sources. Although I'm going to be using Excel, but I want to show you there are so many data sources you can connect to. So data sources, there can be a lot of data sources like Azure, database, Power Platform, online services, and lots more. So you can connect to them and then create your visualization. I have my database already, you can see. So first I'm going to choose my chart that I want. So I want KPI and I'm going to take sales, and for the trend axis I'm going to take date. So as you can see from this visualization that the area chart in the background represents trend of sales over time. So the back of there you can see this is the trend of sales with time, and the figure that is 12 million is the sales for the last month. So you can resize your visual according to your theme and your choice. Also what you can do is you can take advantage of format your visual and you can change the call out value for the 12 million. So I'm going to change it to purple color. You can see I've changed it. It's just for the theme for your report and just to keep it aesthetically pleasing. So right now, after creating one chart, I'm going to show you how I create even more. So right now I'm going to go back to build visual and going to choose pie chart. And for the pie chart, I'm going to take discount by month name. So Okay, so this was actually sales with date. I can just go back, let it be KPI format only. So if you click the visual, then if you choose any visualization, you can change it. Definitely you have to click back and then choose another chart. So I'm going to choose pie chart and then take discounts by month name, and here is my discount by month name. I can resize it, I can change the font color or anything. And now let's create even more visualizations. So let's take the scatter chart, and for this you can see the x-axis, y-axis, legend. I'm going to choose profit for x-axis. For y-axis I'll choose discounts. For the legend I'm going to choose product, and for the size I'm going to choose gross sales. So here you can see I have created this bubble chart, or you can say scatter chart. Going to resize it, and then that's how we are creating our visuals. You can create even more. Let's take line and stacked column chart and select country and gross sales. So we have our scatter chart. You can change the colors of it according to your theme. So suppose if you have yellow and black theme going on, then you might want to stay in a yellow and black theme. Although I have a colorful theme, so I would keep like that. It's just for aesthetics, and it's great if you have good aesthetics to your dashboard and reports. Now, after creating that, what we are going to do is we want to publish this report. So after you are done importing your data set, then choosing visualization, x-axis, y-axis, and then we are creating so many visuals. And then I'm going to show you a cool feature that we can do here is if you click on any single segment on this, every other segments of the other charts are going to correlate with that. And this process is called filter. This filter can only be done on reports. We cannot do it on a dashboard. So if you click on any segment, you can see how it's correlating with other data. So you can play around with the data, understand the data even more. It's quite interesting to do, and it's visual, so definitely it's easy to do. Very easily you can understand the data and how it's going on, and the modeling aspect of it as well. Now after this process, what we want to do is just double click on any chart, then you'll be back to your default. And after creating our visual, we want to publish our report. So all you have to do is click on the publish in the home button, and then you have to click on save, and then just give a name to your report. So I'm going to give it new report, and then save it. After saving, you have to choose your workspace where you want to publish it. So I'm going to choose my workspace, and then it's going to publish it. So what's happening here is the online Power BI service is uploading my report in the cloud. So I'll be able to use it. So here you can see a link, right? If you click this link, then you'll be directed to the online Power BI service, and you'll be able to open your report there. But one thing to remember is you need to already log in into your account. If you don't do that, you won't be able to access the report. This is just for the security aspect. Now, just because we are talking about this, I also want to mention the fact that why we are using dashboard, why not report? Because as you can see, our report has almost same aesthetics and look, meaning like dashboard. Then why are we using dashboard? So you may want to share your file to your colleague, but if we share our report, they have access to the data and then can make changes. So in other words, there is no security. So the best way to share your report is via the PBI service, that is the Power BI service. And to do this, we need to be logged in into our Power BI account in Power BI desktop. Then on the home button, we have to click publish and then select workspace. So what happens in this process is Power BI is uploading the data up to the cloud in Power BI online service, and you have to click on the link to open it, and you will be able to see your report in Power BI browser. And here we are. So I'm not going to click the link because it will take me to a browser where I'm not logged in. As you can see, it will take me to app.powerbi.com, which is the correct website for the online Power BI. But since I'm not logged in here, so I won't be able to access my report. See, I won't be able to access my report. So what I'll do is I'll just go to my browser where I'm logged in, and I'm going to show you where is my report now. So this is my account. I'm logged in here. It's very important you to have an account here. And then when I click my space where I actually published it, you can see new report. This is my report which I created. And if you look at the report, you can see it's as it is as what I created on my desktop, right? There is no changes. So this is my report, but I am in the online Power BI service website. And right now I'm going to show you how I'm creating dashboard with this report. So I hope you understood how we are publishing the report and how our report is getting directly accessed in the Power BI service directly by using a link. Now after this point, we are going to talk about creating a dashboard. So to create a dashboard, all you need to do is you can just click on edit on your report, and then you can change the visualization for any chart according to your choice. But if you don't want to change any visualization, you can let it stay like that. You can do a lot of things here as well. So after this point, what we want to do is we want to pin the chart. So here you'll see an option, right? This pin visual. So I'm going to click this and I'm going to create a new dashboard. If you already have any existing, you can go ahead with existing. So I'm going to name it It's New. Okay, so this is my dashboard and I'm going to pin this. Again, I'm going to pin more visuals here. So I'm going to pin this one as well. I'm going to pin this one as well. And this gauge visual as well. So after you're done pinning the visuals, you just go to your dashboard. You don't need to make any changes to your report and you will be able to see your visuals, right? So here are your visuals. You can resize it according to your theme to make it more aesthetically pleasing, and it just helps you to make your dashboard more interesting. So here I'm going to resize it. And you can easily align it. There are so many advanced options to align it, and that's how I'm creating my dashboard. All right, so this is my dashboard. Now what I'm going to show you is some cool features that you can play around with your data on online Power BI service. So after creating the dashboard from the report, you might want to share your dashboard. So all you have to do is click on share, and then you have to enter the name or email address of the user, and then you can choose the options what you want to do with your dashboard. So allow recipients to share this dashboard. If you want them to share, you can check it or else uncheck it. So these are the options. And allow recipients to build content with the data associated with this dashboard. If you want the user to do this, you can let it be checked or else unchecked. But make sure that whomever you're sharing this dashboard with, they have online Power BI account, right? That's most important because there is some security aspect to it as well. So that's what the great thing about online Power BI service. So after sharing, I want to show you some cool features of online Power BI service. So first thing that is very good about it is the Q&A. Okay, so here you can see ask a question about your data. So this Q&A feature is very interesting. All you have to do is write a question. Probably I'm going to write total sales. So I want to know the total sales. So I'm going to enter that, and you can see there's a figure, right? So I don't have to understand the data model, the structure of the data and everything. I just have to write the question and I get the accurate direct answer to it. So that's pretty cool, and it definitely allows you to get quick answers to your questions without understanding the visualization or model structure. So definitely. Now another cool feature on the online Power BI service is that the quick insights. So for the quick insights, all you have to do is go to your workspace, and then whichever report you just created, you have to right click on that and you have an option called Quick Insights. You have to click on Quick Insights. So let me tell you what Quick Insights does. So it shows us unfamiliar data undiscovered data. It runs a sophisticated algorithm against your data set. So definitely things that we might not able to see are important. Quick Insights does that for us. So why not? It's a very cool feature. You can see there are so many data that actually we didn't create on our visualization, but these are so important. So Quick Insights does that for our report. Now we are going to be talking about how workspaces separate insights of report for each group. So workspace is another tool which is very interesting, helps us to do a lot of cool things like specifying the group. So let me tell you what it is. So workspace are where you will place your reports based on who you want to see it. So in other words, they are a group of certain people who will see certain piece of analysis. So some insights might only be for specific group. Workspaces can separate these reports for each group. So what you have to do this is go to workspace, create a workspace, and then you have to upload a picture for your workspace. Then name your workspace, give a description for what we can do here, and then save it. So that's how you're creating a workspace. It's quite great tool because it's actually specifying the department. Suppose if I only want my dashboard to be seen by the accounts department because it's all related to accounts, then I'm going to do that. The workspace helps me to do that. Now we are going to talk about how to direct access a user on workspace. So yes, this is another important thing that we can do on the online Power BI service. All you have to do is go to your space. I'll go to my space, and whatever report I created, right click on that and then manage permission, go to direct access, add user, and then you can name or write the email address of the user who you want to give access to. And you can also check and uncheck these options according to your choice and then grant access. So this is yet another amazing feature on online Power BI. So these are the things that we can do definitely. And now I'm going to show you the PPT to summarize it to you, that what we did right now on the hands-on, so you get an idea what we need to do, but in a summarized way. So as I showed you on the hands-on, how to build a report. So on building a report, first is you have to import data set in Power BI desktop. And to import data set, all you have to do is select your data set, choose your data source like Azure, Excel, etc. And then you can see the data modeling where we can see how data is related to other data like, the lookup tables. And then make changes to data. You can do some query change and etc. So yeah. And the next step is build visualization using dataset. So you have to choose visual. As we saw in the hands-on, we choose probably a KPI and then select x-axis and y-axis, or we can see the trend axis with that, like sales by date, and then apply visual. So we click on format visual. Here we have choices to change the font color, font size. We can do a lot of things there. Suppose we have a bar chart and we want to change the color of it to match with our theme. As I said, our visual has to be aesthetically pleasing. We can do that using format visual. Now the next is resize the visualization. So definitely this is very important in the process of building a report, because if you don't resize your visualization, it might look less pleasing aesthetically. So we need to follow the alignment, follow the theme, follow the order for that. And the last step to build a report is publish your report. So you have to select publish from the home tab and then select destination, the workspace where you want to publish. And then you get a link, right? And if you click the link and you already are logged in into your account, then you can open your report directly from there. But if you're not logged in, you have to log into your Power BI online service and then open the report, as I showed you in the hands-on example. So these are in a compressed way how to build a report. So it's what we discussed right now. And then we are going to talk about the difference between report and dashboard. So first is dashboards are one page, report are multiple pages. Dashboards has single or multiple data set, report has single data set. Dashboards can't be filtered, report can be filtered. As we saw in the hands-on, how we can click on one segment and other charts are also correlating with that each segment. So definitely it can't be done on the dashboard, but can be on the report. And the last is dashboard is not available in Power BI desktop, but report can be done in the Power BI desktop. So how to publish a Power BI report? These are the steps in a compressed way. We have to publish from the Home tab and then select our workspace, log into Power BI Online Service, and then from there we have to open our workspace in the online service and then open the report. Why share dashboard, not report? As we saw in the hands-on example, sharing a dashboard can be a risk to the data for a company. So for any organization, their data is their most precious asset. So these are some points as to why share dashboard but not report. Number one is everyone you share it with can see your dashboard and interact with your reports, but they cannot save changes to existing reports. Everyone can see the changes that you make because we have this tool called refresh. If you make any change to the dashboard and refresh it, the other person whom we shared the dashboard with can see the updated changes. And number four is no one can see or download the dataset, which is a great thing for any organization since for them, their dataset is quite important. Now to summarize, suppose a business organization strategies for annual sales monthly wise. So first it's going to import Power BI report and then it's going to change visualizations as per choice. And then it's going to pin the tiles for the dashboard and then resize the tiles in their dashboard. So that's how they are building a dashboard and being able to strategy for annual sales monthly wise. Now these are some top features of Power BI service. As we discussed in the hands-on examples, the quick insights give us some unfamiliar and undiscovered data which are very important for an organization, and it's quite wonderful and cool tool to deal with in the Power BI service. And the next is raw level security. This is for the aspect where we want to share data to some aspect of the region and not to all. For example, if we want to share our dashboard with accounts department, so for those kind of customized security level, we use the raw level security. And number third is Q&A. Q&A is another cool feature where you'll be able to write your question and get direct answer to it. You don't have to understand the visualization or any model structure, but you will be able to get data from Q&A very easily. The next point is advantages of Power BI dashboard. So number one is it extracts insights and draw conclusion. So for the first advantage, as we saw in the hands-on example, business organization wants to check which month has the most sales. So it's going to look after the month-wise data and extract the exact month out of the data set and thus have a conclusion. Number two is visualization from multiple data sets. So how amazing it is to have an aesthetically pleasing visualized data from a bulk of boring data set and have a single page visually, smartly and aesthetically telling you a story. And third is easily connects to many data sources. We can connect to multiple data sources like Excel, Azure, databases, etc., which leads us to have visual representation of the data. Now we are going to be talking about some examples of Power BI dashboard, but before that we also need to know the disadvantages of it as well. So the three disadvantages we have is we cannot slice it, we cannot filter it, and we cannot make a dashboard in the Power BI desktop. However, we can create a report in the Power BI desktop. So these are the three disadvantages of the dashboard. Now here we are with the examples, which is very fun to look at. The first one is customer segmentation dashboard. So as we can see from the dashboard, we have profit, sales, total cost, order returns. So we can see the visual graph of sales by region, which gives us a brief idea about which region to target more. We have total orders by city and return. So these visuals helps the organization make vital business decisions. And the next one is sales analytics dashboard. So it evaluates profit, sales, performance, etc. Here on this dashboard, we have net profit, fulfillment, income and expenses. This is the same example we had in our hands-on example, just the same almost different terms. And the last one is the finance dashboard. We have cash balance, day pay outstanding. These all are finance related information and are amazing information benefiting to finance. That's why dashboards are very useful to any existing business organization. Why organizations use Power BI dashboard? So, marketing campaign insights dashboards are using dashboard to understand efficiency. Sales analytics dashboard are using it to understand the performance. Product sales dashboard are using dashboard to understand visualize the profitability, and email engagement analytics dashboards are using dashboard to analyze the data.
It's time for another question. Which visual component is used to filter data on a Power BI dashboard? And the options are A. Pie chart, B. Slicer, C. Table, D. Card. If you know the correct answer, please leave it in the comment section below. Having learned about dashboard creation, we now move on to Power Query. In this module, you'll discover how to import, transform and clean your data to prepare it for visualization.
In the Power BI desktop, a data set is basically defined by a single query that specifies what data to include and how to transform that data. Power Query is a data connection technology that enables you to discover, connect, combine, and refine data to meet your analysis needs. It basically helps you take your raw data source and convert it into something more usable, more workable, on which you can build your analytics and then draw insights from it. The query is made up of related steps that build on each other to produce the final data set. And once you've defined that particular data set, you can use it to create visualizations that you add to your reports, which then you can publish to the Power BI service. Now, the heart of the query is the Power Query M formula language, which is based off of a language called F#. And just like it, it is a case-sensitive data mashup language which is available to many of the Microsoft softwares, such as the Power BI Desktop, Power Query in Excel, as well as the Get and Transform import feature in the Excel versions post-2016. As with many languages, Power Query statements are made up of individual language elements such as functions, variables, expressions, as well as values, both primitive and structured, that together define the logic necessary to shape the data. Now, each query in the Power BI desktop is a single Power Query let expression. It basically contains all the code elements that are necessary to define your data set. A let expression is made up of a let statement and an in statement, as you can see in the syntax before you. So the let statement includes one or more procedural steps that define the query. Each of these steps is essentially a variable assignment that consists of a name as well as an expression that provides the variable's value. Pretty simple, that is what a variable is in most cases. It's 5th grade math, right? Variable is a name to which you assign a value. Now, this expression defines the logic for adding, removing, or transforming the data in a specific way. This is where you will be doing the bulk of your work, as you are going to see in the examples I'm going to give you later in this module. Now, the variable can be of any supported Power Query type. Each variable within a let expression must have a unique name, but again, the Power Query is fairly flexible about what you call it. Just make sure it makes sense and it's easy to remember for you. Now, you can include spaces in the name, but you have to enclose it within double quotes and precede it with a hashtag. Now, that is a somewhat cumbersome naming convention and one that I particularly prefer to avoid. It's honestly a mystery to me, even now, why it is the way it is, but let's just move on. Now, the variable names are also the same names that are used to identify steps in the applied steps section in the query editor's right pane. So I think it would be wise to use names that make sense. Now, strictly speaking, you do not have to define your procedural steps in the same physical order as the logical order. As in, for example, you can reference a variable in the first step of your procedure and then define it at the last step of your procedure. Now, this is something which is unlike the regular coding. However, this approach can make the code very difficult to debug, as well as cause unnecessary confusion amongst the coders. The accepted convention when writing a let statement is hence to keep the physical and logical orders in sync. Now, we spoke a lot about the let statement and none about the in statement. So a little input here. The in statement is basically like a return function. It returns a variable value that defines the dataset's final shape. Now, in most cases, if not all, this is most likely to be your last variable that you defined in your let statement. You can specify a different variable from the let statement, but there's usually very little reason to do so. So if you simply need to see a variable's value at any specific point in time, you can select its related step again in the applied steps section in the query editor. If you are not familiar with what it looks like, I'm going to show you in just a while once we open the demo machine. Now, when you select a step, you're essentially viewing the contents of the associated variable. With that, let's move on to our problem statement. Now, this session is going to include a number of examples that demonstrate how to define the procedural steps necessary to build a query. All of the examples are going to be based off of a dataset, the link to which I will leave in the description box below. Now, the dataset I'm going to use is the Titanic dataset, which lists the passengers on the infamous Titanic voyage. It basically shows who survived it and who did not. Now, if you plan to try these examples for yourself, you need to create a titanic.csv file from the dataset that I'm going to link in the description box below and save it to a folder that you can access from the Power BI desktop. On my system, I saved it to a local folder in my C drive. Now, understand what we are trying to do here is to make this particular dataset a little more usable for you to lay analytics on top of. Yes? So now let's move on to Power BI and see how to do that. So the first step into building your own Power Query script is to add a blank query to the Power Query desktop. Now, to do that, what we're going to do is we have this Get Data button on the home ribbon in the main window. So I'm going to click on that. All right. Then I am going to navigate to the other section. And towards the very end, I'm going to find this option called a blank query. So I'm going to double click on this, or you can even click on connect. Now what it does is that it launches this query editor with a new query listed in the queries pane on the left. Now it's conveniently named query 1, or you might have a similarly numbered name with a different number depending on how many queries you've created. Now to rename this query, what we're going to do is we are going to right click and select rename and maybe give it a fitting name like survival log. Okay. And then we are going to press enter. As simple as that. On the right in properties, you see the name has changed, which earlier was query 1. Next, let's go to the view menu. It opens up this ribbon and then click on advanced editor. Then it opens the advanced editor. Now, as this editor opens, you can see that there is a new let expression here, which is already defined. The let statement includes a single procedural step in which the variable is named source and the expression is an empty string. As you can see, it is indicated by double quotes. Notice that the variable is also listed in the in statement, again, source. And if I move this advanced editor a little to the left, you can see that the variable is even listed as a step in the applied steps section. Now, this is the part I was talking about earlier when I talked about applied steps. Now, this is that section. Here you can see all the steps that have been applied to your query editor, and you can click on each step to see what that variable holds. Now, for this exercise, we'll be changing the variable name to get passengers. So the first procedural step that you'll add will retrieve the contents of the titanic.csv file and save them to get passengers variable. Now, to add the procedure, we are going to replace the current let expression with a different one. Notice that this get passengers variable is specified in the procedural step in the let statement as well as in the in statement. Now, in this way, the variable's value will be returned when the let statement runs. It's as simple as that, as I had earlier mentioned, that the in statement is basically like a return function. Now, this expression in the procedural step includes everything after the equal sign. The expression uses csv.document as a function to retrieve the file's contents as a table object. It supports several parameters, but only the first one is required to identify the source data. As a part of the first parameter, you must also use the file.contents function right here to return only the documents data. And here you can see the location of my dataset. As I had already mentioned, it is saved in my C drive in a local folder called data files, and my file name is titanic.csv. Now, the second parameter can be specified as a record that contains optional settings. So in Power Query, a record is basically a set of fields which is made up of name value pairs enclosed in brackets. Now, the record in this example includes a delimiter and encoding options for the values. Now, the delimiter option specifies a comma, as you can see right here, as the delimiter in the CSV document, and the encoding option specifies the text encoding type 1252, as you can see right here. This is basically the Windows Western European code page. Yes? And that's all there is to know and all there is to setting up a basic let expression in your Power Query. After you've entered your code, click on Done and close the advanced editor. And as you can see, that has run the procedural step, and the data set appears in the query editor, and it should look similar to what you can see right now. It's got a couple columns, it's got the survived, it's got names, it's got sex, age, passenger class, so on and so forth. Notice that the first step in the applied step section is now named get passengers, which is the same as your variable name. The procedural steps expression is also displayed in the small window above the data set right here. Now, you can edit the code directly in this window if you want to. Whenever you add, modify, or delete a step, you should apply and save your changes. A simple way to do that is to click on this little save icon at the top left corner of the menu bar. When prompted, if I click on this, I will be prompted to apply my changes. And here I am going to click on apply. And with that, my query is saved. Moving on, another important thing is removing a column from the data set. Now, the next procedural step that you are going to add to your let statement basically will remove your duplicate column or column 6 from your data set. Now, because your data set is saved as a table object, you can choose from a variety of Power Query table functions to update the data. For this step, you'll use something known as remove columns function to filter out that specific column. So again, I'm going to click on the advanced editor and I'm going to get back to the query. Now, basically, to remove the column, I am going to add a comma, give a space, and on a new line, I'm going to define the next variable or expression pair. Now, to remove the column, add a comma after the first procedural step, and then on a new line, define the next variable expression pair, as you can see on your screens. The table.remove function requires two parameters. The first parameter specifies the target table that you will be updating, which in this case is the getPassengers variable from the previous step. Second argument specifies a single column or a list of columns to be removed. This example specifies only column 6 from getPassengers table. The important takeaway here is how the second step builds on the first one and then returns a new result, which is assigned to the removeCalls variable. The new variable contains the same data set as getPassengers variable, just without the column 6 data. After you add this particular procedural step, replace the getPassengers variable in the in statement with removeCalls variable, and next click Done to close the advanced editor. You can then save and apply your changes. Your data set now should look something like this with 5 columns only. As you can see, the removeCalls step has been added to the applied steps section as well. And column number 6 is no longer included in the data set. To add more procedural steps, we follow the same logic as here, continuing to build on our growing foundation. The next step is to promote the values of the first row of your data set to the header row. So these values become the column names. So to carry out this step, again, go to the advanced editor. Now to carry out this step, add a comma after last step that you defined, and then on a new line, you can put the expression in front of you. This expression uses the table.promote headers function to promote the first row of the column headers. The function's first parameter is required and specifies the table to use as the source data. This is just like you saw in the previous example, in which the new step builds on the previous step. The second parameter, promote all scalars, is optional but a good one to know about. By default, Power Query promotes only text and number values. When promote all scalars parameter is included and set to true, Power Query promotes all the scalar values in the first row to headers. The expression results are assigned to the promote names variable. Be sure to update the in statement with this variable name. Again, I'm going to click on done. And as you can see, our entirety of first row has turned into this header row right now. The rename columns function requires two parameters as usual. The first is the target table, which is the promote names variable from the previous step, and the second is a list of old and new column names. This is a list of an ordered sequence of values separated by commas and enclosed in curly brackets, as you can see before you. It's this entire line. And in this example, you can see each value in the list is its own list containing two values, the column name and the new column name. So I'm going to click on done. And voila, you can see all the names have been changed. Now the next task is to filter out rows that contain not applicable in the age columns, and then filter out rows with age values 5 or less. Now because the age column was automatically typed in as text when imported, you will need to filter the data in 3 steps, starting with the non-applicable values. Now to filter out these values, you will need the select rows function. Now, this function returns a table that contains only the rows that match the defined condition, age not equal to NA. As you saw the previous examples, the function's first argument is the target table, which is rename columns from the preceding step. The second argument is in each expression specifying that the age value must not equal NA. The each keyword indicates that the expression should be applied to each row in the target table. As a result, the new table, which is assigned to the filter NA variable, will not include any rows with the age value of NA. Clear? Now, once you remove the NA values, you should convert the age column to the number data type so you can work with the data more effectively, such as being able to filter the data based on numerical age. While changing the type of the age column, you can also change the type of passenger ID column to an integer 64 type. This way, you're referencing to the IDs by integers rather than text, as you can see right here. Now, to convert to the new data types, you should use this particular expression. Now, this uses the transform column types function to change the data types. The first parameter is the name of the target table, which is filter NA, and the second parameter is the list of columns to be updated along with the new data types. Each value is its own list that includes the name of the column and type. Once each column has been updated with the number type, you can filter out the ages based on numerical value. Your dataset should now include only the desired data as it exists in the filter kids variable. Now, another handy transformation you might need to do at all times is to replace one column value for another. For this example, you will be replacing the 0 value in the survived column with no and the 1 value with yes using the table replace value function. Now kindly refer to the syntax that is shown to you and try to transpose the following elements that I'm going to discuss with the syntax on your screen. Now the table replace value function requires 5 parameters in total. First, you have the table, which is the target table, in this case, the variable from the preceding step. Second, you have the old value or the original value, which has to be replaced. Then you have the new value, which you will replace the old value with. Then you have a replacer that carries out the replacement operations. And finally, you have columns to search. Now, the column or the columns whose values should be replaced. Now, most of the parameters should be self-explanatory except perhaps the replacer parameter. For this, you can choose from the several functions that work in conjunction with the replace value function to update the values. In this case, the replace text function is used because text values are being replaced. So first, what we're going to do is that we are going to replace the 0 values with no. And after you replace the 0 values, you can replace the 1 values with yes using the same construction. Here you have your old value, which is 1, your new value, which is yes, the table, which is the replace 0 table, the replacer, which carries out the replacement function in the column survived. And then finally, I'm going to change variable at in. As you can see, I have changed the variable for replace 0 and hence all the 0 values have become no. Now let's go ahead and do the same thing for 1. And there we are. Now another way you can modify your column values is to change how capitalized they are. For example, you will update the values in the gender column so that the first letter of each of the words is capitalized rather than all being in lowercase. To make these changes, again, let's go back to our advanced editor, add a comma. Now again, this expression uses the transform columns function to update the two values. The function requires 2 parameters. The first is the table to be updated as usual, and the second is the list of operations to carry out. At times, you might need to provide additional information, but that's not the case always. For this example, there's only one operation, so you need to specify that the gender column and the text.proper function are enclosed in curly braces. The function converts the first letter in each word in the gender column to uppercase. At this point, your let expression in its entirety should look similar to what you see on the screen right now. The let statement includes all those steps and makes up your query to this point. Now, with each step building on the preceding step, let's click on Done, and you see the gender column with capitalized first alphabets. And on the right, you see the applied steps. And notice that the applied step section includes one step for each variable defined in the let statement. And all of them are specified in the same order that they appear in your statement. If you select a step, let's say this, the data displayed in the main windows will reflect the contents of that particular related variable. If I click on this, you see, we are back to the step where the ones were not replaced with yeses. Now, up to this point, each procedural step in your let statement represents a discrete action that is built on the preceding step. In some cases, however, you might need to structure your steps in a way that is not quite so linear. For example, you might want to create a calculated column that shows the difference between, say, a passenger's age and the average age for that person's gender. So for that, we need to first calculate the average age of the female passengers and save it to a variable, then calculate the average age of male passengers and save it to another variable, or you can do it vice versa as well. This is optional. Then you can add a column that uses the two variables to calculate the age differences and round the age differences to a more readable number of decimals. Now this step is purely optional. Now to carry out these steps, again, I'm going to put a comma, go to the next line, and add a couple of steps. Now this suddenly might have caused a lot of confusion. So what I'm going to do is I'm going to walk you through these steps in smaller chunks so you can better understand how they work. Now the first line, which is preceded by 2 slashes here, which says add calculated column based on average ages, indicates a single line comment. Anything after the slashes to the end of the line is purely informational and does not get processed. Power Query also supports a multi-line comment that begins with a slash and a star and ends with star and slash, just like the multi-line comments in the SQL server if you might be used to that. It's up to you whether you want to include comments or not. Whether or not you do, the next step is to calculate the average age of female passengers. So these are the two steps. The first step uses the select rows function to generate a table that includes only rows with a gender value of female. The function is being used here in the same way you saw earlier, except that different data is being filtered out and the results are being saved to female variable. Notice that the source table for the function is the change case variable from the preceding step. The second step uses the list average function to calculate the average for the age values in that particular table, which is the female table. The expression returns a scalar value which is then saved to the average female variable. The function requires only one parameter. The parameter includes a second function, which is the table.column, which passes the values from the age column to the list average function. All right, so let's run these two and see. Now you can see we have the average female age right here, which is 30.7, a lot of 2's and 1. Moving on to the next two lines. Now we're doing the same thing for the male passengers, and for this you can use the same construction with a few minor changes. Notice that you must again use the change case variable for the source table when calling the table.selectRows function. Even though it's no longer the step directly preceding the new one, you can in fact use any of the previous variables in your expressions as long as it makes sense to do so. With the average female and the average male variables in place, you can now also add a column using the add column function, which is this one. The table.addColumn function requires three parameters. The first is the target table, which is again change case, and the second is the name of the new column, of course, which is the age difference column or age diff. So let's run all of that and see. And now you can see the average male age is around 32 years old. Finally, let's run our add column variable. And if we go to the extreme right, we see our new column with age difference is right here. But then there is an issue, isn't there? Let's go back to the advanced editor. Now, as you can see, this particular argument, the third argument, is the expression used to generate the column's values. The expression starts with each keyword which iterates through each row of the target table. Now, this is followed by an if-then-else expression that calculates the row's value based on whether the passenger is male or female. If the gender value equals female, then the age difference value is set to the age value minus the average female value. Otherwise, it is set to the average male value. But as you saw, all the values are in negative and have way too many decimal values specified. So after defining the new column, the final procedural step rounds off the age difference values to 2 decimal points. The expression includes the transform columns function, which you saw earlier, but it uses the number round function to round off the values rather than changing their case. The number round function takes 2 parameters. The first value is an underscore, which represents the column's current value, and the second is the value 2, which indicates that the value should be rounded off to 2 decimal places. That completes the steps necessary to create the calculated column. Your let expression in its entirety, after you change this to round diff, your let expression in its entirety should look something along the lines of this. All right. It should look something like this. This code I will also leave in the description box below. I'm going to click on done. And here you can see the age difference in plus and minus, whether people go above the age average or below. Now notice that the applied steps section includes variables used to find the average ages, even though the add column step in the code builds on the change case variable. You can view the contents of these variables by selecting each step as I had done before. And if you select one of the variables used to store the actual average, the query editor will display it on its scalar value, as again I had shown it to you before, but again if I click on average male, it shows a scalar value. Now the query only shows the contents of the average male variable, a rather lengthy number, and now you can see why I included the final procedural step to round the values in the calculated column. Not surprisingly, there's much more to Power Query than what was covered in this particular module. But this should give you the foundation you need to start building your own queries in the Power Query desktop. It should also give you a better understanding of how these queries are constructed when using a point-and-click feature to import and transform your data. In this way, you can examine the code to better understand why you might not be getting the results that you expect. You can also start building your own query by using point-and-click operations and then use the advanced editor to fine-tune your datasets or to introduce logic not easily achieved through the interface version. To make the most out of Power Query in the Power BI desktop, you'll need to dig a lot deeper into the M language's various elements than what we've covered here, especially the built-in functions. Keep in mind though, the Power Query was built with Excel in mind, so you might run into elements that don't transfer easily to Power BI desktop environment. Even so, the basic principles that define the language and its syntax are fairly the same, and the better you understand them, the more powerful a tool you have for working with the data in the Power BI desktop.
Here is another simple question for you guys. Which function in Power Query is used to remove duplicate rows? And the options are A. Remove rows, B. Remove duplicate, C. Filter rows, D. Group by. If you know the correct answer, please leave it in the comment section below. With a solid understanding of Power Query, we'll next dive into data visualization using Power BI Desktop. Here you will learn how to leverage Power BI Desktop to create compelling data visualization and reports.
What is data visualization? Now, data visualization is basically the graphical representation of information and data. There can be many visual elements like charts, graphs, and maps. Here, data visualization tools really provide an accessible way to see and understand different trends that can occur in this data, or outliers and patterns. Anything that could be in this data could be visualized and found using data visualization tools. Now, in the world of big data, data visualization tools and technologies are very essential to analyze really massive amounts of information and then make some data-driven business decisions to help their organization. Also, with the technological revolution that's occurring, data really went from being expensive, difficult to find, and collect to abundant, cheap, but incomprehensible. It is audacious to store, understand, and analyze increasingly large volumes of data with traditional softwares and tools. However, as individuals or even as an organization, all of this data is only as good as what we can make out of it. And this is where big data comes really into the picture. It is used for predictive analysis, analyzing user behavior, or any other data analytics processes to bring value to the data that is present. Yet the raw details about this can remain uncertain due to lack of knowledge and lack of skills. Data visualization really helps to tackle this particular issue that we are facing. It is basically the process of transforming data into visualizations like charts, images, graphs, and even videos that really explain the numbers and allow us to gain some insights from it. So in short, you can say that it makes information more coherent and really adds value to it, discovers new patterns, spot trends, etc. Now, let me explain this with a really simple example. How do you explain the various rows and columns of data in an Excel spreadsheet to your boss or customers? You obviously will create a chart like, a line graph or scatter plot and even a bar chart of the same data. So what it really does is it gives meaning and purpose to the original raw data that was present initially, so that you have a visual representation of it and you can start analyzing it and integrating it with colors, and really integrating it with colors and giving more meaning to your data. This has really empowered many businesses and organizations by providing a much more clear and actionable insight to programs, as it can keep you ahead of the game. Let's move ahead and download our data set that we will be working on today. So for this, I'm just going to go to my Google search engine and I'm going to click on Kaggle. So Kaggle is a very big platform for people to work on various data sets, and people from all over the world upload their data sets that they work on. So you can download any of theirs and work on it in your own projects. So I just click the data option on the left hand side and I'm just going to scroll down. Today we'll be working on the COVID-19 data set. So we'll just download any of the data set that is available. Here you can see once I scroll down, so there's a separate option for COVID, and I'm just going to click the novel coronavirus 2019 data set. This has been uploaded by SRK, and I'm just going to scroll down and check out all of the available data sets. So you can see that there is one COVID-19 data set. There is also confirmed cases, confirmed US, deaths US, and finally the recovered cases. I'm happy with this data set, so I'm just going to download it. Because this is in a zip format, I'm just going to click on extract all, and I'm just going to click extract. So that's done. Okay, this is great. So I'm going to quickly move back to my Power BI desktop, and I'm going to click get data, and I'm just going to click text to CSV file. I'm going to click archive one, and I'm just going to upload the data set. The first data set is the COVID-19 data. Currently, this is a CSV file, and you can see that Power BI has prompted a window with all of the available data in the current data set. You have observation date, you have the state, you have the country or region, the last update, confirmed, deaths, and recovered. I'm happy with this data. I'm just going to load it into my Power BI. It'll just take some time to load all of the data. You can see in the field section, you have the data set COVID-19 data, you have the confirmed cases. So the various columns that were available, the confirmed cases, country, the deaths, the last update, the observation, the province state, recovered, and the serial number for each of them. So this data set is what we'll be working on. We'll just build some visualizations, some really simple visualizations, and we'll create dashboards. So this is just one data set that we'll be working on. Okay, so what we're going to do is we will learn how to create a few charts and understand how you can analyze the data. So we'll be creating visualizations now. So on the first page, let's create and work on bar charts. Okay, so what I'm going to do here is I'm going to select a stacked bar chart. That's the first icon that's available. And I'm just going to click on country or region. And I want to plot or view the confirmed cases of different regions. So I'm just going to track the confirmed field, and I'm just going to drop it in the values add data fields here. Okay. And what it really gives me is it gives me an overview of all the countries with the confirmed cases. As you can see, US is on top. So this is 2019 data. So that is pretty old data. We are in 2021 right now. So as you can see, back then, US was on top, followed by India, Brazil, Russia, France, UK, and so on. So these are all the confirmed cases. You can also really add filters. You can just scroll down. You can add is less than some certain number. You can see that there is so many confirmed cases, and the least is South Africa. So you can just add less than or greater than some certain amount, and only those countries which is greater than that number will be displayed. I'm just going to put is greater than some number. Okay, and I'm just going to click apply filter. Okay, you can see that the regions with values greater than this number will display on your bar chart. On page 2, so this is stacked bar chart that we've just worked on. In the second one, we'll create visualizations using line charts. So again, I'm just going to click a line chart, and I'm going to click the country or region because that's important. So I'm just going to click on province or state here now, and we'll check out the number of deaths, and I'm just going to drag and drop that in the values field. And you can see the number of deaths that have occurred in England, and then Maharashtra, Cambodia, Rio de Janeiro, Texas, Florida, and all of that is given in your line chart. Again, you can just add some filters if you'd like to. I'm not going to add any filters as of now, and I'm going to create a new page. So if you click on the three dots that are available, you can export data. You can show this as a table too if you'd like to. So that's pretty nice. And you can also sort them accordingly, according to ascending order, according to descending order. All of that can be done. So that's great. So if I scroll down, you can see the number of death cases in each of the state that is present. Okay. And I'm just going to click back to report. So this will just take me back to the visualization. Okay. Now I've created a new page, that is page 3. And here what we're going to do is we are going to create a pie or donut chart. Okay. So pie charts are quite well known. However, when it comes to displaying a lot of data, it is not recommended that one uses a pie chart because it can be really difficult to identify tiny differences between each of these categories. So what we're going to do here is we are going to click a pie chart. You can see the icon that's right here. I want to check out the recovery. So I'm just going to drag and drop this values here. And I'm going to click on the province and state. Okay. So as we've already mentioned, there can be a lot of problems using pie chart because each of these tiny differences cannot be figured out in a pie chart. So what I'm going to do here is I'm just going to look for states in India. I'm just going to look for some major states: Maharashtra, Karnataka, Delhi, Tamil Nadu, Uttar Pradesh, Uttarakhand. I'm just going to mention all of the states that I can remember from India. You have Andhra Pradesh. I've just picked up a few states from India and I have represented them in this pie chart. Now you can see that it's much more simpler, and you can see that Maharashtra has the most number of recovered cases, followed by Karnataka, then Tamil Nadu, Delhi, Uttar Pradesh, and then finally Uttarakhand. So it's pretty nice to represent tiny data sets in pie charts. You can also use donut charts if you'd like to. So I'm just going to click a donut chart. A donut chart is also a very pretty visualization that you can use. Moving on, you can use KPIs, that are key performance indicators, which are really a measure of the company's performance and it evaluates its success. We can display this in Power BI using the card or gauge. You can use the gauge or you can also use the card panel. So what I'm going to do is I'm going to create another page. So I'm just going to click on the gauge option, and what I'm going to do is I am going to add the number of deaths. Okay. So you can see that this is given in a gauge format. If you want it in a card format, you can just pick the card option. So these are the KPIs that you can work on. And now if you want to delete a chart, you can simply click on it and just click delete on your keyboard. If you want to add a new page, as I've already mentioned, you can just click on the plus icon. So now we will learn how to create a dashboard. What you can do is you can just copy paste all the visualizations that we've created so far onto the same page. And this basically gives a dashboard. That's how easy it is. Okay, and I can move this. So I can just click on the visualization, copy, go back to page 1, and then paste it. I can also resize each of these visualizations as I'd like to. And that's it. That's how easy it is to create your own dashboard. This is your dashboard on page 1. And you can also obviously change colors if you'd like to. So if you even want to change colors in your visualizations, you can do that. You can just go to this format icon and you can just click data colors and you can switch colors. Okay. We'll switch to something light maybe. Okay. You also want to change the colors in your legends of your bar chart. You can do that. you can just go to, again, the format option, go to data colors. So just click on for show all. You can see that different countries can be chosen with different colors. So you can choose France of one color, and you can represent UK in another color, and Colombia in another color, and so on. You can do that. And all of the changes will be reflected in your visualization immediately. Okay. So now what we're going to do is we're going to learn how to save. Okay. Just click on save, name your file as anything you'd like to. I'm just going to name this COVID-19. I'm going to save this file. And if you want to publish your work, you can do that too by clicking the file option. You can see the publish option, and you can just publish to Power BI. Okay. Here you have to enter your email address, and then once that is done, you can just publish it. So let's move ahead and check out one more use case of Power BI. So as in the case of most modern technologies, Power BI is also likely to embrace the law enforcement agencies, which are benefiting immensely with the use of big data analytics and other technological innovations. Power BI dashboards can be used very effectively to get insights into aspects such as deployment of personnel at critical locations during specific periods of the year by plotting various parameters such as the types of crimes that occur, the incidences, the crime patterns, etc. Like many of the factors and parameters can be involved in really finding the crimes that take place in a certain area. This is really helping the police and the other forces into getting a better insight into where crime can occur over a certain area and how it can be also prevented. So this is just one use case. Power BI can be used for many instances and many use cases to find and make better decisions in our daily lives and in our organization too, if you are working in any.
It's time for another question. Which visual in Power BI desktop is used to display trends over time? And the options are A. Bar chart, B. Line chart, C. Pie chart, D. Scatter plot. If you know the answer, please leave it in the comment section below. Having learned data visualization, we'll now move on to Power BI Charts Explained. This module will cover the various types of charts available in Power BI and how to use them to effectively represent your data.
So Power BI provides us the functionalities of multiple charts that we can use. So you will find bar charts, column charts, line charts, area chart, combination charts. You have pie charts, donut charts, tree maps, funnel charts, gauges and cards, tables and matrices. So there are lots and lots of visualizations that are available that we are going to explore now. So Sunit has a question over here. Same thing we can do using Excel. So what makes the advantage of using Power BI? So Sunit, so basically what happened is, like in Excel, definitely you can create the charts. The first thing is that those charts are limited. And second thing is, suppose if you have a raw data, right? And with that raw data, what you want to do is you want to create a quick summary report. So in Excel, first of all, what you will have to do is you will have to summarize the data by applying some formulas or by creating some pivot tables. That will be your first step. Then once your data gets summarized, then on top of that, you will add a chart in it, correct? So there are two steps in this. Once you summarize the data, and then you add a chart on top of this. Now that summary of the data will not be very quick. You will have to spend some time. You might have to do some calculations and formulas, which can take the process a little tedious. Now, if suppose in that report, you have to showcase 5 different charts. So that means you will have to create 5 summaries of the data, right? You will either create 5 pivot tables or you will create the formulas 5 times to first prepare the data and then create a chart on top of that. But all those hassles are not required in Power BI. You just have to select the chart. Aggregation and summary of the data is taken care of by Power BI automatically. You just have to select your calculation. Secondly, Excel cannot handle huge size of data, right? So you, like in Excel itself, you have a limitation of 10 lakh, or I will say 1 million rows of data. But Power BI can handle millions of rows without any challenge. Thirdly, if you will see, Power BI also gives you a lot of features of interactiveness. So you click anywhere on your report the data will get filtered across all the different charts. So Power BI offers you the option of interactiveness, which is not possible in the Excel. And also sometimes if you have to make some more advanced functionalities in the Excel, you might have to write some VBA codes as well, which can again take a lot of time. Now, if you compare both Tableau versus Power BI, right? So when we talk of Tableau and Power BI, so both are visualization tool. That is something that they have a common feature. So Power BI has an edge in the context. If I tell you, the first advantage that Power BI offers is it has data transformation capabilities, which Tableau doesn't have, right? So basically, for Tableau, if you have to do some advanced level of data transformations, you have to use another tool, that is Tableau Prep. But with Power BI, you don't need any additional tool. You can do all the transformations in your Power BI tool itself. Secondly, it is similar to Excel. So people who already have some experience and they have used pivot tables and all, so for them, learning curve of Power BI will be very less. They will be easily be able to learn it. The third benefit that Power BI has over Tableau is that is low upfront cost, right? So a license of Tableau costs you $70 per month, whereas Power BI costs you $9.99 per month. So if you see, the cost is also a very big role, something that impacts the use of the tool. So these are some of the features which make Power BI very much superior to Tableau, I will say, and make it that they have a higher edge over the Tableau, right? So visualizations definitely you will find to be similar in both the tools, and there could be certain visualization that you might be able to create in Tableau and not in Power BI, and likewise some in Power BI, not in Tableau. So those things are almost same on both the tools. Okay. So what we're going to do is we're going to explore this data plus visualizations, which makes it a complete Power BI tool. So let us see how you can create all these different type of charts very easily using the Power BI now. So I'll launch my Power BI tool. And also, if you will go by the latest trends also, like what something that I have observed is that now, the demand of Power BI has actually increased if you compare it with Tableau, and it has very fast, widely increased. So, as such, you don't need any language to learn, right? But yeah, if you know SQL, so that can be an added advantage. But even if you don't learn it, so it won't be a showstopper to learn Power BI now. And people, who might not have the Power BI with them. So this is the link from where Power BI can be downloaded. So if you scroll down, so you will find the option of download. So dataset that we are going to use over here, this is a Superstore dataset, in which what we have is we have the data like, when you go and do some shopping from any of the e-commerce platforms, right? So you do some shopping from Amazon or you do some shopping from Flipkart. So over there, when you purchase something, there is an order ID that gets generated. So on what date that order was purchased, what was the shipping date, what was the shipping mode, right? Who was the customer who purchased that order? So customer name, segment, country, city, and state from where that order was purchased, the postal code, region, and what all products did he purchase, and what was the sales value, quantity he purchased, and the profit. Now, this is the data that we have in this file. So we will be using this data to create some interesting visualizations in Power BI now. So if I come over here to the Power BI, when you launch it for the first time, so you might get this window coming up onto your screen, which may ask for sign in. So you don't have to worry to sign in something. You just click on this cross sign and the box will be closed. The next thing that we do over here is we have to load that data into the Power BI interface. And how do we do that? You just have to click on Excel, because the file that we are using over here, it's an Excel file. So I click on Excel, so as to load the data from there. And we go into that folder where that file is saved and click on open. So Power BI is going to create a connection with that file. This will just take a while to do that. So if you see now, the connection with that file has been created. So we will be able to see all the sheet names that we have in the Excel. Just a second, I think the file just got stuck. I'm just loading it again. Yep, so here we are. So orders. So once you select that file, you just have to click on load and the file will be loaded in your Power BI interface. And actually I've now closed the unnecessary documents that were opened up. So it speeds up the process. So now what we do is once the data is loaded now, right? So when you come in this Power BI interface, so you will be able to see all the fields on the right hand side. And this is where you will be able to see all the visualizations that are available in Power BI, which we can use. And if you come on the left hand side over here, you will find there's a section, this is a report view, right? So currently we are in the report view where the visualizations will be created. And the second is, this is your data view, right? So data view is something where you can have a complete preview of the data that you have loaded in the Power BI, right? So order ID, order date, shipping date. So you can see complete information and complete data over here. You can't edit the data, you can't modify the data. You can just look at the data, and if you want to filter it out, you can do that. The third tab that you see over here is the relationship view. So relationship view means where if suppose you have a data, right, where you are loading the data from multiple files. So you can use this option to create the relationships between them. But right now we don't have multiple data sets. So we are going to jump back to the report view where we will be creating our visualizations. So in order to build the visualizations, you just have to pick up the chart from here and you will be able to create it. Suppose if I pick this chart over here, this is the clustered bar chart. So just click on this and you will notice that clustered bar chart, structure of a clustered bar chart will come up over here. So please everyone pick this up. So now what we do is we are going to make this chart. So when you select this chart from here, you will observe the options get activated below this chart now, right? So what I do is I'm going to pick category and I'm going to put it on the axis. So when you put that category on the axis, you will notice you can see the category name over here. Then you pick up the sales and put it in the values. Okay, and you can see over here that these are the three categories that I have: technology, furniture, and office supplies, and we can see the sales across them, right? So this is a normal bar chart that has been created where I can easily compare the sales across the three categories. Okay, now what you can do is over here, let's pick up the field of region and I'm going to put that up into the legend, and the chart is going to split into 4 of the regions that we have in the data. So I can see that what was the sales in technology in central region, east region, south region, and west region. So I can see that split across the regions now for the three categories that we have. So it becomes easier to compare now, right, in which region which category had the highest sales. So this is basically called as a clustered bar chart, right? If you want to modify this chart, you can click on the other chart. So this will become a clustered column chart. So difference between a bar chart and a column chart is this: bar chart is where you have the horizontal bars, and column means these are vertical. So that is what you have as the difference between the bar chart and a column chart. Now likewise, if you come over here, so we have seen bar and column charts over here, right? So these are two charts. Then you can create line charts and area charts. So why do we use line charts? Line charts are used to see the trend over a period of time, right? That is where we use the line charts. So for example, if you come over here now, this is where you will find the option of line chart. If you click on this line chart, the empty structure of this line chart will come up, right? Now on the axis, we are going to pull the field of order date, and then we are going to pull the field of sales now. If I put the sales into the values, you will notice a line chart will be created right away where I can see what was the sale generated in 2014, 15, 16 and 17. So I can easily analyze that the sales have increased over a period of time. Okay. And with these charts, Power BI also provides you a lot of options to do any of the customizations if you may want to do on these charts now. So when I say customization, customization means if you want to change the color of the line, you want to change the color of the bars, you want to add some background color, titles and all. So all those things are very easily possible with the help of Power BI. So if you click on this option of format, so with this, I will be able to do all those changes. So for example, if you want to change the data color, so you can change the color from here and you can choose any color of your choice. Likewise, if you come down, you want to turn on the data labels, you can do that. You can show the data labels on the chart. If you want to change the shapes and all, so you can do that as well, right? So if you scroll down, so Power BI will give you lots and lots of options to customize the chart. You want to add some background color, so you can just select any of the color of your choice and you can play with the transparency and make it light and dark. So you can see the background colors can be applied on these charts very easily. You can apply the borders around the chart. You just need to turn on the border and the border will be applied. You can give some shadow effects to the chart. So here you can see a shadow effect has been given in this chart over here. And if you want to replicate the same thing, the colors of this chart to this chart, so just select the chart and click on Format Painter and click over here, and you will observe those changes will be replicated over here. So this is how you create a line chart now. Now, similar to line chart, we have one more type of chart that is called as an area chart. So if you click on this area chart, not this one, so just make sure this line chart is selected. If you select the line chart and you click on this area chart over here, right? So you will find this chart over here, area chart. So if you click on this, the chart will get converted into an area chart now. So the difference between a line chart and an area chart is that line chart gives you a single line over here, whereas area chart fills the bottom of the chart with the color, so it looks a little more occupied on that chart area as compared to a normal line chart. So this is what an area chart looks like. If you want to add some more data in this, you can do that as well. Suppose you want to convert it back into a line chart and you want to split this data based on, say, suppose the segments, right? So you can pick up the segment and you can put it in the legend. So you have an option of legend as well in the line chart. And now you see there are 3 segments in the data. So we have consumer, corporate and home office. So you can see for all the 3 segments, 3 different lines have been created over here. Right, so we can see the 3 different lines, one line for each of the segments, and from where we can see, like, on a basis of trend, both the 3 categories had an upward trend, but in terms of sales, the consumer is the segment which has generated the highest sales over a period of time, right? So see, there are 2 things that you all have to focus upon. So when we are building the charts, it is not just about the technicality that what chart we are creating. We also have to keep in mind and we have to understand that any chart that we create, it should have, it should suffice the purpose. It should be able to tell you what analysis or what inference you are getting from there, right? So that is very, very important. So if you see from here, I can see the trend that how the sales have changed over a period of time for the 3 different segments. Now what you can do is you can add pages in the Power BI. So if you feel you want to add more charts, you can click on page 2, this plus sign, a page 2 will be added. Now what we're going to do is we are going to explore some of the other charts, which are like combination charts and ribbon charts. So let's try to see what are they and how do we use them. So this is where you are going to find a combination chart, right? This and this. So combination charts are something, which have both line and a bar chart in them, and we use them to analyze more than one value, right? So like in the previous charts, that we created, we were only analyzing the sales, right? Sales over a time or the sales in comparison to the categories. But suppose you want to compare two things. So let us see that. So we will click on line and stack column chart. Okay, so this is where this chart comes up. Now on the shared axis, suppose I put the category. I put category on the shared axis. Okay, now I want to show the sales. So sales will come in the column values, and you can see a bar has been created, and we can easily compare the sales of the three categories. And if you pick up the profit from here, and let's put it on the line values. So you will observe there is a line that has come up now. So I can easily compare that what is the how the sales that were given by the three different categories, and with the help of the line, I can I can analyze what was the profit that was generated by the three categories. So I can see the lowest profit was given by furniture, and if I see talk about the profit over here, so it was very high for office supplies and it was the highest for technology. So I can compare two things in one chart, that is sales and profit. And again, if you come into this formatting option, you will be able to do a lot of formatting options over here. So I'm just trying to show you one. There is an option of secondary access. So in the formatting, if you come up, right, so in the search you can type secondary. So you will see there is an option will come up, show secondary. So when you say so what happens is the secondary axis also comes over here. So you can see both the axes on this chart. On left side you have sales, on the right side you have the profit. So you can see both the axes now. So Rashmi, the complete training is of 27 hours, right? So which is spread across weekends and weekdays. So weekdays it takes 13 days and weekends it takes 4.5 weeks. So to have the complete tool knowledge where you learn about visualizations, you learn about data formatting, data cleansing, data modeling, and DAX and all. Okay. Now the next type of chart that we are going to explore over here is a ribbon chart now. Okay. Now ribbon chart is something which could be very much new for some of the people, which is something you will not find in any other tools. So if I show you this, you just have to click on the ribbon chart over here. This is a ribbon chart that we have. Okay. Now in the ribbon chart, what I do over here is I am going to put category on the axis, sales in the values, and I'm going to put region, right? So we have a field of region on the legend. So you see a chart has been created now. So first of all, please don't do anything. First, just understand the chart, then you all try it. On every chart, you will find there is an option at the top which is called as focus mode. So if I click on this focus mode, the chart will come on the entire screen, right? And when you see this thing over here, what you will observe is that how we analyze this chart is now that is something very important to understand in this chart, because this chart is more about technicality. So if you see the bars, right, the bars are telling you what was the total sale for each category, right? So if you come over here, sales for technology, sales for furniture, and sales for office supplies, correct? This is the first information that you get from this chart. Now if you take a look at this orange wave, this orange is for south region. So now in this chart what you will observe over here is these colors are, this breakup is sorted in the ascending order, right? So in technology category, the sales is lowest for the south region. That is why it is coming at the bottom. Then it is higher for central, higher for the west, and the highest for east region. That is what this chart is telling me, right? And when we go from the technology category to furniture category, so there is a change that has happened. The sale of the west region has gone down and it is coming at as the second highest sales for furniture in the west region, right? So you can see there is a downward trend that has come up, and then the sale has got further decreased a little bit from furniture to office supplies for this particular region, that is east. Getting it? I'm just showing you the trend for the blue color right now. Don't see any other thing over here on this chart. So if you hover on this blue area, it in fact tells you that the sales has dropped by 21%. And if you come over here, the sale has further dropped by 1.33%. You see sales change, that is minus 1.33%. So sale has decreased. And if the sale would have increased, it also shows that it will be a plus sign. So you see for this particular region, west region, when we go from technology to furniture, the sale has increased by a margin of 0.25%. And the rank has also changed. Previously it was, the rank was 3, now the rank became this top over here, rank 1. So if this previously was rank 2, sorry, not 3, we will say rank 2. It was 1, 2, 3, 4. So 2 rank became 1. So now what we will do is we will come up and we are going to explore some more charts in it. So we are going to see the pie chart, donut charts, and the tree maps. So why do we use pie charts, donut charts, and tree map is when you have to showcase some market share, right? You want to see, which item is having higher share or which item is having a lower share. So let's try to create that. So you will observe we have a pie chart over here. You click on this pie chart, and in this pie chart, suppose I want to compare the sales of the different, I will say shipping modes. So I pick up the ship mode, I put it in the legend, I pick up the sales, and I put it in the values, and your pie chart will be ready. So I can see 59% of the sales had happened in the standard class, right? So we can see that percentage share. Out of that, then I can see this is the sale for second class, which was 19%, 19.99. This is the sale of first class, and this is the sale of same day delivery, right? So this is a shipping mode. So that how do you want your item to be delivered? So for all these 4 categories, we can see them. Okay. So this is a pie chart, and just a little bit different chart that you have over the pie chart is that is a donut chart. So if I just make a copy of this, Control C and Control V, I can copy this chart and I will convert this chart in the form of a donut. So you can see this donut shape over here. If I click on this chart gets converted into a donut chart now. So both the charts are same, just that a donut chart has a circle in the middle, a transparent circle. Otherwise, from the information perspective, both the charts are same. In the middle, you can never have any percentage, right? Like over here, percentage is for each section. So that is why they are coming over here. In the center, you can only show one number, right? If you click on this chart, but if you want that these legends that these data labels that you have, right? Detail labels, if you come over here, so you have this option of position. You want to keep it outside or inside. This is something you can do, right? So they can come over here. You can place those labels, right? Like this on these places only, not inside exactly. Sure. Now, similar to this, you have another chart, which is a tree map. Okay. So I'm just adding a new page. This is where you will find the option of tree map now. So if you click on the tree map, now this is also something on the similar lines of pie chart only, but different in the visualization. So I pick up the field of ship mode, put it over here in the group, and I pick up the sales and put it in the values. So you will observe a chart which is a tree map has been created. Now this chart is bigger the box, higher the sales, smaller the box, lower the sale, right? The size of the box is telling you the quantum of sales over here. Bigger size means bigger sales, smaller size means smaller sales. Okay. So this is how we can use this tree map in order to have some interesting visualization over here. You can create maps as well in the Power BI, right? So map is one of the interesting features. So if you want to show the data on the map, right? So if you, for creating a map, you need to have a geographical data with you. So you can pick up the map from here, right? So once you pick up the map from here now, over here in the map, suppose I drag my state. So I want to show the states on the map. I'll pick up the state, put it in the location. I'll pick up the sales, put it on the size, and your map is ready, right? So you see bigger bubble means higher sales. So if you see California has a big bubble, that means in the California there was a high sale that was generated. If you take a look over here, that is New York, it is telling you that in the New York, again, there was high sales, but less than California. But in the places like Idaho, Montana, there was very less sale that was generated. And if you talk about Washington, there was a medium type of a sale that was generated now. Now, similarly, you will find there are bundle of other visualizations as well that are available in Power BI, which you can easily create to analyze your data, right? So you can create the maps, you can create the funnel charts. So if you want to create a funnel chart over here, so you will see there's a funnel chart over here. You select the funnel chart. Suppose you want to show the sales of subcategories. So you pick up the subcategory from here, put it in the group, pick up the sales, put it in the values, and it creates a funnel like structure for you. The subcategory that has the highest sales comes at the top, and as you go down, you can see the sales are decreasing, right? So a beautiful visualization to see a pattern that how the sales have changed for the different subcategories now. And it also offers you an option where you can see how the percentage has changed, right? This is a very interesting feature that you will find. Like if you come on the chairs, now it is telling you that chairs had 99% of the sales of what tables had. So tables and chairs, you will see 99% of the sales what you had in this table phone, sorry, not tables, phones. And whatever you had the sale for phones, 99% of that was achieved in chairs. Similarly, if you go down, it is telling you that for storage had 67% sales of firsts. First means phones. So whatever was the sales of phones, 67% of that was generated for the storage. So likewise, you will see the percentages till the last. So this is an interesting visualization to see that sales in that decreasing order for the different subcategories with the interesting visualization over here. Likewise, you can create some bar charts, you can have the tables and matrices, and you can create the visuals using the R script visuals as well, right? So for that, you have to be a little bit comfortable with your R scripting and R codes, and you can create your visuals in the Power BI itself, right? So for example, this is where you are. So you just have to pick up the R visual from here. You click on enable. So in order to create the visualization using R, you should have R and R Studio to be installed on your system. Without that, you cannot create R and R visual, and same goes for Python. If you have Python installed on your system, then only you will be able to create the Python visuals as well, right? So this is basically how the R and Python visuals are created. You just have to pull that, and then what you have to do is you just have to drag and drop your fields over here. So if I drag the sales, I drag the profit, right? So you see this, some code has been generated over here. You just have to write the code what you really want to create. So if I say plot, right? So we have dragged two variables over here, that is data set dollar sales and region. So I'm just going to say data set dollar sales, comma. Now this is the R code, the code that I would have written in the R. I'm writing the same thing over here. Data set dollar. So it's not region basically, it should be profit. Second. So we drag the sales, we drag the profit, So plot data set dollar sales, comma data set dollar profit, right? And I simply say don't summarize. And select to enable. And you can see the chart has now been created. So this chart that you see has been created by writing a R code. So this code that I have written over here, based on this, the chart has been created, right? So that is how you just have to write your code of the R or the Python and the visual will be created. Okay. So this is what I think we will be having for the session, right? So I hope you all enjoyed the session and you got some insights on how you can create some interesting visualizations using Power BI at the speed of light.
Here is another simple question. Which type of chart is best used to show the proportion of categories in Power BI? And the options are A. Column chart, B. Line chart, C. Pie chart, and D. Histogram. If you know the correct answer, please leave it in the comment section below. Building on your knowledge of charts, our next topic is slicers in Power BI. You'll learn how to add interactivity to your reports with slicers, allowing users to filter data dynamically.
Let's move ahead and talk about what are slicers in Power BI. Slicers in Power BI are the simple forms of filters that play a key role in designing customized charts and reports on the Power BI desktop. Now, these slicers play the most crucial role in really creating comparative charts or customized reports. Also, Power BI slicers act as an alternative solution in filtering the narrow portions of data sets that are represented in the form of other visualizations in a particular report. For example, the image on the screen has a dashboard on it, right? It has many visualizations that are grouped together in one page. Now, what slices can really do is it filters the narrow portions of the data sets that are presented in the form of visualizations in this particular report. Now, slices in Power BI can also be thought of an on-canvas visual filters. The slices really enable a user to sort and filter a packed report and view only the information that they want. Now, unlike filters, the slices are present as a visual on the report and let a user select values as they are analyzing the report. Now, let me explain again with another example. If you have a sales analysis report, you can make a slicer for years. Now, from that slicer, you can select the year for which you want to see the sales metrics. The report visuals will automatically change, showing the information for that particular year. We will understand slicers much more when we understand when to really use them. So, when do we use slicers? Now, slicers are a great choice when you really want to display commonly used or important filters on the report canvas for easier access. It also makes it easier to see the current filtered state without really having to open a drop-down list. You can also filter by columns that are unneeded and hidden in the data tables. And finally, you can create more focused reports by putting slicers next to really important visuals. Power BI slicers do not support the following options, that is input fields and drill down options. You can really use a slicer in your Power BI when you aim at doing one or more of the things that are mentioned below. That is when you want to easily access important and frequently used filters by putting them on the report canvas. You can also use slicers when you want to view a focused report by placing the slicer right next to essential graphs and charts. This I've already mentioned before. Slicers also easily allow you to view all the currently applied filters on the report instead of going to the filters drop-down list. It also helps you to show unneeded or hidden or less used columns, but keep them on for the users in case they need to use them for further analysis. Now that we know when to really use slicers, let's move ahead and install Power BI Desktop. So on my browser, I'm just going to search for Power BI Desktop. The second link that appears on your search engine that says download Microsoft Power BI Desktop from official Microsoft is what we need to click. This will immediately redirect us to a page where we can select our language and click on download, and this will allow you to choose the download you want. Now I want to download the PBI Desktop Setup x64 version, so I'm just going to click next, and this will automatically download the executable file for me. Now once the executable file is downloaded, I'm just going to open this. You can just select the language that you'd like to use Power BI on. I'm just going to look for English really quickly, and I'm going to click next. Now you can see that it says welcome to the Microsoft Power BI Desktop Setup Wizard. I'm just going to click next. I'm going to accept the terms and I'm going to click next. This will allow you to install Power BI Desktop onto this particular location. If you'd like to change the location, you can do that, but I'm just going to let it be and I'm going to click next. To begin the installation, you can just click install. Since I've already installed Power BI Desktop onto my local machine, I'm not going to click install. So once you click install, it will download automatically for you and you can finish the setup, and it will also create a desktop shortcut from where you can access your Microsoft Power BI Desktop. Okay. So once you download your Power BI Desktop, this is what appears initially. From the welcome screen, you can see that you have an option that says get data, and you can also see the recent sources that you have worked on. That is, you can open your recent reports. Also, you can open other reports or select other links. Okay. You can select the close icon to close the welcome screen. Now, alongside the left side of the Power BI desktops are icons for the 3 Power BI desktop views. The first one is a report, the second one is data, and the third one is model from top to bottom. Now, the current view is indicated by the yellow bar along the left, and you can change views by really selecting any of the icons. Okay, see, you can see that the views really change. We are going to switch back to the report section. If you're using a keyboard navigation, you can simply press Ctrl plus F6 to move focus to that section of buttons in the window. Now, to see the many types of data sources that are available, simply click Get Data and you can click More in the Power BI Desktop Home tab. And in the Get Data window, you can scroll to the list of all data sources that are available. Okay, you can see that there are a lot of data sources available. So here you can see that you can connect to a couple of different web-based data sources. You can get data based on file, database, okay, and Power Platform like Power BI Datasets, Power BI Data Flows, Azure, and also online services, and finally others. Okay. But if you want to view all of the data sources that you can connect to, you can just click the all option and check out everything. Once you select your data source from where you'd like to import it, you can just click connect. But since we have no data sources of now, I'm just going to click cancel. So in Power BI Desktop, the report view, that is what we are currently on, you can build visualizations and reports. Okay. The report view has mainly 6 areas that I would like to discuss. The first is the ribbon at the top, which displays common tasks that are associated with reports and visualizations. Like you can import your data set, you can directly import data from a Microsoft Excel workbook. You can also create a live connection to data sets in Power BI service, that is cloud service. And you can also import data from an SQL server database. You can enter data by yourself. Okay, I'm just going to show that to you guys. You can add how many ever rows you'd like to. You can add various columns and you can create your own data set. Okay. You can also check out the recent sources that you've been working with. You can transform data. You can create new visualizations. You can add text box. You can add more visualizations. You can really use these common tasks to associate and work on your reports and visualizations. The second main part is the canvas area in the middle, where visualizations are created and arranged accordingly to the user. The third area is the Pages tab at the bottom, which lets you select or add report pages. So if you click the plus icon, it will create a new page for you. If you want to delete pages, you can click the cross button and delete the page. Okay. The fourth area is the filters pane. You can see that here on the right hand side. And in this part of the session, you can filter data visualizations. That's the advantage. The visualizations pane is where you can add, change, or customize visualizations and really apply drill through, right? There's several visualizations that are available like stacked bar chart, you have stacked column chart, you have pie chart, you have donut chart, you have gauges, and you have world maps, and you have many visualizations that are really available from where you can select, okay? And the last part or the last section of the report view is the fields pane, which really shows you the available fields in your queries. You can drag these fields onto the canvas, the filters pane, or the visualizations pane to create or modify visualizations. So this part of the pane allows you to load data. So once you click get data and you import your data into Microsoft Power BI, the data set will be available here. You can see the different tables that are available in your data set, and all of that information can be available in the field section. Okay. Once you get that, you can drop these fields onto the canvas part, that is the filters pane or visualization pane, and really play along with it. Now, what you can really do is you can expand and collapse the filters, visualizations, and fields pane by selecting the arrows at the tops of the pane. Okay, collapsing the panes provides more space onto the canvas to build really cool visualizations. You can also check out the insert option, which allows you to insert a new page. You can also add new visualizations. You can add text box, buttons, shapes, images, all of that. In the modeling section, you can just add a new table. You can add new parameters. You can select languages. You can change your languages. And in the view option, you can select a theme that you'd like to work on, right? The several themes, like, for example, in PowerPoint, you have different themes that you can choose from. The same way, Microsoft Power BI Desktop also allows you to choose various color themes, and you can also, customize your own theme according to how you'd like to. The page view allows you to fit your page the way you'd like to. If you want to fit it to width or you want to put in a size, you can do that. And the mobile layout is another interesting option which allows you to create your dashboard or reports according to your mobile layout, okay? According to how a user or how people can view it on a phone. You can also add grid lines, you can snap to grid, and you can automatically lock all objects in place to put them as where they are. And there are many more options like filters, bookmarks, selections. All of that is not really necessary to learn right now. The help option, on the other hand, allows you to check out training videos. It allows you to check out documentations. You can also check out examples from sample data sets from, the official website. And also you can interact with the community. You can read blogs. You can submit an idea. All of that can be done in the help option. Now, the interesting part is that once you create your report, you can definitely share it with others. There are many ways to share your work. You can distribute the report.pbix file like any other file. You can upload the .pbix file from the Power BI service, or you can publish directly from Power BI Desktop to the Power BI service. But you must have a Power BI account to be able to publish or upload reports to Power BI service. Now, to publish to the Power BI service, what you have to do is from the Home tab, you can select the Publish option, and you may be prompted to sign in to Power BI or to select a destination. And once it is completed, you can see that it will directly publish to where you want it to. So this is all for the interface of Power BI Desktop. I hope it's clear. I hope I have covered most of the parts that I need to for this introductory part. Now let's move ahead and create our slicer in Power BI Desktop. So now let's learn how to create our own slicer. I have downloaded the retail analysis sample PBIX file on the internet. So this slicer really filters data by district manager. So what we're going to do here is I'm going to click on file. I'm going to just say browse reports. And since I've downloaded the file already, I'm just going to open it. Make sure on the left pane you have selected the report icon to open the file in report view. And down you can see that there are 4 pages. One is the information, overview, district, monthly sales, and new stores. I'm just going to click on the overview page with nothing selected on the report canvas. Select the slicer icon in the visualizations pane to create a new slicer. As you can see here, we have the slicer option. I'm just going to click on that. Now that we've selected a new slicer, we can just go to the fields pane, select district and DM to populate the slicer. Now the new slicer is populated with a list of the district manager names and their selection boxes. So what we can do is we can just resize and drag the elements in the canvas to really make room for the slicer since it's overlapping with the pie chart. Okay, and now that I've made some room for the slicer so that you can see the district manager names, it's easier to figure out things now, okay? Now what we're going to do is we're going to select names on the slicer. Okay, you have Alan, you have Andrew, you have Brad, you have Carlos, Chris, and all of that. So you can just select the names and you can notice the effects on the other visualizations on the same page. Okay, so you can just select Andrew for now. So you can notice the effects on the other visualizations of the page automatically, okay? And if you want to select more than one name, you can just click on the control button and you can see the changes immediately. Now, if I go to the visualization pane and select the format section here, there are many options to really describe them all here. You can experiment and create a slicer that works best for you. So this is exactly where your next topic comes into picture, that is to format your slicers. Different formatting options are available depending on the slicer type. Now, if I click on general option, you can see there's option that says orientation, right? So here by clicking on the horizontal orientation and responsive layout, you can produce buttons or tiles rather than, standard list items and make slicer items resized to fit different sizes and layouts. So that's what the option really allows us to do. You can now see that the names are given in terms of tiles. Now with the district manager slicer selected on any page in the visualization pane, you can select the format icon and to display the formatting controls. You can also select the drop down arrows next to each other to display and edit the options. You can see this page information, this page background, wallpaper, filter pan, etc. There are many options that you can really, play around with. So this helps you really format the slicers. Now you can sync a slicer and use it on any or all pages in the report. Now in the current report, the overview page has a district manager slicer. But what if you also wanted that slicer on the new stores page? The new stores page has no slicer. Now with the sync slicers panel, you can sync the district manager slicer to these pages so that the slicer selections on any page affect visualization on all three pages. You can do this by clicking on view and there is a sync slicer option. Now I'm just going to go back to my overview page and select the DM slicer. So once you select this, you can see that the sync slicers, it will show you what all pages have the DM slicer. Okay, because you've already created a district manager slicer on the overview page, the sync slicers pane appear as follows. Okay, now in the sync column of the sync slicers pane, select the overview district monthly sales and new stores page. Okay, this selection, what it really does is it causes the district monthly sales slicer to sync across all of the three pages. So what I'm going to do is I'm going to select all of these. Once that is done, we can observe the effects of syncing the slicer and making it visible on other pages. Now, if you move to the district monthly sales page, you can notice that the district manager slicer now shows the same selection as on the overview page. That's how easy it is to really sync slicers on other pages of your report. Now that we know how to format and create our own slicers, let's move ahead and check out some of the limitations of Power BI Slicer. So there are several disadvantages of slicers in Power BI. We're going to be discussing each of this. First one, there is no support for input fields in Power BI slicers. Second one is there is no support for visual level filters in Power BI slicers. This is really important for certain people when they're working on different kinds of data set. You can also not be able to pin a slicer to a dashboard. This is very, very bad. You can pin your visualizations to the report, but you cannot pin a slicer to the dashboard. The next disadvantage is that the slicers do not support and work with measures, or nor do they support drill down in Power BI report. And also, the data models imported in Power BI and used in slicers do not have the time zone information, although you can convert a local time zone into UTC using the query editor in Power BI desktop. So these are some of the limitations of Power BI Slicer.
Having explored slicers, we'll move on to Power BI KPI Indicators. This module will teach you how to use key performance indicators to track and display critical matrices.
So a lot of you might wonder, what is KPI? So a KPI, or a key performance indicator, is a visual cue that communicates with the amount of progress you've made towards a certain goal. It basically demonstrates how effectively a company is achieving key business objectives. So organizations use this KPI at multiple levels to evaluate their success on reaching targets, both internally and externally. So high-level KPI may be ones which focus on the overall performance of the enterprise, while low-level KPIs may focus on internal things like employees in departments such as sales, marketing, etc., etc. Next, so this is a really important question, when to use a KPI. So KPIs mainly answer two questions. A, what am I ahead or behind on? This specifically refers to a number which is your target. And secondly, how far ahead or behind am I? So this represents a trend which is related to the target. Since a KPI is based on a specific measure, it is designed to help you evaluate a current value and a status of the metric. So therefore, when we ask what do you require for a KPI, it basically requires a base measure that evaluates to a value and a target measure. It also requires a threshold or a goal which the target is set against. So currently a KPI dataset in Power BI needs to contain goal values for a KPI. So if your dataset does not contain one, don't worry. You can create goals by adding an Excel sheet with goals to your data model or in a PBIX file. So this is the next segment. I'm sure most of you were waiting for this till now. So how would you use your KPI visualization? So for that, we need to open our Power BI desktop. So we'll be creating a KPI that measures the progress we've made towards a certain goal. A lot of the people will directly start with a KPI, but I personally find it more comfortable to start with a column graph and then change it into a KPI. So before we start, let's import some data. Here I have an Excel sheet with KPI appropriate data. So this is what the preview of my data looks like. We've got an actual sales column and a target sales column. Month-wise, here we've got the Jan to December month numbered accordingly. And here we have the fiscal month. For those who don't know, a fiscal month is basically months arranged according to the financial year of a country. Here it is April to March, hence I've started with 1 being April and 12 being March. So let's get back to our charts. So as I said, I'm going to start with a column chart. Here we are just going to drag and drop values. Like I'm just going to take the month and drop it into the graph and then take the actual, drop it into the graph. Here we have a graph. Now the thing is, Power BI desktop is actually smart enough that it knows what column to take as what parameter. So now we are going to change it into a KPI. Now this is my KPI icon. We're going to be using this. Let's select the KPI icon and there we have it. Now to turn it into an actual KPI, we must have a target. So let's take the target sales and put it in the target goals field. So this is what a KPI is mainly supposed to show. Here, this is a number that I'm ahead or behind on, and this is the trend. Now looking at it this way, you might not see a problem, but I assure you there is a problem with this. For that, I'll have to use the table. Using the table is as easy as using any other visualization here. We just take the month, drop it, the actual sales, and the target sales per month. I'll be going to the formatting pane here. I'll just increase the size by a little bit. We go to the grid and we increase the text size so you can see it properly. There. As you can see, the months are ordered alphabetically. So this has to be changed. So what I'm going to do is I'm going to select the month tab here, go up to modeling, and here you can see an option which is sort by column. Here you can either change this to fiscal month or month number. I'm simply going to choose the month number here. There. See how our target has changed. Optionally, you can also format this KPI by choosing this paint roller looking icon right here, which is the formatting panes icon. Now here we have the indicator, which controls the indicator display units and the decimal places. Next, we have the trend axis. When it is set on, the trend axis is displayed in the background of the KPI. Next, we have the goals. When set on, the visual displays the goal and the distance from the goal. Next, we have color coding. Suppose your company follows a certain color palette. This is where you can change the colors to match your color palette. Here you can also choose the direction of your graph. Suppose high is good or low is good. For example, if it is something like earning versus wait time, typically a higher value for the earnings is better. Suppose it is something like a defaulters graph, then essentially a lower value is better. So you can change the color settings accordingly. Here good color is green, bad color is red, neutral color is yellow. So let's get back to our graph. Now that you know how this tool basically works, you can do some really smart things with it. Like you can create a measure in the model to return a string. So I'll be calling this progress. Now you can see the progress column is added here. What I will do is I'll be taking a card and I'll be adding the progress to its field here. So it's basically going to return the progress this year. So this is a live tile and it'll keep changing our data set. You can also do a bunch of other interesting things. For example, instead of a single KPI, you can use a multi-KPI. For that, all you must do is go to the Home tab here, and on the ribbon you can see something called From Marketplace. Click on it. Search for something called Power KPI. Okay. You can see the icon appear here with other icons on your visualization pane. You can use it like you use any other visualization here. So you can just drag and drop different values on your values. Your axis has to be a certain date. Does not matter what date, but it can be a period or a month, but it has to have a date. Then in your values field, you can just drop actual and target. There you go. This also you can format using your formatting pane. Like you can go and change your layout, you can change the title. Suppose now it says actual and target by month. You can just rename it to KPI. There are a bunch of other options you can play around with. Let's move on to something else. Another thing you can do is you can actually get a custom KPI from the marketplace again. You can just go to the KPI option. Right at the bottom somewhere, you will have something called the KPI indicator. It'll take some time to load. You can also use this like any other visualization on your visualization pane, like so. You can use it like you use any other KPI tool here. As you can see, these has vibrant colors and it shows the graph in a really nice way with these dots and indicators. What you can also do is you can go to this formatting pane and you can change the graph. You can go here to KPI General and choose a chart type. Right now we have a line chart, then we have a line no marker where those indicators are gone. Next we can use a bar chart as well. You can choose a banding type, whether increasing value is better, decreasing value is better, or the closer is better. Like the increasing and decreasing I had explained earlier in the KPI chart. The closer is better option can be used where you are testing medicines and chemicals. Here right now we have increasing is better. You can change the banding percentage. You can change the colors like you did in the previous charts. Let me get a slicer here. Now I'll go to the formatting pane and in the selection control, I'm going to turn off the single select so I can choose multiple things on the slicer. As you can see, you can use it like any other charts on your Power BI. All three of them are interacting the same way. With that, I think we've covered the KPI.
With KPI indicators covered, the next focus will be on Power BI DAX. Here you will dive into data analysis expressions to perform complex calculations and enhance your data analysis.
So what is DAX? Now DAX is a collection of functions, operators, and constants that you can use in a formula or an expression to calculate and return one or more values. It is the native formula and query language for all of the data analytics tools in Microsoft, and it is also a very highly versatile and functional language designed to work with relational data and perform dynamic regressions. Simply put, DAX helps you create new information from the data already present in your model. But why is it so important? Now, it's easy to create a new Power BI desktop file and then just bring some data into it. You can even create reports that show some valuable insights without using any formula at all. But what if you need to analyze growth percentage across different categories for different dates? Or you need to calculate year-over-year growth compared to market trends? Data Analytics Expressions, or DAX, will provide you with this capability and many other important capabilities as well. Learning how to create effective DAX formulas will help you get the most out of your data. When you get the information you need, you can begin to solve real business problems that affect your bottom line. This is the power of Power BI DAX. And this is the part of the technology that will help you get there. Now, you might already be familiar with creating formulas in Microsoft Excel. I am hoping most of you have actually migrated from Excel to Power BI. That knowledge will be very helpful to you in understanding DAX. But even if you have no experience with these Excel formulas, the concepts that are described throughout the session here will help you get started with these formulas and solving real-world BI problems right away. We'll focus on understanding DAX formulas used in calculations, more specifically in measures and calculated columns. You should already be familiar with using the Power BI desktop at this point so that you can import data and add fields to the report. And you should also be familiar with the fundamental concepts of measures and calculated columns. If you haven't, I will also link a basic tutorial for you guys in the description box below. Now, we frame our understanding of DAX around three fundamental concepts. You have syntax, functions, and context. These are some of the more important concepts in DAX, and understanding these three things will provide the best foundation on which to build your DAX skills. So first of all, you have syntax. Now, before you create your own formula, let's look at the DAX formula syntax. Your syntax includes the various elements that will make up a formula, or simply put, it's how you basically code or write a formula. This is a simple DAX formula for a measure. Now keep a couple of things in mind. This formula includes certain syntax elements. Now, people who are from a coding background will understand what syntax is. It's a grammar for using a certain programming language. And it's the same thing in context of DAX as well. Now, first part, the measure name is total sales. Second, the equal sign operator indicates the beginning of the formula, and when you make a calculation, it will basically do the role of giving you a result. Then sum is your DAX function. This is going to add up all of the numbers in the sales amount column, and this is something that we are going to discuss later. But for now, I have taken sum because everybody understands what a sum is. Then you have your parentheses or your round brackets, which surround an expression that contains one or more arguments. All functions require at least one argument to run, and in an argument, you basically pass a value to the function. Sales here is the table that you are trying to reference, and sales amount, as I had mentioned before, is your column in that particular table. With this argument, the sum function knows on which column to aggregate a sum. Now, when trying to understand a DAX formula, it's often helpful to break down each of the elements into a language you think and speak every day. For example, you can read this particular formula as the sum of values in the sales amount column in the sales table will give you the total sales measure. When you add this formula to your report, this measure will calculate and return values by summing up the sales amount for each of the other fields. Now, you can always go ahead and create your own measure that sums up the values from the sales amount field, But the good part about this method is that this measure will make your formulas and your model more efficient. Now, the best way to learn DAX is to create some basic formulas, use them with actual data, and see the results for yourself. So let's go ahead and create a simple formula. And this task will basically help you understand your formula syntax and how the suggestions feature in the formula bar can help you while creating your formula. Now here I'm using the Contoso Sales sample Power BI desktop file, which is an open source file that I've gotten from the Power BI website. If you go on to their website, you can get it too. But for your convenience, we are going to link this also in the description box below. So this is what your data model looks like. Couple of complicated relationships here. If you do not understand the concepts of relationships, do refer to the tutorial link I'll leave in the description box below, and then come back to this and finish this video. But it's not that important. We are here to learn DAX. So let's go back to our report view. Now this is our report view. This is where we create our visuals. So in the fields list, I am going to right click the sales table and select new measure. This is where we are going to be creating our new measure. Let's go ahead and name this sales for previous quarter or previous quarter sales. All right. Now after the equal sign, which will appear automatically, let's type calculate. Now you'll see this wonderful thing that Power BI is smart enough to suggest a bunch of things which start with CA. The Smart Complete helps you use DAX in Power BI even if you're new to DAX or programming in general. It will also give you a suggestion on how to use this particular function. Now that's brilliant. So what you're going to do is you are going to use the calculate function to filter the amounts we want to sum by an argument that we are going to pass through the calculate function. People who understand coding will refer to this as a nested function. Now, as you can see in the suggestion below, the calculate function has to have at least two arguments. The first is the expression to be evaluated, and the second one is a filter. Now, after this parentheses, we're going to type sum, okay? And then begin by typing sales, through which sales will come up, and let's see, yeah, this is what we want. We want sales amount. And then I close the parentheses. Now this is the first expression argument for our calculate function. Now after the comma, I'm going to keep a space to specify the first filter, and then I'm going to use the previous quarter time intelligence function to filter the sum results by the previous quarter. Okay. So after opening the parentheses, let's type. I'm going to put in calendar and date key. Now the previous quarter function has one argument, a column containing a range of dates basically. In our case, that's the date key column, and then I'm going to close both the arguments. Your formula should now look like this. So I'm going to go ahead and commit. I'll take some time, and here you can see your measure has been created. Okay. So congratulations, you did it and created a complex measure by using DAX. And that also, this is not one of the easy ones because it has nesting, it has so many advanced functions. But what will this formula do? What it's going to do is calculate the total sales for the previous quarter depending on filters applied in your current report. So for example, if we put sales amount and then previous quarter, so you were just introduced to several important aspects of DAX formulas. This formula included two functions. One is your previous quarter, which is a time intelligence function, which in a nested argument passed to calculate, which is a filter function. DAX formulas can contain up to 64 nested functions, even if it is highly unlikely for a formula to ever contain so many nested functions. Such a formula would obviously be very difficult to create and debug, and probably wouldn't be very fast either. But in this formula, you also used filters that narrowed down what will be calculated. In this case, you selected one filter as an argument, which is actually a result of another filter. You use the calculate function, which is one of the most commonly used functions in DAX. As you go ahead and author models of your own and create more complex formulas, you'll likely use this function many more times. Although any further discussion about the calculate function is outside the scope of this particular session, as your knowledge of DAX grows, my advice would be to pay attention to this particular function. Now, the next thing that I need you to understand, which is a very fundamental aspect of DAX, is context. Now, in DAX, there are two kinds of contexts. You have row context and filter context. First, let's look at the simpler one, which is the row context. And this applies whenever a formula has a function that applies filters to identify a single row in a table. This is something which you apply even without knowing that you apply this. The function will inherently apply a row context for each row of the table over which it is filtering. And like I said, this is most often applied to measures, and you're probably doing it anyway without even knowing about it. Now, the filter context is a little more difficult to understand than a row context, and you can most easily think of the filter context as one or more filters applied in a calculation that determines a result or a value. It doesn't really exist in place of row context. Rather, it applies in addition to the row context. For example, to further narrow down the values to include a calculation, you can apply a filter context which not only specifies the row context, but also specifies a particular filter. For example, when you add total cost to a visualization and then add year and region, you're defining a filter context that selects a subset of data based on a given year or region. But why is this particular kind of context so important to DAX? Now, one of the reasons is because it can basically define a function by relationships and by other measures and columns. Now, to better understand this formula, we can also break this down much like other formulas. This includes the measure name, which is store sales, the equal sign operator, which I had discussed before, the calculate function, which you just used, your parentheses, which surround your expression, a measure, which is your total sales, and then you have a fully qualified referenced column, which is your channel name in your channel table. Now, this is our row context. Each row in this column specifies a channel such as store or online. Now, the particular value store here is a filter. This is our filter context. This formula ensures that only sales values defined by the total sales measure are calculated for rows in the channel name column of the channel table, with the value store used as a filter. Now, you can imagine being able to define your filter context with a formula has immense and very powerful capabilities. The ability to reference only a particular value in a related table is just one such example. Now, don't worry if you completely don't understand context right away. As you go ahead, learn more, create your own formulas, you'll obviously get a better grasp of this concept and why it is so important. Now, let's go ahead, look at a few functions, what they are, and how you can use them in your reports. So functions are basically predefined formulas that perform calculations by using specific values. Now, these values are called arguments, and you basically are going to use them in a particular order or structure or syntax to suffice your function. Now, arguments can be other functions, other formula, expression, column references, numbers, text, logical values such as true and false, or other constants. And if you're familiar with functions in Excel formulas, many of the functions in DAX will appear very similar to you. However, DAX functions are unique in some ways, such as the customizing calculations based on a row by row method, or the fact that many functions return a table rather than a value, and also the very important time intelligence functions. So let's go ahead and look at a few of these. So first, we're going to start out by some simple functions. We're going to start out with some count functions and discover a few different variations of the same function. So again, I'm going to go ahead and click on new measure. And let's go ahead, name this our count measure. I'm probably going to try and reuse this for all the three cases that I'm trying to demonstrate. It's not very complicated. You just type count and wait for Power BI to auto-complete it. And then you pick, let's say, I'm doing product category. Then I'm going to go ahead and commit. As you can see on the right, this measure has appeared. If I drag and drop this on my screen and then maybe pick the card visualization, it is going to give me the exact count of the number of cells that contain numbers. Say the count function, it's basically going to give me the number of cells in that particular column that contain numbers. So we have 8 of those in this. Now remember, the count function is only going to return a whole number, and the only argument that is allowed to this function is a column. The count function counts rows that contain either numbers, dates, or strings. When it finds no rows to count, it basically will return a blank value to you. Your blank values in your columns are going to be skipped, and your true and false values unfortunately are not supported because you cannot count them. Now, if you want to evaluate a column of true or false values, you can go ahead and try a variation of count, which is the count A function. You can use that to count logical values or text. What this is going to do is it's going to count the number of non-empty cells in a particular column. So let's go ahead and try that. I'm going to go ahead and use the very same measure that I had created. Okay. Let's name this count A. And here let's go ahead and count A. Now, as you can see, the syntax has not changed and our value has also not changed, which possibly means that all of the cells in that particular column, which are not empty, actually contain numbers, and there are no empty columns. Now, like the count A function, you have something known as the count AX function, which counts the cell containing any kind of information, including other expressions. For example, if a column contains an expression that evaluates to an empty string, the countAX function treats that result as a non-blank. Usually, this function will not count your empty cells, but if it contains a formula, it is counted. Whenever a function finds no rows to aggregate, this one, like both its sister functions, returns you a blank. So my next example is going to show you how countAX works by counting the number of non-blank rows in the column using a filtered form of the stores table on status off. For that, you need to see what the table looks like. Here's the table. This is the close reason you measure. Let's just name it something, which is close reason. All right. Again, let me tell you, basically we are trying to get a count of how many of these stores are closed by filtering out the number of non-empty cells in the close reason column. Okay, so let's go here and if we turn it into a card, it's giving us the number 12. Let's go to our data and see if that is true. Let's go down, 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 down. I'll keep it here for some time. You can go ahead and count the number of rows, and it's actually 12 rows, which have the status off and a close reason. So that is the number of non-empty cells in this particular column, and we have used the countAX function to count them. So next, let's go ahead and look at some logical functions. Now, these are the functions which are going to act upon a certain expression that you pass on to them, and return you the information about the values given by the expression that you put in. Yes? For example, you can use a function known as if to check the result of an expression and create conditional results, because the word if, even in English, is used in a conditional context, right? So in this category, I'm going to discuss the three most common logical functions, which are and, or, and not. Another very popular one used more commonly is the if error, which basically evaluates an expression and returns a very specific value if the expression returns an error. So let's go ahead and look at our first function, which is the AND function, which does nothing but check whether both arguments that you have passed through it are true or not. If both of them are true, then it returns true, otherwise false. Now the syntax is fairly simple. All you have to do is put in two logical arguments after the and it's going to return a value depending on the combination of values that you test. Now, if you need to perform an AND operation or multiple expressions, you can create a series of calculations, or better, even use the AND operator that you use while coding, which is the double ampersand sign, and join all of them in a simpler expression. As for this particular function in DAX, it accepts only two logical arguments, hence that's what we are going to do. So I'm going to go ahead and create a very simple measure again. And let's call it the logical measure. Again, like the previous time, I'm going to try and reuse this as many times as I can. Now, basically what this measure is saying is that if 10 is greater than 9 and minus 10 is less than 1, then we are supposed to be returned all true, else one or more false, which is just a good way of saying true or false. We're going to go ahead and test it. And if I just click on this, if you see both of the conditions, they are true. 10 is greater than 9 and minus 10 is less than minus 1. So our conditions are both true. Now, if I go ahead and change this up a little bit, instead of minus 10, I make it plus 10 and then commit, you see the value changes, right? So for the AND function to return you a true value, both of the logical arguments passed through it should be true, else it will be false. Now let's go ahead and try out another very popular logical function, which is the OR function, which basically checks whether one of the arguments is true. Now, like the AND function, the OR function in DAX also accepts only two arguments. So if you need to perform an OR operation on multiple expressions, you can create a series of calculations by using the OR operator. Also, this function evaluates the arguments until the first true argument and then returns true. So keeping that in mind, let's go ahead and switch this up a little bit. Now we know from our previous example that one of the arguments here is true and one of them is false. So instead of keeping this quote as all true, let's switch this to at least one true. And let's switch this to both false. All right. We're going to switch the AND to an OR function. And we're going to go ahead and commit our changes. Now we remember from the previous example that one of them is true, 10 is greater than 9. The second argument is false. So our card shows at least one is true. Now let's change the 9 to 11 and see what happens. As you see, the card shows both of them are false. So now that we've seen and or, let's look at not. What it does is that it changes false to true or true to false once you pass a logical argument through the not function. Your return value will be true or false And you're basically going to pass just one argument through this particular function. So what I'm going to do is I'm going to make these changes here. I'm just going to keep one side as true and one side as false. Here we're going to switch this. Let's remove our second argument and replace the or by not. So 10 is not greater than 11. It's a false statement. So since we are passing it through the not function, we should get a true, which is why we're getting true. And let's flip this and see if we get false. And here you go. With that, we've looked at a certain logical functions. Let's go ahead and see what the next type of function is. Next, we have our information functions, which basically look at a cell or a row that is provided as an argument and tell you whether the value matches the expected type. For example, the isError function returns true if the value that you've referenced contains an error and false if it does not contain an error. All of these functions are pretty true to their name and are fairly simple to follow. Now the next one we're going to look at is a function called contains, which returns true if values for all the referred columns exist or are contained in those columns. Otherwise, the function will return you false. So basically, true if all those values exist and false if they don't in the column that is specified. Now make sure that your column is not an expression and your value is basically a sort of a single scalar value. The arguments, column name and value must always come in pairs, otherwise you will be thrown an error, and the column name must belong to the specified table. Now next you have a function called username, which is an expression with no parameters. It returns the domain name and the username from the credentials that are given to the system at the connection time. The code you see here basically verifies if user login is a part of a certain table or not. It's as simple as that. Your return value is going to be the username from the credentials given to your system. The same logic applies to two other information functions, namely user object ID, which returns the current user's object ID or SID, and the user principal name, which basically returns the user principal name as the name suggests. Next, let's go ahead and discuss some text functions. Now DAX includes a set of text functions which are basically based on the library of string functions if you have worked on Excel before. Now these functions have been modified to work with tables and columns in tabular models of Power BI, but if you've worked with them using Excel, it might come naturally to you. Now the first one we're going to look at is concatenate, which as the name suggests, it concatenates two text strings into one text string. You're basically going to use the function and then pass two different texts, and then your function is going to concatenate or join those texts. Now the joined items can be text, numbers, or Boolean values represented as text or a combination of those items. You can also use a column reference if the column contains appropriate values. So again, if I go ahead and create a new measure, let's try and concatenate the commonest text that you can, which is hello world. See, it's as simple as that. Now you can go ahead, do the same thing with numbers or Boolean and work with it as you like. The next function we're going to look at is exact. Now what it does is that it compares two text strings and returns true if they are exactly the same and false otherwise. It's pretty self-explanatory, and one thing you have to remember is exact is case sensitive but ignores formatting differences. So you can use exact to test your different strings being entered into a document. So let me switch the second word to hello, but maybe with H capital. And as you can see, because it is case sensitive, it's going to return false. Now this is great if you want to compare two different columns and their values from two different tables that you have updated from, let's say, two different individuals. So you can sort out the differences and see where the irregularity lies. So the next text function we're going to discuss is upper. I'm going to go over this pretty quickly. It converts a text string into all uppercase letters. So if I used upper and maybe, let's say, now the next and the most common functions that are used in DAX are in fact the date and time functions. As the name suggests, these functions help you create calculations based on dates and time. Now again, if you have used these in Excel before, they are very similar to the date and time functions there. However, like we saw in many other functions prior to this, the DAX functions in Power BI take values from a column as an argument. So I'm going to go through a couple common ones very quickly, and then we're going to discuss a few common time intelligence functions, which are a section of their own. So first of all, let's discuss today. Now this function is very useful when you need to have the current date displayed on a worksheet, regardless when you open the workbook. Although it is most commonly used for calculating intervals. So I'll quickly go on to DAX and use this function. Okay, so we're going to go click on new measure. Let's call it the date measure. And then commit. Now, if I had to display this on a card, it would give today's date. But a DAX function simply can't serve this purpose. It has to have more of a purpose than just showing the date, right? So, suppose if you know someone was born in 1955 maybe, you can use this formula to find that person's age as of this year's birthday. So here we are going to use another function, which is the year function, and subtracting 1955 from it. Let's commit. And you know that person as of this year would be 65 years old. This particular formula uses the today function as an argument for the year function to obtain the current year, and then subtracts 1955, which will return the person's age. Now that you've already seen how you use the year function, let's go ahead and look at it from a definitive standpoint. Now, as the name suggests, your year function will return the year of a date as a 4-digit integer, and that goes for all of Microsoft's spreadsheet-based applications and softwares. If you try to use date and time functions before the March of 1900, you'll probably get an error. Now, you need to understand that in contrast to Microsoft's Excel, which is basically storing your dates as serial numbers, what DAX does is it uses a date-time data type to work with dates and times. Dates should be entered by using the date function or as results of other formulae or functions. You can either enter dates in accepted text representations of dates, such as 22nd June 2020 or June 22nd, 2020, depending on where you're from. Now, you need to keep in mind that errors may arise if the format of strings is incompatible with the current local settings, and you'll have to take care of it as you go along using this. Another one, like the today function, is actually the now function, which not just returns the date, but also the time in date-time format. Now, the now function might seem only useful when you need to display the current date and time on a worksheet, but it is also used to calculate a value based on the current date and time, and when that value is updated each time you open the worksheet. The result of the now function changes only when the column that contains the formula is refreshed, so please do not expect it to get updated continuously. Now, the last one I want to discuss is not just a date time function, but also a time intelligence function. Now, what a time intelligence function does is that it enables you to manipulate data using time. Now, this includes dates, months, quarters, and years, and you can then build and compare calculations over those periods of time. Now, one in particular which is used a lot is the dates in period function. Now, this basically returns a table that filters out your column only between a certain period of time or in between your start date and end of interval. It returns to you a table containing a single column of date values. So one very commonly used time intelligence function is your end of month function. It could be your end of quarter or end of year function as well. Now, what these kind of functions do is they return the last date of the month in the current context for specified column of dates. This table contains a single column and a single row with a date value. Now, this could be a reference to the date and time column, a table expression that returns a single column of date time values, or a Boolean expression that defines a single column table of date and time values. Now, one thing you need to remember is that you cannot use this in the direct query mode. So let's go ahead and look at a sample to create a measure that creates the end of the month for the current context. Let's call it end of month or EOM. And use it directly. Now, like I said, you can use the end of quarter or end of year as well, depending on what your company uses, and put in the date key. Let's drag it out and put in a card, and here you see your end of month. You can go ahead, drag it into a visualization and see how it affects your visualization. And you can also use the other variations of this, such as you can change end of month into end of quarter, which will basically give you the date for the end of quarter. This is the end of my quarter, so that's that. With that, I think we have covered all the common functions that there is to know about. You can obviously go ahead, look at the official documentation for DAX and see for yourself the entire plethora of functions that are available at your disposal.
Here is another quiz question. Which function in DAX calculates the total of a column? And the options are A. Sum, B. Average, C. Count, D. Max. If you know the correct answer, please leave it in the comment section below. Having learned DAX, we'll now explore Power BI Report Builder. You will learn how to create detailed and professional reports utilizing advanced features to present your data insights.
Now let's start with paginated reports. And what are they? I assume some of you might have already used SQL Server reporting services. For them, paginated reports are not a new thing. For people for which this concept is new, these reports are called paginated reports because they are formatted to fit well on a page. They display all the data in a table, even if the table spans multiple pages, and hence given the name Pixel Perfect Reports. Because you can control the report page layout exactly and precisely as you need it to be. Paginated reports are based on the RDL report technology in the SQL Server reporting services and can have many pages to begin with. Now, paginated reports have their own design tool, which is in fact known as the Power BI Report Builder, the tool we'll be working on today. It's a new tool that shares the same foundation as the tools you'd previously used to create the paginated reports if you have done so. In fact, for those of you who have used SSRS before, paginated reports that you created there in 2016 or 17 or in the Power BI report server on-premises services are all compatible with the Power BI service. Power BI service thankfully maintains backwards compatibility, so you can move your reports forward and then you can upgrade any previous version paginated reports. So Report Builder is your standalone tool for authoring paginated reports. Now, a single paginated report can have a number of data sources. It doesn't have an underlying data model unlike your Power BI reports. So for the initial release of paginated reports in Power BI service, you create embedded data sources and data sets inside the report itself. You create reports in Report Builder on your local system, and if a report connects to on-premises data after you upload the report to the service, you need to create a gateway and then redirect the data connection. All right. Now there are a couple of different sources you can connect to as of May 2020, which are the Azure services, Azure SQL database and data warehouse via authentication, Azure analysis services via SSO, SQL Server via a gateway, SQL Server analysis services again via a gateway, Power BI datasets, Oracle and Teradata. Now through this exercise, you can design your report, which basically means create paginated reports with matrix, chart and freeform layouts. Add more to it by filtering, grouping and sorting your data or adding formulae and expressions. You can create a report definition when you design a paginated report. You can view it via the Power BI service in a browser or the Power BI mobile apps. And finally, you can create a subscription to the same. Now, a couple of limitations and considerations that you have to understand. There are some features that aren't supported in this initial release. Firstly, pinning report pages or visuals to Power BI dashboards. I mean, you can still pin visualizations to the Power BI dashboard from an on-premises paginated report on a Power BI report server or reporting services, but you just can't do it on the service. Second, you cannot use document maps. Third, sub-reports and drill-through reports are also something you cannot do. You may consider using URL parameters with paginated reports to achieve the drill-through scenarios though. And one that I have mentioned before is that you can't use shared data sources and shared data sets. Hence, you have to create your own via embedding them in your report. So now that all of this is out of the way, let's go ahead and look at the different aspects in the report design view of paginated reports. Now, the report design view in the Power BI Report Builder is the design space for creating paginated reports, as the name suggests. You can publish it to the Power BI service, as I had mentioned before, and the design surface is at the center of the report builder with ribbons and panes around it. Now, the design surface is where you add and organize your report items. Now, basically, we're going to discuss in brief the panes you use to add, select, and organize your report sources and change report item properties. So first, you have your report data pane. Now, from the report data pane, you define the report data and the report resources that you need for a report before you design your report layout. For example, you can add data sources, data sets, calculated fields, report parameters, and images to your report data pane. After you add items to the report data pane, you can drag fields to the report items on the design surface to control where the data appears in the report. However, if you drag a field from the report data pane directly to the report design surface instead of placing it in a data region such as table or chart, when you run this particular report, you will only see the first value from that field. Okay, so this is one thing to keep in mind. Now, you can also drag built-in features from the report data pane to the report design surface. When rendered, these fields provide information about the report, such as report name, the total number of pages in the report, and the current page number. Some things are automatically added to the report data pane when you add something to the report design surface. For example, when you embed an image in your report, it will be added to the images folder in the report data pane. You can use the new button to add a new item to the report data pane, and not just one, you can add multiple data sets from the same data source or from different data sources to the report. Next, you have your report design surface. Now, this is basically your main work area for designing your reports. To place report items such as data regions, sub-reports, text boxes, images, rectangles, and lines in your report, you add them from the ribbon or the data part gallery to your design surface. There, you can add groups, expressions, parameters, filters, actions, visibility, and formatting to your report items. Now, the design surface size might be different from page size print area that you specify to print the report. Changing the size of the design surface will not change the print area of your report, no matter what size you set for the print area. The full design area size does not change, however, but you can definitely choose to display the ruler if you are in doubt. Next, you have the parameters pane. As the name suggests, With the report parameters, you can control the report data, connect related reports together, and vary report presentation. The parameter pane provides a flexible layout for the report parameters. Then you have the properties pane. Now, every item in your report, including data regions, images, text boxes, and the report body itself, has properties associated with it. For example, the border color property for a text box shows the color value of the text box's border, as the name suggests. And the page size property for the report shows the page size of a report. Again, pretty understandable. These properties are displayed in the properties pane. The properties in the pane change depending on the report item that you select. Now, in a report builder, you can change properties for the report items in several ways. You can do it by selecting buttons and lists on the ribbon. You can do it by changing settings within dialog boxes, as well as property values within the properties pane. The most commonly used properties, however, are available in the dialog boxes and on the ribbon. By default, the properties displayed in the properties pane are organized into broad categories such as action, border, fill, font, and general, each category with a separate set of properties associated with it. Next, you have the grouping pane. Now, groups are used to organize your report data into a visual hierarchy and to calculate totals. You can view the row and column groups within a data region, on the design surface, and also in the grouping pane. Now, the grouping pane has two panes, one representing row groups and the other representing column groups. When you select a data region, the grouping pane displays all the groups within that data region as a hierarchical list. Child groups appear intended under their parent groups. Now, you can go ahead and create your groups by dragging fields from the report data pane and dropping them on the design surface. In this pane, you can add parent, adjacent, and child groups, change group properties, as well as delete groups. Even if the grouping pane is displayed by default, you can definitely clear it by unchecking the box on the View tab. I hope with this section, you're clear with all the different ribbons and panes in the design space. With that, let's move on to the real deal. Let's go on to our tool and create our paginated report. Now, upon selecting to open your Power BI report builder, you shall be faced with something like so. You will have a dialog box called Getting Started, which shows at startup. I'm going to close this and I'm going to full screen the report builder. This is what your report builder looks like. Here's your design space with all the different panes and ribbons around it. Yes. Now in this tutorial, what we're going to do is we're going to connect to a sample Azure SQL database, and then we're going to use a wizard in the report builder to create paginated reports with a table that wraps to multiple pages. So again, your steps to this demo is to use an Azure sample database, create a matrix in the Power BI report builder with the help of a wizard, format the report with title, page numbers, and column headings on each page, format currency. If you don't have an Azure subscription, you can definitely go ahead and create a free account before you begin. Now, as I had given you guys a heads up before, you definitely need a Power BI report builder from the Microsoft Download Center. You need to also have created an Azure SQL database sample in the Azure portal. You will be needing the name and password you created. You will also need a Power BI Pro license. You need a workspace on the service in a premium capacity. Now, if you have a premium capacity, it would have like a diamond-like icon in the workspace next to it. So let's go ahead and create a matrix with a wizard. If we go to File and then click on New, again, this dialog box appears that we had closed out before. If you're using the dialog box that appears automatically once you turn it on, make sure that your New Report option is selected on that dialog box. For me, I've opened it through File and the New Report option, so this is the only one option that I'm getting. But apart from this, if you use the startup dialog box, you will also be getting options such as new dataset, open, and recent. So be careful of this. So on the right, you have options such as table or matrix wizard, chart wizard, map wizard, and blank report. So I'm going to go ahead and click on table or matrix wizard. Here I will be prompted with this dialog box, and here I'm going to go ahead and choose a dataset. Okay. In the choose a dataset page, this wizard that appears, select create a dataset. For most of you, this will be automatically selected. Then go ahead and click on next. You'll be prompted to choose a connection to a data source, a page like this. Here we are going to click on new because we are going to use a new data source. And on clicking that, a dialog box which says data source properties is going to open up right in front of you. You can name a data source anything you want, use characters and underscores. For the purposes of this tutorial, I am going to call it my Azure data source because I am going to be using an Azure data source. In the connection type, I'm going to go down the list and select the Microsoft Azure SQL database. And next to the connection string box, I'm going to go ahead and click on build. Now this is going to lead to another dialog box called connection properties. Now for the server name, I'll be going back to my Azure portal where I have created an SQL Server database beforehand. So on the SQL databases page, this is the name of my sample database. I'm going to click on it. And here it's going to show me all the details that I need. If I go a little to the right, you have your server name, which let's just copy and paste here. You can copy to clipboard and then paste. Make sure it ends with a .database.windows.net. In the logon to the server section, instead of use the Windows authentication, we are going to be using our SQL Server authentication. So my login is Azure user. I'm going to go ahead and type a password. And in the next section, to connect to a database. Now under connect to database, select the drop down arrow and select the database name you have created in Azure. In my case, it's the my sample database. Then we're going to go ahead and test connection. The test results would come fairly quickly. And as you can see, the test connection is succeeded. For you, you will also see the test results message every time. Then we are going to select OK. And again, we're going to go ahead, even in the connection properties, we're going to select OK. Now, in the connection string box, the report builder displays a second line, which you might have noticed did not exist before. This is basically the connection string you just created. We're going to go ahead and click on OK. Now, we're back to the choose a connection to the data source page. And now you have a data source connection in your data source connections box, which is your My Azure data source. And in this report button under the data source connection you just created, we're going to select the data source, which is already selected in my case, and then click on next. Here we are going to be met with a design a query page. If this does not come directly to you, you'll probably be met with a prompt where you'll have to type in the same Azure username and password. But since I'm already connected and logged in my Azure portal, as you guys just saw, now you'll be met with a design a query page. What we're going to do is we're going to expand this sales LT section and then the table section. And you'll have a bunch of different tables called address, customer address, product, category, description, model, so on and so forth. I'm going to go ahead and select a couple tables. We're going to select address, customer, product, and the last one. Now pay attention here in this line. Because auto detect is selected in case of our relationships, the report builder detects the relationships between these tables automatically. We're going to go ahead and select run query. And then our report builder displays to us the query results. Yeah, all the columns, and this is all the rows. Once we're done with this, we're going to go ahead and click next. Now this will directly lead you to the arrange fields page. For those of you who have older versions, you might be led to a choose a dataset page where you can go ahead and choose the dataset that you're working with and click on next. For those of you with the latest version as of May 2020, you will directly be met with this arrange fields page. What we're going to do is drag certain fields from the available fields box to the row groups box and the value box. So I'm going to drag company name. Also going to get the sales order number as well as product name. Let's get this also. Now again, from the availables field, we're going to pick 3 more things to put in our values box. So order quantity. As you drag order quantity into the values box, you know what this logo means, right? It's a calculated field. So it's going to sum your order quantity automatically. You're going to put unit price as well as line total. All right. On clicking next, you'll get a choose the layout page. Here, what you're going to do is keep all the default settings, but clear the expand and collapse groups. In general, the expand or collapse groups feature is great, but just for the sole purpose of this exercise, you want the table to wrap to multiple pages. So we're going to go ahead and uncheck this. We're going to then go ahead and click next. It shows us a preview of what we've created, and then again we're going to finish so our table is displayed on the design surface. Alright, so now let's pause for a moment and look at the results of the wizard. This is a little insight into what you have created as of now. Let's first go step by step and look at all the features that we had looked at previously. First, the report data pane. If I expand the dataset here, you see the embedded Azure data source and the embedded dataset based on it, right? Both of which you have created. The design surface is about 6 inches wide, and on the design surface, you see the matrix displaying the column headings and the placeholder values. Yes, the matrix has 6 columns and appears to be only 5 rows tall. Again, here you see the order quantity, unit price, and line total are all in sums by default, and each row has a subtotal again by default. You still don't see actual data values. You need to run the report to see them. Now we go to view and check our properties pane. We get our properties pane on the right. In the properties pane, the selected matrix of yours is called Tablix 1 or Tabli 1. Now, a Tabli or a Tablix in the report builder is a data region that displays data in rows and columns. It can either be your tables or matrices, whatever. All right. Now, the grouping pane is in the bottom, as I had mentioned before. It has your row groups and column groups. And here you will see 3 row groups that you created in the wizard. You have your company name, sales order name, and product name, which we just did. The matrix doesn't have any column groups because we didn't create any. Next, what we're going to do is run the report. To see the actual values, you need to run the report. So we're going to go to the home ribbon or the home toolbar and then select run. Now, as you see, the page has changed and it'll take a few moments to load. Kindly be patient, and voila, you see the values. The matrix has many more rows than you saw in the design view, right? Note that here on top, report builder says it's page 1 of 2. Now the report builder loads the report as quickly as possible, so it retrieves enough data for a few pages at a time. The question mark at the end of this 2 indicates that the report builder hasn't loaded all the data yet. We can go ahead and click on print layout, and then your report will be in this format when you print it. The report builder now knows that the report has 29 pages and has automatically added a date and timestamp as well. So now you have a report with a matrix that wraps to 29 pages. Let's add some features and improve how it looks. So you can run the report after every step if you want to see how it's coming along. Yes? Now for that, on the Run tab, you see this design option. We're going to click on that so we can continue modifying it. First, we're going to go ahead and set page width. Typically, a paginated report is formatted for printing, and a typical page is 8.5 by 11 inches. So I'm going to drag it out. So you can go ahead and drag your ruler to make your design surface a desirable size. The default margins are 1 inch on each side, so the side margins need to be narrower. So we're going to go to report properties. I'm going to expand margins. I'm going to change the left and right margin to like 1.9 just for the sake of this. I'm actually pretty satisfied with the 2 centimeter gap. All right, then we're going to go ahead and add a report title. So here it already gives us the option called click to add title at the top of the page. Let's name it sales by company. Also going to centerline it. On the right, you can see the alignment, font, general lists, so on and so forth. Once you've selected your title text, under font in the color, let's change this to blue. All right. Actually, I quite like the black, so let's just keep it black. Much better. Then we can go ahead and add a page number. Now you notice that the report has a date and time stamp in the footer. You can also add a page number to the footer. So at the bottom of the design surface, you will see something known as execution time. Yes, this is on the right at the bottom. Now in the reports data pane, let's go up and expand the built-in fields folder. We're going to take page number. We're going to drag this to the left side of the footer. Yeah, so I put it at the same height of this execution time bracket thing. I'm going to drag it out to make a square. Then I'm going to go to the insert tab and select a text box. I don't know why I couldn't see it. It's right in front of me. And as it appears, click to the right and type I'm going to bring this also type off. And then I'm going to go back to the report data pane and drag the overall total pages. And also make it square. So it'll basically show the page numbers in a current page number of total page numbers format. Okay. Next, we're going to go ahead and make our table wider. So now you can make your matrix wide enough to fill in the width of the page and make the text columns wider so the names don't scroll as much. So I'm going to select the matrix, select the company name column, and open it wide. And I'd do the same for the product name. I'm just going to expand it enough so the name shows completely. Now your matrix is almost as wide as the print area. Now all that we are left with is to change the currency and add column headers on each page. So to format the currency, we're going to select the upper left, the cell, hold down the shift key and select till here. Okay. We're going to go to the home tab and select the $sign. Then we're going to click on this little arrow next to the placeholder styles and select sample values. So now you can see that the values are formatted as a currency. Yes. Now finally, we are going to go ahead and add columns on each page. So one more formatting improvement before publishing the report to the service is to make column headers show up on each page in the report. So in the far right top bar of the grouping pane, select advanced mode, select the top static bar in the row groups, and you will see that the company name cell matrix is selected. Now we go to our properties pane. So here we're going to select our keep with group and set it to after and repeat on new page to true. It's time, guys, now to run the report and see how it looks. Go back to the home ribbon and select run. This is going to take some time. All right. Then we're going to go select print layout. Okay, so this is our print layout. Here you can see your currency is formatted. Your columns have headings on every single page. Just let's go to the next page. So my line total has actually come to the next page. What I'm going to do is I'm going to go back to design. Select this and bring it in. make a few changes. All right, let's run this. Voila, our line total comes on the same page. And here on our last page, you have your totals. So now you see your currency is formatted for every page, and the report has a footer where there is your page numbers written. I should have aligned it better, but we work with what we've got. You have a date and timestamp on your page for every page. Here in the bottom, you see you have your footer, you have the date and timestamp. Now you can go ahead and save this to your computer. So now that you created your paginated report, you're all set to upload it to the Power BI service. All you have to do is go to your Power BI app, to your workspaces. You select the arrow next to the advanced and turn on dedicated capacity. Now, if you cannot turn it on, you need to ask your Power BI admin to give you the permission to add the workspace to the dedicated premium capacity. Choose an available dedicated capacity for this workspace if necessary, and then save. If your workspace isn't a premium capacity, alas, then you cannot upload your report. You will get the message unable to upload paginated report. Then you can go ahead and contact your Power BI admin to move the workspace. If you do successfully upload these paginated reports in your new workspace, you can simply go to Get Data and navigate to where you've saved the file and open the file. Power BI will import your particular file and you see it under your reports on the app list page. You can then go ahead and select your report to view it, and that is how you can view your paginated report in the Power BI service.
Here is another question. What is the primary function of Power BI Report Builder? And the options are given on the screen. If you know the correct answer, please leave it in the comment section below. Following a look at report building, we'll shift to creating Power BI reports on PUBG data. This practical module will guide you through applying your skills to real-world data sets.
So by the end of this demo, you would be able to answer basic questions on what are the basic views on the Power BI desktop, how to import data sets into your model, how to transform and edit your data set, how would you create a report on the Power BI desktop. I'll be also giving a few visualization tips and helping you out with a few custom visuals. Before ending, I would like to talk a little bit about the Power BI mobile app and the ideas at the Power BI website. So with that, let's move to our Power BI desktop. Now here I've had it open from some time, but if this is the first time you are using the Power BI desktop, you might have, say, a yellow pop-up which shows various different videos and tutorials. But you don't need those tutorials because you have this tutorial. So without wasting much time, let's get right to it. So since you're using this tool, I'm assuming you guys have already pulled in some data for your report already. Here is the Get Data button. It gives you a bunch of different sources. We have the Excel, we have the SQL Server. You can even scrape off data off the web. I'll be using Excel data. These are some of the data sets that I'm going to be using today. We have a bunch of data regarding the bikes that are going to be introduced in 2018, and we have our PUBG data, something because of which a lot of you might be present here today. So all you have to do is click on it. Yeah. So once your data is imported into the model, it should look something like this. You should be able to see a preview of your data. Since I have already loaded this data, I am going to cancel it. But for those of you who haven't, you can just load it here. So now when you have imported your data, your view should look something like this. This is your report view. This is where you make your report. It's a nice blank space. Yeah, it's also called a canvas. There is a visualization pane here at the right. It gives you access to a bunch of different charts to visualize your data and analyze your data. You get access to a gallery of custom visuals from here, the marketplace. And also from down here, you can pretty much control everything about the appearance of your visuals. Further right, you see the data sets that you've imported into your model. I've got a bunch of different bike sets and some PUBG players data. Okay, now this is another view. This is your data view. You basically get the preview of what your data looks like. So I want to point out a few things before you begin actually creating a report. Try renaming all your columns into how you would like to see them in your dashboard or your report. You must always remember that you are creating this from a user perspective. So your naming conventions and data types are going to appear at the surface to your user, and you want it to be as interactive and comprehensive as possible. So I've already renamed everything right here. Another thing, that anything that's not absolutely necessary in your model, just delete it. Because it's basically going to contribute to the size of your model and take up way more system resources while processing. Here I have nothing to delete, but I think I shall be hiding this column because nobody needs to see this. Just a right click and hide in report view. As you can see, this entire column has been grayed out, and once you go to the report view, you won't be able to see it. Okay, so this looks good. I don't want to spend much time on this. I only wanted to show you a gist of how you can make these changes to the model. So let's start building some charts. Building charts here is very simple. On the Power BI desktop, I'll be using the bikes dataset as I had mentioned before. All you have to do is take a field and drop it on your canvas. I am going to take the type of bike, drop it on my canvas, and the count, and drop that on my canvas as well. Change it into, say, a column type chart. As you can see, a bunch of all the bikes that are going to be launched in 2018 are going to be the cruiser bikes. This dataset consists of the top 50 bikes that are going to be introduced in 2018 or already have been introduced. So at top we have cruiser bikes, then we have a few cafe racers and super bikes, and a few others. Now let's try a few other graphs. Okay. Remember to click outside of the box when you want to take a new graph, else it'll change your graph like it did to mine. Let's take this line chart for example. You can also use a KPI, but I prefer the line chart here. I'll take the month and drop it, and the number of units and drop it. Great. As we can see, there have been spikes in the March of every year. For some reason, people love buying bikes in March. Next, let's just try something new. Let's just add a multi-row card. I'll just keep adding fields. Let me just add, say, the name of the bike, the company, the type of the bike, and let's say the on-road cost of the bike. We have some Ducati here, some Bajaj, some Triumph, a lot of Triumph, some Royal Enfield, some Harley Davidson, and so on and so forth. So this is basically the easiest report that you could make. It took barely like 2 minutes and hardly 10-12 clicks. So the great thing about these visuals is that it is so interactive right from the bat. All I have to do is select one bar and it's going to show that on the table. With the line graph it works a little differently, but you get my point. Another thing is I can change and control how my report looks visually. So let's just add a text box. Let's say, bikes of 2018. You can just choose a font that you like, a font size that you like. I'll choose a 60. Let's just put it up top here. Anything that you feel would make your report look more beautiful, just do it. Along with that, you can add a few images, a few shapes, like a few line, oval, triangle, arrow. I'll be taking an arrow and putting it right here because why not? There. The simplest dashboard ever. Now a lot of you might wonder, I said dashboard a few times and I said report a few times. Mostly these two terms are used synonymously, but what is the difference? And I assure you there is one, and a major difference. It's basically how these two are utilized. So a dashboard is something which summarizes the data. You can take a bunch of different data sets and then bring them into one sheet in a dashboard. And a report is something which will elaborate on your data. So basically, you take one data set and you want to show individually for each column what it wants to portray. That is your report. Yeah, so basically, the bottom line here is a dashboard summarizes data, whereas a report elaborates on data. That's my understanding of it. Okay. That's a simple graph, and this is a way more, say, colorful graph. We can see a bunch of BMW, some Harley Davidson, some Triumph. It's so interactive and I don't even have to do anything. All I have to do is make a few graphs from the same data set. And everything else is taken care of by the Power BI. Go to the formatting tab, data colors, and choose all the colors that you want it to have. As we can see, if we select one, you can see the cruiser bikes in all different companies. Here in the pie chart as well, the donut chart, I'm sorry, here in the tree maps. But out of all these bikes, I have a certain favorite, and I'm sure a lot of you might have it as your favorite. That's the Harley Davidson. Come on, let's face it, it's a very, very cool bike or set of bikes. So here I have on the map of the Indian subcontinent all the different dealers that have their showroom for a Harley Davidson. The red ones are the cities which have one dealer, yellow 2, and Bangalore, being the only city with 3 dealers, is in green. And here we can see the number of units of Harley sold since Jan of 16 till December of 2017. Again, like I had mentioned before, for some reason, people seem to buy a lot of Harleys in March. There you go. If I select a certain city, it gets zoomed in the map. That's just how interactive this tool is. So of course, I can go and change the format and order of these visuals. Next, we have a lot of people must often create reports on a weekly basis. This is where sorting comes into picture. Look at this graph. I mean, when you look closely, you can see that the days are ordered alphabetically by default. Now, the Power BI does not know that your sales by days refers to the days of the week. So obviously alphabetical order, so Friday comes first and Wednesday comes in the end. Very logical according to Power BI, but we all know it's wrong. So we have to fix it. You have to tell Power BI that these are not just words, but days of the week. So we open the data set it's from. It has days and sales. We're going to select the days column and go to the modeling tab here, and there is something called the sort by column. Go there and select the order. And there you have it. It's fixed. Monday comes first, Sunday comes in the end. I wonder what office this is, which is even functional on Sundays, but it makes for great data, so who cares? Another thing is this funnel chart. As we can see, a funnel chart is supposed to look like a funnel, which it clearly does not. If we sort this out, then we can just select the stage and go to the sort by column and select the stage order. There we have it. Our funnel looks like a funnel. As you can see, it starts with the lead, then potential, and comes down all the way to the number of deals closed. This is a proper order, and with that, I am here at the last. This is the last from this particular data set. It's the last update. So another thing you can do with the Power BI is see how fresh your data is and when it was last updated, right? So you can do it a lot of ways, but I prefer the edit query editor function in the Power BI desktop, or a lot of you might know it as the Power Query. All you have to do is select this, go to your home and edit query here, like so. Then you can create a query, like here I have the last updated query. You can just close and apply. And there you have it. You can simply create a query like so, and here I have given the formula for your live date and time. You can even append text to it, but I like it this way. It's simple. So just like that, it creates a dynamic text string, and you can use it in maybe like a card, like I have used this little icon 1 2 3 written on it. That's the card visualization. This is a live tile and it changes with the data set underlying it. So you can do things like turning off the label or making the text a little bigger, a little smaller. All you can do is you can go to the data label, and here you get the text size. You can increase the text size, you can decrease the text size. And every time you hit update, it gets updated. Pretty useful, yeah? Now let's move on to our next segment of the module, that is conditional formatting. For this, I have a separate data set, and that is probably the data set which this thing is getting sold on. So I think I should explain this data set and where this comes from. A lot of you might know it, a lot of you might not, but this looks pretty morbid with all the bombs and weapons and the death and all. Now, how many of you have heard the game PUBG? Heard of the game PUBG? Can I have a show of hands? Okay, great. So for those who have, for those who haven't, it's one of those player versus player games where you go around killing a bunch of your friends. It's great. Some good, clean fun, right? But what's better is that all the data that you've generated on the game is available through an API. So I've acquired these datasets using various gamer tags, and it has an entire history of how many minutes you've played, what weapons you've been using, what maps you've been playing on, how many you've killed, how often you've been shot, all this great data. And I thought it would make for a great demo. So here we go. I have two data sets here. One is a PUBG data set which has all the ways people have died, the killer names. It's a set of 100 different players. And another one I've got here is a player's data. It consists of 20 specific players and their kill to death ratio. The KD ratio here is the kill-die ratio. Let's just call it that. All right, so let's go to our dashboard. Conditional formatting. This is already done. Let me bring it back to its basic state. So yeah, so one of the most common things people say is that I just need to be able to change the color, which is pretty basic formatting. So my answer to them is, here is this paint roller sort of icon. You can click on it and you get this option called data colors. And of course, you can always change the color of your data depending on your company color. Like I can change this into a green, or maybe say a lighter blue. It's great for anybody that's colorblind. Yeah, but what you could also do is that you can change this into a color dynamic pattern instead. You can obviously just add solid colors, but you can also change the color saturation according to, let's say, the number of absolute kills. Let's take this field and drop it at the color saturation right here. There. So green being good, red being bad. Player number 20 seems to have the best kill to die ratio, but as you can see, he isn't doing pretty well in the absolute number of kills section. Whereas this player right here, this player number 15, has a lower kill to die ratio, but has a better kill record, let's say, than the player number 20. A lot of killing talk going on here. I assure you, this is no real world data. It is just the game. So this is a PUBG dashboard that I've created. This graph obviously shows the previous graph, which I showed for conditional formatting. Here, this is a map which is based upon where the here is a map which is based upon where each player is from. there is something very important I have to show you about the map. So let's just open the player's data in the data view. Now, as you can see, it has a latitude column and a longitude column for each player. Now, your MSBI just will notice that these are numbers. We have to tell the MSBI that all these numbers here are latitudes and all these numbers in this column are longitudes. So what are we going to do? We're just going to go to the modeling tab, select your column, data category, and by default it is usually uncategorized, but you're going to set it to the longitude. And same goes for the latitude. I've already set the data category. That is how I've been able to make the map, else it wouldn't take on those numbers. Now, here's a pie chart which tells how most people have died. We have down and out, which is most people. Then we have the M416, and then we have the M16A4. Pretty popular ways to die. I'm just happy this isn't real data. Just putting it out there. Another thing you can do is make use of the cross highlighting to know specific data. So here I have made two different charts, a bar chart and a column chart. Here it shows how a bunch of people have died, and here it shows who has killed those bunch of people. Like, this is player data, and once you select any player here, it just shows how they've been died, how many times they've died and how. So again, down and out from the grenade and the M24. If I choose another player, it shows the same. So MSBI is always this interactive. The MS Power BI is always this interactive. It's just how it was designed. It was designed for those people who didn't want to code in the background, or let's say who couldn't. So anybody who can visualize data can use this tool. Next, we have a few other graphs. Like, I really like the scatter chart, so I made it according to players right here. It shows how they've performed. The bigger the bubble, obviously, the better record they have. On top, we have the legend here, which shows the color assigned to each player. Next, we have our custom visuals. So I'm going to be using the KPI visuals here. This is the basic KPI, this ticker looking icon over here. It has a red and a green ticker. Basically what a KPI does is it will answer two questions. Firstly, how far or close to your goal are you? And secondly, what has been your performance over a period of time? So all the companies use this KPI, or the key performance indicators, to monitor their internal and external performances. Internal as in team-wise performance, maybe the performance of the marketing team or the sales team, and external performances as in the overall performance of the company in the market. So these are a bunch of custom visualizations. Remember, I had mentioned right in the beginning that you could go to home and there's something called from marketplace. I'm going to select that. Here you can choose from a bunch of different custom visualizations, but since we are using KPIs, let's just select KPIs. And right at the bottom, you will find something called the KPI indicator. All you have to do is add it to your model. I've already added it to my model, and it will appear right here in the visualization pane next to all your other visualizations, and you can use it just as easily. So the thing about these custom visuals that I really like is the solid background color that you get. It really makes your reports pop, and the graph here you can see is in solid lines and you get variants of the same graph. So suppose I take this, I can go to the formatting tab and choose KPI colors and choose the background color. You can go to KPI general and choose your chart type. So we have 3 different charts here. We have a line, which this chart is. Then we have a line and no markers, and you can see all the bubbles here are gone. And then we have a bar chart. Pretty simple, right? Then we have something called the banding type. Increasing is better, decreasing is better, or closer is better. So there are 3 cases. First, say something like the money you've acquired over a period of time. The bigger the better, right? So in such a case, increasing banding type is better. But what if it's about the money that you've been penalized to give? For such a thing, I think a decreasing banding type is better. That's where you put the decreasing banding type and see, your entire graph turns red. And then we have the closer is better. This is an option which is not available in your basic KPI. You'll have to use a custom KPI for it. So when you have experimental data, like say drugs or medicines, the closer it is to your ideal data, the better it is. In such a case, closer is better. Now the prerequisite for KPIs are you must always have a target value. So this is the bike sales chart. If we just open it in the data view, so this is what a KPI appropriate data should look like. It should have an actual value column and a target value column and a trend. This is how your key performance indicators are made. Now I think we've already made a pretty big report, so I think we're ready to publish this. So there's a publish button in the home ribbon right at the corner, extreme right here. All you have to do is press the publish button. And here at the Power BI website, it gets uploaded. You can see how it's as interactive as it was on the app. Nothing has changed. Yeah. So the best thing about this is you can even use it on your desktop, but you can even use this in your mobile apps. And this is a pretty open data set. Like I can share it with a bunch of different people, which is the reason why this data is on YouTube right now. But a bunch of you might be using Power BI for, say, company purposes or really confidential data. In such a case, you would want it to be with a limited number of people. So for that, there is an ellipsis right here, these 3 dots on the extreme right. What you can do is select the option Generate QR Code. Now a QR code connects anything in the real world directly to the related BI information. You don't need any navigation or search. So the colleagues you've shared the dashboard with then can scan the QR code for access to your tile or your report right from their mobile device. They can use either, say, the QR code scanner located in the Power BI app, or the mixed reality app, which is also from Microsoft, or any other QR scanner which is installed on the device. All you have to do from here is you have to download it, and then it will be saved as a JPEG image, and then you can mail it to people or print it out, whatever, it's your choice. I hope you found all the ideas and the tips that I've given really helpful. There is actually another place where you can go and search for ideas. It's ideas.powerbi.com. This is a forum basically which shares ideas about Power BI, and when people have queries also they come here. Let's see, the top search is copy paste from Power BI desktop. Seems to be pretty popular because people want the copy paste functionality from Power BI to their reports in Excel and so on. We have a few more ideas. Even if you have ideas of your own, this is a place where you can share them as well. Just had to put it out there. With that, I think I've concluded my session about the Power BI desktop and how to create impactful reports on it.
After working on PUBG data reports, we'll now cover IPL Data Visualization with Power BI, where you'll learn how to create visualizations specifically tailored to IPL data.
IPL Data Visualization with Power BI. So if you're someone who's not from India, IPL is the Indian Premier League, which is a professional 2020 cricket league in India, and it is usually contested between March and May of every year by 8 teams representing 8 different cities or states of India. Now, the league was founded by the Board of Control for Cricket in India in 2007, and it's been going on since then. So today what we'll be doing is we'll download the IPL data set from Kaggle, and we'll visualize this data set on Power BI. You can see that I have Power BI desktop on my desktop. And once I click on that, it will just allow me to get started, and I have pop-ups that occur. So first thing what we're going to do is we're quickly going to talk about the interface. So the interface is very interesting. It's very easy to understand too. It's not very complicated. You can see you have a menu on top. You have, as usual, file where you can create a new file. You can save those files. You can get data. You can import, export. You can check out options and settings. You can also get started. You can sign in. You can read about Power BI too and things like that. Okay. Once that is done, you also have home, and this will just redirect you to the home page of Power BI desktop. You can also insert new pages. You can add a blank page. You can add duplicate pages. You can add visuals. These are a little more complicated as of now. We don't really have to discuss this, but maybe elements are important. You can add text boxes, buttons, shapes, images. All of this may be useful later on. Also in the modeling option, you can add tables, you can add new parameters, you can choose a language, that's great. And in the view option, you can pick themes, right? There's current default themes, you have city park, you have classic theme, you have classrooms, you also have page views, you have mobile layouts, and you also have filters. You can put grid lines if you want an idea of how to create your visualizations, all of that. And if you want any help with the community of Power BI, Microsoft has a great set of community. You have guided learning, you have training videos, you have documentation, you have various examples. This is great. Okay. So once that is done, I'll just quickly switch back to home, and you can see that this page that we currently on, that is home, is very, very important. Okay. This is where you'll be mostly working on. So this is pretty important. Here you have the get data option, and this is where you're going to import your common data sources. This is where you're going to be getting your data sources from. So you can get your data sources in form of Excel sheets. You can also get Power BI data sets, data flows. You can also get in terms of SQL Server, text or CSV files, even via web, and also blank queries and much more. You have a lot more options you can get your data from. Okay. And you can also import data from a Microsoft Excel workbook. You can create a live connection to data sets in the Power BI service, that is cloud service. You can also obviously import SQL Server database, which is really important. Most of the organizations work on SQL Server, so importing data from SQL Server might be a very, common option when you're working on Power BI. So they've just given a separate icon to import data from a SQL Server database. And you can also create a new table by really typing or pasting in new content. You can create your own database, right? If you have small content and you want to go ahead and create it yourself, you can just enter data by yourself by clicking this option. And the data verse option will allow you to connect through its SQL endpoint. This is not really that important for now. And you can also manage and connect to recent resources. Right now, we don't have any, so it just says more. You can also transform data. Okay. So this is a really interesting option that is present on Power BI. You can really, add queries and transform data as you'd like to. So this will really allow you to do that, right? Transform data. And moving on, you can create new visuals, you can add new text box, you can create more visuals, and a lot of things. So I clicked the create new visual and it just created a new visual for me. I'm just going to remove this for now. Okay. And you can create new measures. There's an option for calculations. There is an option for sensitivity, and you can also publish it. You can share it with your friends. So these are few options that are available at home. Now, if you look at the bottom, you can see page 1. If you want a new page, you can click the plus icon and it will create a new page for you. And you can just shift around with your pages. Okay. And if you click another plus button, it's just going to shift you to page 3, page 4, etc. If you want to delete it, you can just click the delete option, the remove option, and it will delete the page. Okay. We don't need 3 pages as of now. So I'm just going to delete all of the pages except page 1. So that is done. Now the interesting part is you have filters, you have visualizations, and you have fields. You can just click on these arrows to hide all of these options. And since we're going to be learning about them, we'll just open them. So the filters will allow you to search any of the data fields that are present here. You can add data fields that are there. And the visualization is the most important part. So fields will just allow you to really import the data. If you import the data, all of the data and its tables and the entire content of the data that you've imported will turn up in the fields option. We'll see that when we download the IPL data. And when we import that, you'll be able to see the data here. Okay. So once that is done, you can visualize the data. So you can just drag and drop the data and you can choose various visualizations. You can choose a bar chart. You can use a pie chart. You can use R script visualizations. You can use tables. You can use matrix tables. You can also use charts, and you can also use maps. You can really visualize these data in various forms, like forms that you could never imagine. And that's the real advantage of Power BI. It will allow you to play through your data and really get a hang of it and, really understand your data in detail. And you can also, add the data fields here which you'd like and then choose the visualization for that data. So you can really have fun with your data using Power BI. Now with this, let's move on to the left side of Power BI. You can see the 3 icons. The first one says report, the second one says data, and the third one says model. Currently, we're on the report option. If you click the data option, the screen changes. And if you click the model option, then the screen will change too. So this will just allow you to create reports and visualize your data in a certain way. This will just give you an overview of your data. So the model option will just make you really identify data sources and create relationships between your data. Currently in this session, we'll just be working on reports, so we don't really have to bother with data and model. And this is all for the user interface. It's pretty easy, right? It's not rocket science. It's very easy. Now let's go ahead and download our data set. Now I'm just going to go to Google and click Kaggle. If you aren't part of this community where you can download any data for free, then you've definitely been missing out on a lot. Definitely sign in and create an account on Kaggle because you'll be able to download a lot of data sets and really, work on them. I'm just going to search for IPL data set and I'm just going to scroll a bit down. And you can see here there's a data set by Prateek Bhardwaj, and there is a complete data set of IPL from 2008 to 2020. I'm just going to click on this. Now let's see what he has on his data set. So you can see that there are two data sets. One is ball by ball and the other one is matches. Okay, so I'm happy with this. They're just two files and we'll just import both of these files. And I'm just going to click on the download button, and this will automatically download the zip file of this data set. Once that is done, I'm just going to check out the first data sets, that the ball by ball data sets. Here you have the ID, you have innings, you have the number of overs, the number of balls, the batsman, and non-striker, bowler, batsman, extra run, total runs. You have a lot of information. The bowling team, there are around 8 teams in the IPL. You can see that that's mentioned here. There's batting team, there's bowling team. And this just gives you a ball by ball information. That's a lot of data. Okay. I'm just going to close this, and then we're just going to check out the matches data set. Here you can see the ID, you can see the city, the date, you can see the man of the match here, the venue, and you can see the teams who won the toss and what was the decision after they won the toss, the winner, the result, and there are a lot of information, the umpires of the match. All of that is given in the matches data set. So this is great. I am happy with this data set. So I'm going to go ahead and import this in my Power BI desktop. So now I'm just going to click get data, and I'm just going to click text to CSV. Just going to go to downloads, archive, and I'm just going to import ball by ball first. And I'm just going to click load. Now you can see that automatically in the field section, all of the data in the ball by ball data set has been automatically loaded and placed in the field section. Now I'm just going to again click get data, and I'm just going to click text or CSV, and I'm just going to click IPL matches data set, and I'm going to open that. I'm going to click load. Once that is done, you can see that you have the IPL matches data set in the below, and I'm just going to click this. Okay, and you can see that you can just click these buttons to really select the data that you want to use. Okay, now what we're going to do is we're going to visualize some data. Okay, so let's visualize the batsmen that have been playing in IPL. Okay, so what I'm going to do is I want to view the batsmen that are currently playing in IPL, okay, from 2008 to 2020. So I'm just going to drag batsmen and I'm going to drop it in the between. And you can see that there are a list of batsmen according to the alphabetical order. Now, if I want to visualize this on a column chart, I am just going to drag batsmen again, and I'm just going to add it in the values field. And this will just give me an overview of the count of batsmen by batsmen. Okay, as you can see that Virat Kohli is currently the batsman who's made the most number of runs in IPL, followed by S. Dhawan. So now that we have represented the count of batsmen in the form of bar charts, what we're going to do now is we're going to give colors to each of these. So we're going to change the colors of this. So what I'm going to do is I'm going to click the paint bar icon, and I'm going to click on data colors. Once that is done, if I scroll down, you have the option that says off. Okay, it says show all off. I'm just going to click this to on. And you can see that you can really select colors for each of these, because Virat Kohli has been playing for RCB, and RCB is represented mainly by red and black color, mostly red from the past how many ever years it's been there. I'm just going to click on a red color for RCB. Just going to click on more colors. I'm going to pick a more precise color. Okay, this looks great. And here you go. You have red color for RCB. And then you can change the colors for all of them, all of the legends. And you can really play around, It's great. So this is to represent in terms of, bar charts. And if you hover your mouse over each of these legends, you can see the names and you can see the number of runs they've scored over the entire course of IPL. It says 4,609, but I don't think it's very accurate. It says S. Dhawan scored 4,208, and then it says RG Sharma scored 4,088, and so on. So the number of runs scored by the batsmen throughout the IPL is mentioned over these legends. So if you want to filter out batsmen only from a particular team, you can just look for them and then just select them and then just make a bar of them, right? That makes more sense. That's one filter you could play around with. You can also add data fields here. Now, if you scroll down, you have an option that says count of batsmen is all. Show items when the value is less than 4,000 and is greater than 2,000. And I'm going to apply this filter. And you can see the list of batsmen. The first one is David Warner. The second one is R.V. Uthappa, Gautam Gambhir, and so on. So you can really, play around with queries also on the filter side. And you can visualize on the visualization side. And on the field side, you can pick your data. So this is amazing, right? Now let's create a pie chart for the bowlers. So as usual, I'm just going to grab my bowler and I'm just going to drop it on the page. And you can see there's a list of bowlers that are mentioned here. So what we're going to do is we are going to click the pie chart option. And what we're going to do is we're just going to again drag bowler here and then going to add it in the values field. That is, we're going to drag and drop it in the values field. So as you can see, there are a lot of bowlers. The first one on the list is Harbhajan Singh. So we're just going to make this list a little more small. So as you can see here, the pie chart already has various colors assigned to various bowlers, right? This is not the case in the bar chart. So that's the disadvantage. If you want to represent different teams or different bowlers or batsmen in different colors, in a short amount of time, if you don't have that much time, you could just pick a pie chart. So what I'm going to do here is I'm just going to add filters, okay? So count of bowler is less than, maybe you could say 2000 and is greater than 1000. And I'm just going to apply this filter. You can see the bar is much more better in visualization. I'm just going to move this in the side. You can reduce this more if you'd like to. So in page 1, what I've done is I've just represented the number of batsmen and their runs, and also the number of bowlers and the number of balls they have bowled. So I hope this is clear. It's really simple, right? It's not really that complicated. There's a lot more to learn when you keep exploring Power BI. So let's now go to page 2, okay? Now what we're going to do is let's scroll down. Let's look for something interesting. Let's look at IPL matches dataset. Let's represent toss winner, okay? I'm just going to grab this and I'm just going to drop it in the page. And I'm going to represent this in the form of a donut chart, okay? I'm going to again grab toss winner and I'm just going to add it in the values field. And if I make this big, you can see that Mumbai Indians has won the most number of tosses in IPL. Throughout all the IPLs, Mumbai Indians has won the most number of tosses. Okay, moving on, we have Kolkata Knight Riders, then we have Chennai Super Kings, followed by Rajasthan Royals, then we have RCB, and then we have Kings 11 Punjab, and so on. This is a really nice way to represent a small amount of data, the donut chart, because it's very evident that Mumbai Indians won the most number of tosses. Let's create another page. Let's also check out the venue. Let's represent the venue, okay? I'm just going to drag and drop this. I'm going to represent this as a bar chart. Again, I'm going to drag and drop the venue in the values field. And I've represented in the bar chart, okay? So what I'm going to do is I'm going to make this a little big. So you can see that the number of matches that are played in Eden Gardens, Kolkata is the maximum, that is 77. And then we have the Firoz Shah Kotla Stadium, then the Wankhede Stadium, followed by M. Chinnaswamy Stadium, and etc. The list goes on. So the thing about Power BI is that you cannot manipulate the data. You cannot make changes to the data set. Okay. All you can do is you can visualize it in any form and you can just reduce the size of the data and you can also view what particular data or specify what kind of data you really want to see, but you can't really make changes to the data. That is important to know. And again, you can add a lot of filters like is less than or equal to, is greater than, is not, is blank, is not blank. All of that filters can be easily added so you can represent your data. There's an interesting data that is available that says winner. So let's check that out. I'm just going to drag and drop this. And then I'm just going to click on pie chart. I'm just going to drag and drop winner in the values field. And you can see that again, Mumbai Indians has taken over by winning 120 matches, followed by Chennai Super Kings by winning 106, and then followed by Kolkata Knight Riders, and then Royal Challengers Bangalore, then Kings 11 Punjab, Rajasthan Royals, and so on. So this is really what Power BI is all about. You can play around with all of the data. There's so much data, especially in the IPL data set. You have batting team, you have extra types, innings. I showed you the most basic ones, but if you're really interested in knowing the intricate details of all of these IPL teams and really understanding and getting an insight of the past, form of all of these teams, you can really represent these in terms of all these visualizations, add filters, really play around. You don't really have to put a constraint to yourself. I have just showed you the most basic things. I have created a bar stack. I've made use of a bar chart. I've made use of a column chart. I've just made use of a donut chart. And then also I've made use of a pie chart. I've also made use of the basic fields, that is the batsman, bowler, the venues, and the winners who have won the number of matches, and things like that, the venue also. So this is really basic, but I hope this helps you to give a kickstart to your IPL data visualization and you really get to play along with it more.
With IPL data visualization complete, our next topic is sales analysis using Power BI. This module will focus on analyzing the sales data and deriving actionable insights.
Our first project or first case study is an end-to-end sales dashboard. In this case, what we are going to do is that we are going to explore the internal sales data set of a mock company and analyze it from the perspective of business. We are going to look into different products, employees, and supervisors to determine their individual impact and overall impact on the revenue of the entire company. And for that to happen, we are going to design and create a sales dashboard in Power BI, which we can publish and share on Power BI service. There are a couple of actionable items that you can see in front of you. We are going to tackle each of these actionable items one by one. So let's move on to our demo machine. So this is how Power BI Desktop looks like. This is the latest version as of the March of 2020. Before we begin, the first thing I'm going to do is I'm going to get data. This is an Excel spreadsheet, so I'm just going to get it real quick. Okay. Now, as you can see, this data set has three different tables. We have the employee master, which has the employee ID, employee names, and the supervisor under which the employee functions. Then we have the product master, and this has the product ID, product name, and the price per unit. And we have the sales data. Now this looks more like a fact table, which has the date, the employee that made the sale, the item sold, and the number of units sold. And these are all of our tables. Now, if you are happy with your data and you think it is a usable data model on which you can directly go and build up and lay your analytics on top of, you can click on load. But I'm going to transform this data and clean it up a little bit before I start using it. This is going to take some time. Now what this does is it opens up your data in something known as a Power Query Editor.
Now, one of the reasons why Power BI is such a powerful tool is because it has the query editor where you can navigate, define, and perform data transformation operations over a data source. You get the option of transforming your data on the query editor whenever you connect to a data source. You can create a new query or load an existing query. It's completely your choice. It's basically this dedicated window which facilitates and displays your data connections and your transformations that you're going to apply to that data set, the data set with which you started, all the way to the data set which you have reached here in the applied steps section. So let's go ahead. So the only change that I want to make is in product master. Here I'm going to change the data type of this particular column to fixed decimal number. Basically, I'm asking Power BI to consider this column of values as prices. Yes. And here in the applied steps, as you can see, it automatically added a step called changed type. And I think everything else is just fine according to me. So I'm just going to close and apply. This is going to take a while. Kindly be patient. It's going to take some time and it's finally done. And here on the right, you can see all of your fields and their sub fields when you click on the drop down icon. So starting out, people who are new to this is your canvas or your report view. Here is where you're going to be creating your reports in Power BI. The next is your data view. Now this is the view where you can look at your data. All right. You can also make edits to your data using any of these ribbons available to you and the options in them. You can click on separate tables and view them individually. And finally, you have your relationship view. Here you can see various tables are connected to each other. How are they related to each other? As we all have seen before, we have three tables, two of which are dimension tables, which are your employee master and your product master. And one of them is a fact table, which is your sales data table. Now, in our case, Power BI has already established a connection because it's smart enough to do that. It just identified common columns between our tables and made relationships through them. But just in case Power BI could not do that in certain cases, we do not have common names in two tables. I'm just going to show you. I'm going to delete this relationship. Yeah, you can easily do so yourself by long pressing on the column name in one table and dropping it down to the column where you want to fuse it to the other table. And voila, you have a connection there. You have a relationship established. Now, what you need to understand is that once you've connected two tables together, in our case, three tables, with a relationship, you can work with the data in both tables as if they were a single table, which frees you from having to worry about relationship details or flattening different tables into a single table before importing them. In many situations, as in ours, Power BI automatically creates these relationships. And as I spoke about it before, I cannot emphasize enough that while Power BI is actually smart enough to do this for us, if Power BI cannot determine with a high degree of certainty that a relationship between two tables should exist, it does not automatically create this relationship. In that case, as I just showed you a few moments ago, you can create the relationship yourself by dragging your column from one table to another. Now, this has a couple of advantages. Now, because our entire data set is being treated as one table, you can add a column to one table, picking out data from another. Now we've come back to our table view, And what I intend to do here is to create a calculated column in your sales data table. Now the calculated column is going to be for revenue, and it's going to have two different components. One is the units sold, which is available in this very table, and the other one is the price per unit, which is available in the product masters table. So what we're going to do is we are going to come back to our sales data table, and we are going to use DAX to create this new calculated column. So I'm going to click on this new column, and we're going to name this revenue. And we're going to multiply units sold, and we're going to be using a function here called related, because our other column is not in the same table. It's in a different table, which is a related table. So we're going to be using related and price per unit. And we're going to close the bracket. And with that, we have our new revenue column, and it already comes with its data type changed into a currency based data type. Yes. Now what I'm going to also do is I'm going to change the format of the date into something more usable. So I'm going to use this one just because it's shorter, and that's just how I like it. It's a matter of personal preference, but you could just roll with the format that we had earlier. That's not an issue. So with that, now we are ready to layer some visualizations on top of it. So we are back in our report view. Here is our canvas. So the first thing that I want to do is I want to add a title bar to this entire page, just for the aesthetic purposes. So I'm going to go on to the insert option, and this opens up the entire insert ribbon. The first thing I'm going to put in is a shape. So I'm going to keep this bar black. So I'm going to go into this format shape section, and we're going to change the filled color to black with no transparency, and we are going to change the line color to black as well. Then we're going to go ahead and add a text box. Here I'm going to name it mock sales dashboard, because we are using mock sales data. I'm going to increase the font size to a 24, and then bolden it and change its alignment to center alignment. And then what I'm going to do is I'm going to change the text color to yellow. So I'm going to maintain this color scheme throughout. I'm going to maintain the Power BI standard color scheme, which is yellow and black, and that's what I'm going to follow throughout the course of this video. So I'm going to go on background and I'm going to turn it off. Okay, so this looks better. So let's go back to our presentation and see what all is there on our actionable items list. So we've already cleaned and transformed our raw data, and now it's a usable data model that we can build analytics on top of. Next, we have already established the relationship between tables. Now start the actual actionable items, which is to create filters to drill down upon data. So here we have 3 filters that we have to create. One is by date, one is by product, one is by employee. But I'm going to do one better. I'm also going to be creating a drill down, say, for supervisors. Then we'll build further from that. For the whole selective drill down purpose, I am going to use a slicer. And the first one I'm going to do is for date. So I'm going to just drag the date column from the sales data onto our field here. Okay. Let's just resize it. And All right, I'm going to make it slightly smaller. And as you can see, it is a slicer with our start date and end date. And as we slice, we will only be viewing data in between the date range that we have selected. Now this looks kind of really bland here, and it's not really going with the color scheme that we have selected. So what I'm going to do is I'm going to do some conditional formatting on this box and try to make it as eye-catching as I can, while adhering to my original aesthetic. So next to this field section, you have this paint roller-like option, which is the formatting section. Here I'm going to go down to the background and I am going to make it yellow. I'm also going to go up to border and like turn it on. I'm going to add a little bit of radius to this just to make the box slightly curve out in the edges. Then I'm going to go to date inputs and keep the font color and background as is. Maybe change the background color to yellow and increase the text size. All right, I'll keep the font family as is. Let's go to general and see if we can do something. I am going to change the outline color. And change the slider color as well to black. Then I'm going to keep. So with that, I think I'm done. I have created my first slicer. And by clicking on the date, it also opens up the calendar for that month. So you're sure of what date you're picking. Okay, I'm going to bring it up a little bit. So with that, I think our date slicer is ready. Now I'm going to copy this a couple times so I can create other slicers without having to do so much work. So this is our next slicer. I'm going to remove the date from this field and I'm going to add the product ID into this field. And this is definitely not what I had in mind. So here's this little button, this downward arrow inside the visualization, which has two options, which is list and drop down. So I'm going to select drop down. And then I'm going to go to this ellipses sign, which is these three dots, and I'm going to add a search bar. So now you can search for your product ID. Similarly, I'm going to copy this. Let's rearrange them so that we can fit another two slicers in there. So in the next slicer, I am going to cut out product ID and add product names. We already have a search option, a search field inside these slicers. Now I don't think I can fit in two more slicers in there, so I'm just going to resize these a little bit. And as you can see, I have some visual guidelines from Power BI, which are helping me do the job and keep my visualizations aligned. I hope they are the same size. If not, honestly, let's move on. So two more. So here I'm going to remove the product name and add the employee name. And our final slicer is going to be a supervisor slicer. I'm just going to move all of these slicers a little bit so I can fit this slicer in here. And by the grace of God, we have all survived. And I can go ahead and add this extra slicer, which was not asked of me, which I went out of my way to add. So now let's go ahead and see what else is asked of us. Now what we have to do is determine the sales by revenue and number of units sold. That's pretty simple. We already have that data in our tables. So I'm going to go ahead and I'm going to add a card. Now again, in the fields field, I'm going to drag the revenue column that we have created. And I'm going to go through some formatting to make it match our aesthetic. Go on to data label. For this, we are going to color all the text in yellow. Keep my value to 2 decimal places. Also, I'm going to go on to the category label and change the color to yellow and increase the text size by a little. So then it all stands out against the black background that I'm going to be putting right now. Now again, we're just going to go to our border, turn it on and add some radius. So it kind of has a curvature to it. So I'm pretty happy with this card. So I'm just going to copy it to make a card for the units sold as well. So I'm going to cut out revenue and I'm going to drag the units sold to its field. And now we have 2 cards. So next, what do we have to do? So moving on, what we have to do is we have to determine the revenue generated by each employee under each supervisor. So for this, I'm thinking of a visualization which will have a drill down capability. For this, I'm going to create a hierarchy starting from the supervisor and then having the employees under them. You'll get to know what I'm talking about in a while. So for this, I'm going to pick a donut chart. The reason for me picking this donut chart is that I can use this very nicely to create a chart which I can drill down into. It has plenty of space for displaying information inside and out as well. So here in Legend, I am going to put in supervisor on this field, and in values section, I'm going to put in revenue. Also under supervisor, like I said, I want to create a hierarchy. So I'm going to put in the employees under supervisor. And as soon as I do that, you can see this arrow mark has appeared. And as soon as I do that, you can see this double arrow mark appear. So I'm going to click on it and I can see all these different employees and the revenue that they have generated. I can go back up. Here I can drill down, click on drill down, and I can click on this drill down icon, and all I have to do is click on a data point to find out everything about it. So what I'm going to do now is again go to the formatting pane, and I'm going to first change the data colors into something more flattering. We'll keep a yellow, a very dark gray, and a blue. Also want to add a bar or a background color to the title. So I'm going to turn that yellow and align it in the center. I'm also going to increase the text size by a little. Just going to make it 21. This seems okay. And we are going to use Seago, which is the one we've been using throughout. So yeah, that's about it. So now if I want, I could drill down, I could drill up. I can use this drill down button So now if I select any supervisor, I could get employee-wise data under the supervisor, under said supervisor. So I'm going to drill up. Okay. And as far as I remember, now what we have to do is we have to use a visualization to give us the daily growth in revenue. So for that, I'm going to choose an area chart. Honestly, you could even use the line chart for this. I just prefer the area chart. It's a matter of personal preference. I think it covers space much better and it's way better looking, and you can do a lot more with it data-wise as well. So I'm going to bring date into the axis field here. It automatically turns into a hierarchy of year, quarter, month, and day. But I'm going to click on this drop down arrow and uncheck date hierarchy and select date. And in the values field, I'm going to drop in revenue. So automatically I have a revenue by date. And as you can see, I can control it with the first slicer that we've created. Again, I am going to go ahead and do some conditional formatting in there. Like for example, the data color is in blue, which I'm going to change to a yellow to match the theme of this report. Then the data labels are going to be turned on so you can see the highest and lowest points of the data. I'm going to keep them in dark black and also increase the text size. I'll also be going to the title and changing the font by aligning it to center. The background will be yellow. You know what? Well, let's switch it up this time. We can keep a black background and we'll keep the font in yellow. And we'll bring up the text size to match our donut chart. Okay. Also fix the font to match with the rest. And that's it. You can go ahead and add a radius if you'd like, but I'd like to keep the border invisible. And with that, we have our revenue by date. We can look at all the highest points of our revenue. One is on 23rd of February 2019. A close second is 11th of March 2019. Well, I wonder what happened on those days, but that's just how our data is. So the next thing that we're supposed to do is to diagnose the individual revenue brought by each product. For that, I'm going to create a bar chart. You can select either stacked bar chart or declustered bar chart. It doesn't really matter as you'll be using only one line of values. So I'm going to put in the product name in axis, and I am going to bring in the revenue for that product. I'm going to change it up. And I'm also going to add the data labels to each of these bars, keep them in dark black. And maybe increase the text size a little bit. Let's keep it at 11. And we're going to color our data also in dark black on our y-axis. And that's about it. We're also going to go ahead and match up the title with the rest of the scene. And with that, I think we are done with this particular visualization. Now this till now, I think is pretty basic. We can go ahead and filter out our entire data by date. As you can see, we can filter it out by product ID, drilled out by supervisor. If we wanted to see which team performed the best, and then we could also drill down. We could apply multiple drill downs and slicers at the same time. So under supervisor 1, we have employee 1 to 6. And if we want to see, suppose, how employee 4 performed under supervisor 1 between date 1st of January 2019 to maybe 31st of January 2019, you have the total revenue that he generated for the company, the overall number of units sold. You have his revenue by date. As you can see, he made his best sales in the 19th of January 2019, and the number of products that he sold and the revenue generated by each of these products. Let's just reset everything. Now the bottom of the space looks a little empty. So what I'm going to do is I'm going to add a scroller there. So for that, what we have to do is we have to go to the marketplace, which you can access by clicking on this ellipses sign in your visualizations pane. So I'm going to go to App Source. And this is going to lead me to the visuals marketplace. Here, I'm going to go ahead and search for a scroller. And this is your visualization. I'm going to add it here, and it's going to appear right here at the bottom of your visualizations pane. I'm just going to add that. And let's just bring it to the bottom and resize it. I'm going to bring it here. And in category, we are going to put up, let's say, product ID. And in measures, we are going to put price per unit. And the scroller has begun, but it's not very visible. So we're going to go to Format, turn off the title. So we have the entire space for the scroller. Background is on. We are going to change the text color of the font to yellow. And we're going to change the scroll speed to 1 so that it's slow enough for people to be able to read it. The font size remains the same. And that's about it. With that, we have all the visualizations that we need in this particular canvas or this particular report. Now, what I want to do is I want to insert an image into this mock sales dashboard title bar. And what I'm going to do with it is I'm going to make a button out of it. I'm going to place a bookmark in it so that we can connect this page to the page that follows. Make sense? So I'm going to go on insert, go to image. Maybe I'll find something in my downloads. So let's resize it. And then we can add it right here at the corner. Looks decent in my opinion. Let's rename the page. Okay. With that, we've renamed the page. One final thing I'd like to do is I realize that this is going to bother me till the end of time. So I'm going to go ahead and change the title name so it fits in one line. and bring up the size to just gonna align it. Okay. So far what you've done is you've imported a data set from Excel to Power BI. You have cleaned and transformed the data to create a data model on which you can layer your analytics on top of. You've created this wonderful report with visualization, slicers, drill down capabilities by date, product, and employee. So you've basically created a complete sales dashboard. What we're going to do next is to create a drill down page. For that, instead of creating a new page, I'm just going to duplicate this page so I do not have to redo the header and the slicers on this page. So I'm going to delete all of these visualizations one by one. And also this image. Here I'm going to put in another button. Here in the insert ribbon, we have the buttons option. And here is the back button option. Let's just bring it here. Let's make it big and clear. Okay. I'm going to make the fill color black and reduce the transparency to 0. And the icon I'm going to turn into yellow. Okay. And I'm going to turn on the button text and name it back. I'm going to change the font color as well. And that's about it. All right, now we have a back button, which definitely works. If I'm going to click on the back button while pressing on to control, it's going to take me to my mock sales dashboard, which is my first dashboard. So let's go to our second dashboard, and firstly, let's rename this. We can't just keep calling it duplicate of sales dashboard. Oh, well, let's just call it drill down dashboard. Okay, so what I'm going to do is I'm going to put in a table here, and into that I'm going to enter the date, and as it had happened before, it gives us the entire hierarchy, which we do not want, so we are going to select date. Next, we're going to put in employee ID, employee name maybe. I don't want that. We're going to put in supervisor. We're going to put in, let's say, product ID, units sold, and the revenue. Now let's open up our table so as to fill in the entire space. And in the bottom, we also have our total calculated. We're also going to resize the columns so as to fit the entire table. Maybe there's space for another column. So what I'm going to do is I'm going to also put in employee name. So let's reduce the size a little bit so we can have employee name. I'm going to go up to format, go on style. And there are a couple of different styles given here. Right now we're using the default style. Let's try a couple of different styles and see what we like. Okay, This looks good to me, honestly. And let's go to column headers. We're going to change the font color to yellow. Background color is black. Let's increase the text size by a little. Okay, 14 is too much. Let's go with 12. And alignment should be center aligned. I have this compulsive need for things to be aligned properly. Maybe that's just how I've been trained to think. I'm also going to go on values. Okay, seems like they're all right aligned. Then I'm going to go to conditional formatting, and for my revenue column, I'm going to turn on data bars. All right. I'm going to go to advanced controls and change the color to a light yellow. And here I see all the bars and the values on the right. So what I'm going to do is I'm going to select this row. And if you click on this row, it basically gets arranged in a descending order, which is very desirable. And through this, you can maybe select a particular date, or say 1st of January, and pick a certain supervisor, say supervisor 4. And then look at each of these employees and what they have sold and how much revenue have they generated in total. It's great, isn't it? We know that supervisor 4 on date 1st of January has sold 3 different products, product number 1, 21, and 23, and he has sold around 600 units combined and generated a revenue of nearly 32,000. And we only know that through the power of data analytics. Let's just relieve this of all the filters that I've added. So now let's go back and see what else is left to do. Okay, so we've already created a table view of all relevant data for viewing and drill down purposes. Now we have to connect our pages for better user experience and then publish our dashboard to the service. Now, it might seem a little complicated, but I promise you it's extremely easy. To create a bookmark, we have to go to the View ribbon and then go to the Bookmarks option. You'll have a pane opening like so, and it says that I have no bookmarks, so I'm going to click on Add, and I'm going to rename this bookmark to, let's call it DDD, because we have a drill down dashboard. Also, I'm going to go on the ellipses and uncheck data. I'll tell you why I did this, because we want our bookmark to lead us not to this particular page that we have right now. We want the bookmark to lead us to a page which has already been filtered by the filters applied on the previous page. All right, hope I'm making sense. Now we have our bookmark. We're going to go back to our first page. We're going to select this option. And we're going to open the format image, where I'm going to go down to action and turn it on. We are going to select action type, which is obviously a bookmark, and select our bookmark. And in the tooltip, which is going to just display a text, if we hover on this icon, we are going to say click to view drill down. Okay, that seems like it. So now if we hover over this, it says click to view drill down. And if we click on it, it leads us to this page. And just to clear what I was speaking of previously, if I drill this page down per a single product, when I view my drill down, it is supposed to show me. So now that we have everything that we need, let's go ahead and publish this dashboard to the service. So I'm going to go to the home ribbon and click on this publish button right here. And it'll ask me to save my changes. I'll be prompted to save my changes. So I'm going to click on save. And I'm going to save it as sales dashboard 101. And I've saved it. And now it's going to take some time to publish it to my workspace on Power BI. It's going to take a few seconds. And it says a success. That's great. We can open this dashboard directly in Power BI. See, it's exactly the same as it was previously. I can click on this and it'll take me to the next page. And I can click back on this. It'll take me to the previous page. And the cross highlighting works just how it used to work on Power BI desktop. See? The filters work exactly the same. We can apply filtering just the way we want, just the way we did in our Power BI desktop. And we can pin the visuals that we want to our dashboard. So we're going to create a new dashboard and call it Sales Dashboard 101 and pin it. Then we're going to, let's say, pin another visual. Let's pin this. And another one. And maybe we can pin this card as well. And you're prompted to go to your dashboard, and here I can go to my dashboard and it has all the visualizations that I've pinned. The card is right here. And click on the card. It'll take me back to my page. Here you can ask any question to your data using natural language. So maybe I can ask about average price per unit, maybe. And you get the average price per unit. You can ask for top 10 products by price. Here you have product ID, name, and price per unit. So you can basically ask any question to your data and Power BI will answer you. And you can also pin different visuals from different reports onto one single dashboard. And you can share your dashboard by clicking here and putting in the email IDs of the recipients that you want to share your data with. With that, let's go back to our main report. If I click on a certain visualization, it's going to take me back to my main report. So here we have our main report. So in this section, we learned how to import data from an Excel sheet. We also developed, designed, and published our report on the Power BI service. We learned how to create slicers, use cards, drill down and drill up using separate visualizations while also maintaining an aesthetic. We also imported a scroller from the marketplace and created a drill down dashboard which we connected via a bookmark button.
After covering sales analysis, we'll move on to Power BI project. This hands-on project will allow you to apply all your knowledge in a comprehensive real-world scenario.
Let's move on to the hands-on section where we will create our own Power BI project. We will be using HR datasets for this purpose. So let's look at some of the steps that we will do. First, we will load the dataset. Then we will transform the data if required and also define relationships among datasets in case the auto-detect functionality fails in the Power BI. Next, we will create our visualizations and add colors or titles and make other changes to make the dashboard look elegant. And finally, we will publish our report so that other stakeholders in the organization can view it. So let's look at some Power BI reports first to see what a good report looks like. Here, I have my market data analytics, which shows some insights about whatever information that we had. Here, it just shows the number of customers and income by states data. It also shows income by vehicle class and income by marital class in addition to some other analytics. We also have the IT spend analytics data. Here you can see some interesting visuals which shows some interesting graphs about the actual plan by the IT area combined with showing the region in Europe where the variance plan percentage was calculated on a country or region basis. So essentially the key part about creating a good Power BI report is that they should look appealing to the eyes, which you can see here. So we will do just that from the scratch. Here I have an empty project which I have named demo prop. First, for any visualization, we need data. For this project, I have the HR analytics data from the company. I have extracted this data from my database and I'll be using this data in my reports. So I'll load this data as I create my visualization. So first, let's say that I want to answer some questions like I want to show how many bad employees were hired in the entire duration by gender. For this, I'll need only two data points. First, the gender, and second, the number of bad hires that we have. For this, I'll load two datasets. First is the gender dataset and second is the employee dataset. So let's load it. And now I'll go ahead and load the employees data. Do note that most of the data has already been cleaned. So in most cases, I won't need to transform the data. So let's load it. So now that the data set has been loaded, what I'll do is I'll drag some values from employee and some values from gender. But first, let's take a look at what we have. So in employee, we have the bad hires value and we can check that in the field. So let's check the employee. So here, if any hire was a bad hire, it will be marked as 1. Otherwise, it will be 0. So by that, we will just create a visualization using this value and this one because we want to know the number of bad hires that we have. Here, I'll just drag the bad hires and then I'll drag the gender value. Here, I'll try to create a donut chart. So I'll select donut chart visualization. Now, as you can see, what we see here is that the number of male and female are completely the same. That is, we get 9838 for females and 9838 for males. So this means that there's probably some inconsistency in the data. So to check that, we need to take a look at how the data of the gender looks like. Now let's check that. So as you can see here, we have directly used the gender, which is male and female, but they are being represented by the ID column. So if we look at the employee, we can see here that the gender has been determined using the ID and not their gender value. So what we need to do is we need to make a relationship between the ID from gender and the employee. So to do that, what we are going to do is we are going to take a look at the model view and then we are going to connect the ID. So let's click on Manage Relationships. Here, I need to create a new relationship. So I'll select employee here and then the gender, and from gender, I'll be using this column. So let's hit OK and close this. And by doing this, we should have the proper visualization that we are looking for. So if we take a look at this, the relationship has been defined. That is, it connects the gender ID in the employee gender field. So here, what you can see is that the visualization has now changed and it shows that the number of bad hairs in male was about 51.39% and in females it was about 48.61. Now we can try to change the color of this and maybe change this heading. So to do that, I'll go here and I'll make some changes. Now it looks much better. The heading is clear and it clearly indicates that it is going to stay on top of this. Now we can also try to add a background to this. And to do that, what I'll do is I'll turn on the background, and by doing that, we can see the white portion here. So this stands out differently. Sorry, this was my mistake. I'll go ahead and change the visualization again. And I'll format my visuals again. And I'll represent male by, let's say, alright, this color looks good. And I'll represent females by, let's say, yellow. Now it looks much better. You can always make changes according to your requirements, but select those colors which make the visuals look proper and much more appealing. So now that we have answered how many bad hires were there in the company based on the gender, we will go ahead and create another visualization. For this, I'll create a new hire statistics. This will show how many new hires have been made based on the gender and age groups such as less than 30 or let's say like over 30. For this, I'll need another dataset called group, which I'll load right now. So if you take a look at this data, you can see that there are three age groups, that is less than 30, from 30 to 49 years of age, and then the 50 plus. So let's load this. Now, to create this visualization, which will show new hires that have been made, I'll drag the age group first. So I'll select age group and I'll drag it here. Now that it has been done, what I need to do is I need a complete number of the new hires that were made. So in this data, we don't have any such values, but we do have is new hire value, which has a true or false value. So let's check it again. So here we have this new hire. So if we see some employees with the value of 1, then it means that they were newly hired. So what we need to do is that we need to create a new measure which will be new hires using the DAX. So we can do that by right clicking here and selecting new measures. So we get the formula bar right here. So I'll just clear this and I'll type in my variable name, which will be new hires. And I'll provide it a value by doing a sum of this. So sum of all is new hire will be the new hires value. Now that we have created this, we can drag this value into a visualization. So to do that, what I'll do is, first of all, I'll select this and select, let's say, I'll use the stack column chart because we will need to show the gender as well. So I'll select the stack column chart and then I'll drag this value of new hires into the y-axis so that the x-axis represents the age group and the y-axis will represent the number of new hires that were made. And after that, all that remains is to drag the gender into the legend field. So by doing this, as you can see, we were able to create another visualization which shows the number of new hires that were made. And this is based on two metrics, which is the age group, which is shown on the x-axis, and the gender, which is shown above. And this is represented by different colors. Again, you can go ahead and change the colors as you require, or change the headings as you see fit. So again, I'll use blue for the male, and for females, I'll use the yellow color. So now that we are done, I'll just make one another change, which is I'll add in the title and make it look much more bold. So again, format your visuals and go to general and then select the title. I'll again add a background so that it stands out like this. So with these two visualizations, we see the number of bad hires that were made in this company and the new hires that are made based on the age group and their gender. So we can see here that most of the employees that are newly hired are below the age of 30. So I'll just go ahead and change one another thing which I don't like about this visualization is that I'll remove these grid lines. So to do that, again, I'll go to format my visuals. And while we are on this, let me also change the color of the title. And with that, I have answered two questions about the company. That is, the bad hires that were made in the company and the new hires that were made. Now, for this next thing, I'm going to create a line chart which will show new hires made by the year and month, including the employment type. So for that, I will need another data set for this, which shows what is the employment type. So I'm going to need another data set that defines the type of employment that a person has. And I'll just load that data, which is named FP. Now, if you take a look at this, it shows that F means full-time job and P means part-time job. Before loading this data, we can see that there's a problem here. That is, the first row is not being used as the column header. But we can see that what it actually will mean, because F determines that the person is full-time employee and P means that the person will be the part-time employee. So let's transform this data first. So I have just one requirement, that is I want to use the first row as the header. And to do that, I'll just click here. And by doing this, you can see how the data is changed. Now, you can go ahead and close and apply this. And now that it is done, we have FP here. But we need another data set called the date, which will contain everything related to the date and when the employee was hired. So I'll load this data right now. So I'll just go ahead and load this data right now and I'll create a line chart. So as we have loaded this date dataset, we can see that we are not seeing the visuals that previously created. So let's verify what is the problem. So it says here couldn't load the data for this visual and the filter on date is not valid. Check that the data type of the date field matches the filter you're trying to apply. So first of all, I'll go ahead and check what is the model showing. So here you can see that the date is not connected with the employee. So what I need to do is first connect these two. And to do that, I'll again go to manage relationships and define a relationship. So I'll select employee date and then I'll select date and again date. So I'll click OK and close this. So now we can see that the employee date is connected with the date of the date. Now let's go ahead and check if the visuals are visible. So again, we see that we can't see the visuals. So let's try to identify what the key problem is. So it says here the date field is not of the correct data type. So okay, let's go ahead and check this. We'll go to date. And here, I think this is the problem that we are having, which is the data type is of the text format. So we can change this to date/time. And with this, we should have the visualizations back. So let's check again. Okay, as expected, we can see the visuals again. So let's go ahead and create the line chart that we're looking for, which will show the number of new hires that were made by year and month, including the employment type. So to do that, what I'll do is I'll drag the year column from date. And I'll go ahead and select the line chart. Now I need some values for the x-axis and y-axis. So as I said before, here I am using x-axis to show the years. So I'll drag this to the x-axis. And for the y-axis, I need the number of new hires that were made. So remember the DAX variable that we created? We are going to use that here in the x-axis. So this variable, I'll drag this on the y-axis. And as we can see, the hires that were made in 2011 were lower than 2012, which was lower than 2013, which was lower than 2014. So the number of new hires are increasing on year basis. So now I also need to include the employment type. So to do that, I'll drag the employment type, which is defined by FP, and drag it into the legend field. And by doing this, you can see, sorry, my mistake. I didn't need to drag this value here. It was actually FPDESC. As I remember, let me just confirm this. Okay, so we need to drag the FPDESC value because it shows what the type of employment is, and the FP is just an ID. So I'll drag this into the legend. So if we take a look at this, you can see that the number of part-time employees in 2012 was around 6,000 and the number of full-time employees in 2012 was around 1,000. And this trend continues. So I also want to see what happened each month in a single year. And to do that, what I can do is I can drag the month into the x-axis. So this activates the drill down. Essentially, when you will try to find out what happens in a specific year, you should be able to take a look at what happens in that year. So let's drill down. So essentially, what we need to do is just click on the year number and we can see here that there is a downward trend. But this is incorrect because as you can see, the month that we are seeing here is October. And then this sequence doesn't make any sense because the month starts from January, February, March and so on till December. So we need to change this. And to do that, what we can do is we can sort this using the months. So to do that, I'll go ahead and make some changes to this visualization. So first, I'll go to my data view. I'll select month and I'll sort this data using the month number. Okay, let's see what changes have been made. So again, it seems like nothing happened. So let's see what we can change. So here I click on sort axis and I'll select year month. And now I need to make this in the ascending order because right now December is on the left side and January is on the right side. And just like that, we have a perfect visualization showing the number of new hires made in 2013. Now I'll go ahead and make some more changes such as changing the colors and the header. And I'll disable the grid line as well. I'll also add the white background which the other visualizations have. Then I'll change the color of these lines. Okay, so this does not look much appealing to me, so I'll change one color. So, to me, this looks much more appealing to the eye, and I'll use this color scheme. Now, for the last part, I'll create a matrix which will show the region and the ethnicity of the new employees that were hired. So, we need the new hires value again. But we also need two new data sets for this, which are ethnicity and the region data. Here we have the BU dataset which contains the information about the region. So as you can see, we have some values available here which shows the region part and the vice president's names right here. So I'll go ahead and load this. Now that BU has been loaded, I will load another dataset called ethnicity. So we can see here that this dataset has 3 columns, of which the last column is empty. So I can just go ahead and remove this data. So I'll go ahead and remove this empty column. And to do that, I just have to select this and click on remove columns. And just like that, this is ready to be loaded. So close and apply and wait for the data to be loaded. Now that the data is loaded, what I can do is I can go ahead and create a new matrix. But before I do that, I need to make sure that the relationships are properly defined. So let's look at the BU dataset. So it has these values which are self-explanatory and the ethnicity. So it looks like I need to connect the ethnic group for the employee, and then I need to connect the BU for the employee as well. So I'll go ahead and go to my model view and let's see what has happened. So for BU, it looks like the relationship was automatically made. And for the ethnicity, it looks like the relationship here was also automatically made. So it goes to show the powerful features of the Power BI that it is able to make sense of what the relationships might be. So let's go ahead and create that matrix that we're looking for. So first thing is first, I'll take the region value and I'll drag it here. Now I'll select matrix, and now for here, I will go ahead and include into rows the vice president's names as well. Now I'll drag the ethnicity column. And for the values, I'll provide the new hires, because essentially this visualization is all about the new hires that are made. And this shows the analytics of the HR. So as you can see, we can say in this chart that from specific regions, what kind of ethnicity group were hired and how much do they total. So the first thing that I'm going to change about this visual is first of all the font size. because as of now it looks like it is too small. So I'll again go to format my visuals and I'll change some settings here. So for the columns header, I'll change the text size and I'll make it bold. I'll do the same for the row headers as well. And I'll make the same changes for the values. So now I'll just resize all of this. And now I can show you what Power BI is all about. So in this project, what we have answered is the number of bad hires that have been made and the number of new hires that have been made by the company. And I have created this matrix here, which can also go ahead and show that what happens in specific regions. So if we go ahead and click on the central region, we can see that the ethnicity is this, and the visualization changed based on this specific value. So now that the project is ready, I can go ahead and publish it. And I'll select my workspace for this. And now that we have successfully published our report to the Power BI, we can go ahead and see it. So as you can see here, we can see the visualizations that we made. So for this, you can see that if I drill down on 2012, I'll see a trend of something like this, which represents the new hires that were made. And essentially, this will go to show the hiring analytics that have been made by the company. And just like that, the project is done. Do experiment and note that you will be able to create this great reports in no time, because most of the learning comes from experimentation. This video did not include having multiple pages. For example, instead of having just one page here, I could have had two or maybe let's say 5 pages, which could have shown the analytics of the HR operations.
Having completed your project, the next module is Power BI Python integration. You'll explore how to integrate Python scripts with Power BI to enhance your data analysis capabilities.
So, what is Python or the Python programming language? Now, Python is an interpreted high level general purpose programming language which emphasizes on code readability within its notable use of significant white space. It's a fairly simple language to pick up, and any experienced programmer with the knowledge of coding can pick up Python pretty easily. It is also a great decision for beginners to start their coding journey with Python. Now, there are a couple things to keep in mind before we can start this tutorial. Now, to run the Python scripts in Power BI Desktop, you need to install Python on your local machine. I downloaded mine from the Python official website, and the current Python scripting release supports the Unicode characters and spaces in the installation path. The Python Power BI integration requires the installation of two Python packages. First of all, you need Pandas, which is a software library for data manipulation and analysis. It offers data structures and operations for manipulating numerical tables and time series. Your imported data must be in the Pandas data frame, which is basically a two-dimensional data structures, meaning that your data is aligned in a tabular fashion, like having rows and columns. The second Python package you require is matplotlib, which is basically a plotting library for Python and its numerical mathematics extension NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits such as Kinter, WXPython, Qt, etc. Now, you can install these packages in a console or shell. You can use the pip command line tool to install these two packages. And that is all I have to say in terms of prerequisites. Now, let's move on to actually using Python scripts in Power BI. For that, we need to move on to our demo machine. Okay, now first things first, in the Power BI desktop, first we're going to go to File and then options and settings and select the options. Now this is going to take some time. Okay. Here we are going to select Python scripting and the Python script options page appears. Now here what you can see up top in the detected Python home directories, you're going to find your local Python installation path. If it is not already given, you can just click on the arrow and select the path that leads to your Python home directory. In here you can see the Python's installation local path here is in users, app data, local programs. Make sure the path is for the local Python installation that you want Power BI Desktop to use. Here at the bottom, you have your detected Python IDEs. Since the Power BI could not select the Python IDE that I preferred, I clicked on other and then I browsed to the Python IDE which I wanted, which is the Visual Studio Code. Once you specify your Python installation, you are ready to begin running Python scripts in the Power BI desktop. So we're going to go ahead and select OK. Now, in just a few steps, you can run Python scripts and create a data model. From this model, you can create reports and share them on Power BI service. So first of all, we need to prepare a Python script. So first, I'm going to create a script in my local Python development environment and make sure it runs successfully. For example, here's a simple Python script that imports pandas and uses a data frame. Okay. When the script runs, here is what I get in return. Kindly look at this output right here. Now, when preparing and running a Python script in the Power BI desktop, there are actually a few limitations. Firstly, only pandas data frames are imported. So make sure that the data you want to import to Power BI is represented in a data frame like I have done in line number 3. Any Python script that runs longer than 30-minute times out. Interactive calls in Python scripts such as waiting for user input halts the script's execution. And when setting the working directory within the Python script, you must define a full path to the working directory rather than a relative path, which we have already done before. Also, another important thing is that nested tables are currently not supported in the newest version of Power BI. Let's hope that is fixed in the months to come. So now that we've run it here, I'm going to take this code and I'm going to try and run this Python script in the Power BI desktop. So right now I'm on my Power BI desktop. In the home ribbon, I'm going to select get data. Now this is going to take some time. Okay, I'm going to select other. Here I'm going to go down and select Python script. I'm going to click on connect. Now your local latest installed Python version is selected as your Python engine. So you'll see a dialog box like so on your screens. And here I'm going to copy my Python script that I had earlier run in the IDE. I'm going to select OK. And if the script runs successfully, then the navigator is supposed to appear and you can load the data and use it. Kindly be patient. It's going to take some time to connect. And here for this example, I'm going to select DF or my data frame, which is this small little table, and then click on load. Now, if Python isn't installed or identified, you might find a warning that displays. You can also see a warning if you have multiple local machine installations. Now, that's pretty easy to troubleshoot. All you have to do is revisit and review the previous install Python and enable Python scripting sections and uninstall the previous versions of Python. You can then refresh a Python script in the Power BI desktop. You can then refresh a Python script in the Power BI desktop by going to the home ribbon and selecting a refresh, which is this button right here. And when you refresh a Python script, Power BI runs the script again. It's as easy as that. Now that you know how to import data using your Python script, let's actually import some data of use, which we can layer visualizations on top of. All right. So for this, I am going to use a different script. That one was just a dummy, the one that we used before. I only wanted to show you how you can import a simple data set using a Python script. Like I had given the disclaimer earlier, The scripts are going to be pretty rudimentary because this is not about Python programming, but about how to use Python in the Power BI desktop. So I'm going to do the same thing again, and this time I am actually going to have some data with more dimension. So here I'm creating a data frame again, but this time I have more dimensions. I have names, age, weight, gender, state, the number of children, and pets as well. So I am going to click on OK and wait till it connects. Again, I'm going to select the data frame. As I had told you earlier, we have multiple columns this time. You can go on to transform data, which is going to open the Power Query editor. And you can see your table, make changes by adding to the query right here. We have a tutorial about this. You can go ahead and check that. I'll link that in the description box as well. And I see everything is fine. I'm just going to close and apply. And on the right on my fields, you can see my data frame. Here we have all of the columns as well as calculated columns. We have ages, children, pets, weight, so on and so forth. Now we're going to see how we can use beautiful visualizations in the Power BI desktop by using Python. So now to begin with, let's select the Python visual, which is right here on the visualization pane in the PY icon. This will lead to a prompt named Enable Script Visuals. This is a dialog box that is going to appear the first time you use it in every Power BI session. So here we're going to click Enable. Now, when you add a Python visual to a report, Power BI Desktop is going to take the following two actions. First one is going to be your placeholder Python visual image, which appears on your report canvas. This one is right here. It's a blank visualization with the Python icon on it. And all of it is grayed out because we have no values. And then you have the Python script editor, which appears along the bottom of the center pane, which you can see right here. Now, the thing is, your Python script can only use fields added to the values section, which is right here on the right. So what we're going to do is we are going to drag the age, name, children, gender, pets, a bunch of different fields to the values section, which already says add data fields here. So basically, I dragged all my fields in there. And now we can add or remove fields from the values section while working on our Python script. Power BI Desktop will automatically detect these field changes. Now, the default aggregation type for Python visuals is do not summarize. All right, remember that for later use. So now you can use the data you have selected for creating a plot. So as you select or remove these fields on the right, supporting code in the Python script editor, which is here, is automatically going to be generated or removed. Based on your selections, the Python script editor generates this binding code, which is given right here. Basically, the editor has created a dataset data frame right here with all the fields that you have added: age, children, F name, gender, pet, state, and weight. Now, similar to table visuals, fields are grouped and duplicate rows appear only once. In certain cases, you might not want automatic grouping to occur, or you'll want all the rows to appear, including duplicates. If so, you can add an index field to your dataset that causes all the rows to be considered unique, which prevents grouping. Now you can access columns in the dataset using their respective names. For example, you can use the variable age to call age in your Python script to access the age field. Now, with the data frame automatically generated by the fields that you selected, you're ready to go ahead and write a Python script, which results in plotting to the Python default device. Now, when the script is complete, you can go ahead, select Run, which is right here, which is on the Python script editor title bar. Power BI Desktop replots visuals if one of two events occur. First of all, when you select Run from the Python script editor title bar, and second, whenever a data change occurs due to data refresh, filtering, or highlighting. So when you run a Python script that results in an error, the Python visual isn't plotted and the canvas error message appears. Then you can go ahead and select See Details from the message, and to get a larger view of the presentations, you can minimize or maximize the script editor and the blank visualization as you please. So that's enough chit chat for now. Let's create some visuals. So first of all, we're going to try and create a scatter plot to see if there's a correlation between age and height. So I'm going to go to the line which says paste or type your script here. And on the next line, I'm going to paste the script which I have already created. And your Python script editor pane should now look something like this. The matplotlib library is imported to port and create our visuals. So now let's go ahead and select run script. So as you can see, a visualization has appeared. So I'm going to make it slightly larger for it to be visible. Now, when you run the script button, this scatter plot generates in the placeholder Python visual image. You can look at the correlation between the ages and weights of the children. Now, what else can we do? I'm thinking let's create a line plot with multiple columns. Let's go to a fresh new page and do the same thing as we did before, except for this time we are going to create a line plot for each person showing their number of children and pets. Again, we have the same sort of basic frame of code. Again, paste or type your script here. And here, basically, I have created a line plot showing the number of children and pets. Here on the x-axis is going to be the names of people, and on the y-axis is going to be represented their number of children and pets, and the line of pets is going to be represented in the color red. Then I'm going to run the script, and as you can see, children appear in blue while pets appear in red. Now you basically have a line plot with multiple columns showing the children and pets of every person on the dataset. Another interesting chart you can do with this is the basic bar plot. For that, again, I'm going to do the same thing. I'm going to create a bar plot in a fresh canvas. Now, when you run the script, you basically have a bar chart or a bar plot representing all the ages of all the people that are there in your data frame. And that's just the tip of the iceberg of what you can do if you explore the potential of Python in Power BI. Now, this tutorial was basically designed to help you get started with creating visuals with Python in Power BI desktop. This barely scratches the surface about the many options and capabilities for creating visual reports using Python, Pandas, and Matplotlib library. There's a lot more information that you can tap into if you go on to Power BI's community or maybe Python's community. But this is basically all you need to know to get started with Python in Power BI. Now let's go ahead and look at a few known limitations of this service. Now, Python visuals in Power BI desktop have a couple limitations, starting with the data size limitations. Basically, the data used by the Python visual for plotting is limited to 150,000 rows. If it is more than that, then only the top 150,000 rows are used and a message is displayed on the image stating the same. Additionally, the input data has a limit of 250 MB. The second is resolution, which basically refers to visuals are displayed at 72 dpi. Third, you have calculation time limitation. If a Python visual calculation exceeds 5 minutes, the execution times out, which results in an error. Then you have relationships. As with other Power BI desktop visuals, if data fields from different tables with no defined relationship between them are selected, you basically get thrown an error at. Then you have Python visuals, which are refreshed upon data updates, filtering, and highlighting. Then you have something which is kind of a given. Python visuals can be refreshed upon data updates, filtering, and highlighting. However, this image itself isn't interactive and cannot be the source of cross-filtering. Followed by next, which obviously gives rise to the next problem, which is that Python visuals respond to highlighting other visuals, but you can't click on elements in the Python visual to cross-filter other elements. Pretty self-explanatory. And finally, only plots that are plotted to the Python default display device are displayed correctly on the canvas. So a good practice is to explicitly avoid using a different Python display device.
Following Python integration, we'll discuss our Power BI integration. This module will cover how to use R scripts within Power BI for advanced data analysis.
Now, R is a programming language and free software environment for statistical computing and graphics, supported by the R Foundation for Statistical Computing. It is a widely used programming language used among statisticians, data miners, data scientists, even for developing statistical software and data analysis. So in this session, I'm going to explain to you how to work with R in Power BI Desktop, focusing on how to perform R specific tasks as opposed to taking a deep dive into the R language. Now, for this reason, the R scripts in the examples are extremely rudimentary and meant to only demonstrate how you can utilize R in the Power BI Desktop. So once you understand these concepts, you can take advantage of R's extensive and robust capabilities to analyze, transform, and visualize data. If you're not familiar with R, a good place to start will be the R project site, where you can look at projects based on R and learn a little bit about the programming language. Now, when working with R in the Power BI Desktop, R must be installed on the same Windows computer as Power BI Desktop. Now, you can download and install an R distribution for free from a variety of locations, including the CRAN distribution available from the R project site. You can also do so using the Microsoft R Open distribution available from the Revolution Analytics site. And for examples in this particular session, I have used the CRAN distribution version 3.6.2. You'll also find it handy to have a separate R integrated development environment or IDE installed on your system. This allows you to verify your R scripts before running them within the Power BI desktop. Now, an IDE also makes it pretty easy to install R packages that you might need while running R in Power BI desktop. On my system, I have installed the free version of RStudio, which is again available from the RStudio site. So now that you know where to get started, let's actually get started. So when you open your Power BI desktop, it tries to locate an R installation on your system. You can verify whether the correct installation has been detected by opening the Options dialog box available by going to File and then Options and Settings, and then going and selecting the first option, which is called Options. Kindly be patient, this might take some time. Now, if I select the R scripting section, it appears like this on my system. In my case, as you can see right here, the Power BI desktop has detected both the correct R installation, which I had mentioned before, the R version 3.6.2, and the IDE, which is the RStudio, indeed the one that I'm using. If you find the information to be incorrect or missing, you can provide a specific R installation, R IDE, or both. Now, associating an IDE with Power BI Desktop applies only when you're creating R visualizations in your report view. Okay, so by associating an IDE, you can launch the IDE from within Power BI Desktop and work on your visualization script right there. I hope that's clear. So let's move ahead. Using an R script to import data. Now, when using an R script to import your data, your script must return at least one data frame that serves as the basis for your imported table. Now, if your script returns multiple data frames, you can choose which ones to include as a part of your import process. Now, Power BI will create a table for each imported data frame. One word of warning, however, if a data frame contains a column configured with the complex or vector type, Power BI Desktop will replace the column's values with errors. So now, moving on to use R script to import data into your Power BI Desktop, it's very simple. You can click on Get Data, the button right there, click on More. And when this Get Data dialog box appears in front of you, you can navigate to Other and then R script. And then when you click on the Connect button, Power BI Desktop is going to launch the R script dialog box. As you can see, R script is written right here. Now here you can type or paste your R script. For example, we are using an R script to retrieve data from the IRIS dataset. Now this is included in the CRAN distribution. And then what we are going to do is we are going to assign it to the IRIS raw variable. So here I have a handy notepad. Here I've kept all of my code because it's not about R, it's about learning how to use R in Power BI, as I had mentioned before. Basically, what we are doing is we are going to retrieve the iris dataset and assign it to the iris raw variable. Now, in Power BI Desktop, you must assign the dataset to a variable even if you don't modify the data frame in any way. If you were to enter only the name of the dataset, as you can do in an IDE, no data frames would be available to import into the Power BI Desktop. So before entering your script into the R script dialog box, you should probably test it in your IDE to ensure that it runs properly and returns the results that you expect. Now, if your script generates an error within Power BI Desktop, it can be very difficult to make sense of it. Plus, you have to start over with the import process all over again. Once you're sure your script is ready to go, you can enter it into the script text box as you see in front of you, and then click on OK. So when you click on OK, Power BI Desktop processes the script and then launches the navigator dialog box, which will appear in a few moments. Here it is. If I select the iris raw table, this is the data frame that we have imported, and now we can review our sample data for each data frame. In this case, we only have one data frame, which is the iris raw data frame. So it is the only one available, as you can see in front of you. Now, this navigator dialog box lists the data frames in the display options section under the R1 folder, as you can see here. As I have selected the checkbox right here, you must also select the checkbox which is associated with each of your data frames that you want to import. Once you've made your selections, you can click on load. And after Power BI Desktop loads that data, you can view the data set in the data view. It's going to take some time. Kindly be patient. Here, you can see it on the right, or you can go straight to the data view. This is the data view. And again, you can see your table, your data frame right here, and all your columns right here on the right hand side of your view. Now, in some cases, you might want to import the data from a file rather than using one of the built-in data sets. For example, suppose you have copied this iris dataset into a CSV file, which you have saved into a certain location on your system, on your local drive. You can easily pull the data into the R data frame using a statement. For example, suppose you've copied the iris dataset to a CSV file, which you've copied in your C drive in a folder named data files and saved it on your local drive. You can easily pull that data into the R data frame using this statement in front of you. The statement uses the read CSV function to read the context of the iris.csv file. The header argument is set to true to indicate that the first row values should be created as headers if that's what you want to do, and the sep argument indicates that a comma is used to separate the data values within the file. You can use the same process described in the previous example to import the data from the iris_csv data frame as well. Now let me close this. Don't need to save it. Now the R language is extremely flexible due to the ability to install packages with additional functionality, and there are several that aid reporting and analytics. The dplyr and data.table functions provide extremely useful functions or verbs for working with data frames, and the ggplot2 is useful for visualization. To use these in Power BI Desktop, they must be installed into your system. So you can install these through your IDE. In my case, it's going to be RStudio. So let's go ahead, launch our RStudio and run these commands. So here are a couple of commands. First is I am installing the dplyr package, followed by the data.table package, and finally the ggplot2. So let's run these commands. Now, these packages are going to take a few moments to load. Now, after these packages are installed, you can then use the library function within your R script to call that package when you're importing the data. These will basically allow you to use these functions included in the package and make use of them in Power BI. So one of the biggest benefits of being able to use R when importing data into the Power BI Desktop is that you can manipulate data as a part of your import process. For example, here is a script. Now this script uses the summarize and group by functions available in the dplyr R package to group and aggregate the data before importing it. So I am going to click on enter. The group by function here prepares the data for the use by another function, which in this case is summarize, that has been just used before the group by. In this example, the summarize function is used in conjunction with the mean function right before that again, the mean function, to find the mean for each of the 4 measures grouped according to the values of the species column. You can see it in the global environment right here. If we click on the global environment, here on the left hand side top corner, we can see this table. Basically, returning now to the R statement that we have just given, the aggregated data is saved to the iris mean table. Now, this is the name that has been assigned, as you can see here. This is the name that has been assigned to the data set when it has been imported into this R Studio. Now that we've run it here, let's go ahead to Power BI and run it right there. So again, we're going to get data. Now, of course, you can write far more complex R scripts than the one I am writing, but this should give you an idea of how easy it is to use R to import data into Power BI Desktop. And the more adept you are with R, the more powerful this tool becomes for you. Again, on the right, you can see our table of iris mean is right here. It appears. Even if we go to the data view, we see the table that has been imported from R. Moving on. Now, there might be times when you want to use R to manipulate a data set already imported into your Power BI desktop. Now, the query editor includes the capacity to apply an R script to a data set in order to transform the data. But before modifying the data, let's take a look at how the iris raw data set appears in the query editor before applying any transformations. Notice that the applied step section includes only 2 steps. There is source and there is navigation. From what you see in front of you, the source step is selected and a small table is displayed in the query editor's main pane. Now the table represents an initial import operation with 1 row included for each returned data frame. Now in this case, as you see in front of you, because there is only the iris raw data frame, the table includes only 1 row. The table value in the value column right here on the right represents the data associated with that data frame. Now the table value in the value column represents the data associated with that data frame. Now selecting the value results in the second step. So if we click on navigation, now this shows the actual imported data as shown previously. Whenever you use an R script to import data, the Power BI desktop adds both the source and navigation steps. Now let's take a look at how to run an R script against this iris raw dataset. Now to keep things simple, we are going to use the same aggregation logic which we used while importing the iris mean dataset. The primary difference is that you must use the dataset variable when referencing the dataset instead of specifying iris. Now to run this R script in the query editor, we are going to click on the Run R script button here in the transform ribbon. So it's right here on the right. So instead of this iris right here, I'm just going to change it to dataset. Now after you enter the script and click on OK, the query editor adds 2 steps more to the applied steps right here. As you can see, we have 1 Run R script and the iris mean. These 2 steps work just like the first 2 steps, source and navigation. The first one reflects the data frames returned by the script, and the second one reflects the selected data frame, as you can see on the screen before you. As with using R to import data, being able to run an R script against a dataset provides you with a very powerful tool for working with the imported data, whether the data was imported from a database, an online service, or a text file. After you've imported the data into Power BI Desktop, any dataset is a fair game. Another great feature in Power BI Desktop is the ability to use R to create visualizations within the report view. I'm going to close the query editor. Now, for the most part, this process is also as straightforward as using R in other ways, except for one important thing. Now, R automatically groups and summarizes the data whether or not you want it done. And you cannot override this behavior of Power BI. Why Microsoft decided to take this approach is a bit of mystery to me, honestly, especially since it can sometimes give you the results you don't want. Fortunately, there is a workaround. You can add a column to your data set that uniquely identifies each row similar to an identity column in the SQL Server table if anybody of you have used it before. Now, if you're using an R script to import the data, you can add the column as a part of your import process. For example, let's open this. For example, this R script adds an identifier column to the iris dataset based on the dataset's index or row names. The script starts by calling the data table package, which provides functions for the working with data frame objects. Now, be sure to install this package if you already haven't. Then you have the setDT function along with the keep.rownames argument. Now, this creates the new column based on the index values. And notice that you must first assign the iris dataset to the iris ID, which is a variable, before you use the setDT function. Now, this is because the function makes changes directly to the dataset, which you cannot do with a built-in dataset such as iris. After creating the column, you can then use the setNames function to change the name of the first column from the default RN to the new name ID. The final step is to change the column data type to an integer. Now, with the iris ID dataset in place, you can use it to create a visualization based on an R script. And to add an R-based visualization, you have to be on the report view, which we already are. So let's click on this. Let's go again. As you can see, it has this row called ID with all the row numbers, and that's what we wanted. Let's go back to our visualizations pane. Now, the first time we are going to create a visualization out of our script, we are going to click on this R sign in the visualizations pane, and you will be prompted this enable script visuals prompt. You have to simply click on this enable button. And when you click on that button, Power BI Desktop adds a graphic placeholder to the report and opens an R script editor pane here at the bottom. Before you can do any scripting, however, you need to identify the dataset columns that you'll be using in the visualization. Now, the easiest way to do this is to drag the columns from the fields pane, which is right here, to the value section right here. Be sure to include the identifier column you created on the dataset. So for this example, I'm going to add, let's start with ID and species, petal width, and petal length. Now, if you look at your R script editor, when you added the columns, Power BI inserted several comments in the R script editor pane. Now, the first two comments indicate that a data frame named dataset has been created, and based on the columns you added to the values section of the visualization pane, you must use dataset to reference the source data in your R script. The second two comments indicate that duplicate rows have been removed from the dataset, which is why you needed to add the identifier column. Now, beneath the comment, my code starts here. Now, this is a fairly simple script. The script uses the ggplot function in the ggplot2 package. Again, make sure to install the package if you haven't already, to create a visualization with the specified colors and labels, right? Notice that your petal width column is used as an x-axis right here, and the species column serves as the basis for plot colors, as you can see right here. After you define your R script, it's very simple. Go ahead and click on the Run button, which is right here. It's at the top right of your R script editor pane. And here we are. Let me just make it slightly bigger. The Power BI Desktop basically processes the script and displays the visualization in the placeholder that was added earlier when you first clicked the R button. This figure shows how the visualization appears on my system. It might appear slightly differently on your system, but the basics will remain the same. The petal width and length are going to act as axes, and the colors are going to differ by species. You can update an R-based visualization at any given time by modifying the R script. After you modify the script, just click on the Run Script button to update your visualization. And if you want to edit the code in your IDE, you can edit the script in your internal RStudio or RIDE by clicking this button right here. As you can see, it gives you an option of editing the script in an external IDE. Now you may need to do that to connect to code necessary to connect to your data source that you're using for your visualization. The script will also include any code you already added to the visualization script in the Power BI desktop. You still have to copy and paste a bulk of your script back into the desktop if you make any changes at all. But this at least saves you the trouble of trying to set up the data source in an IDE in order to test your script. Something to keep in mind when adding R-based visualizations to your report is that the Power BI service comes with licensing restrictions. You cannot use R-based visualizations in the Power BI service unless you have a Power BI Pro license. Moving on, another fun feature in the Power BI desktop is the ability to import predefined R-based visualizations into your workspace. The visualizations are available through Microsoft's App Source Gallery, which you can directly access through the Power BI desktop. You do not need to understand R syntax, nor do you need to build or run R scripts for this. So let's open a fresh page. And to import a visualization, we are going to click on this ellipses or the three dots on your visualization pane in the report view, and then click on Import from App Source or the marketplace. Now this launches the Power BI visuals window. As I had mentioned, it's also known as the marketplace. So here are a couple of suggestions for you. When you locate the visual that you want to import, you can just go ahead and click on this yellow add button. If the visualization requires additional R packages to be installed, the R packages required dialog box is going to appear, and it is going to list down the packages that need to be added. You can either click, cancel, or install the packages manually, or you can click on the install button and let Power BI Desktop install the packages automatically for you. For this specific example, I'm going to select something known as a spleen chart. Okay. Now when it's added to the Power BI Desktop, you can see it right here in the bottom. So when you import a custom visualization, the Power BI Desktop adds a button to the visualization pane specific to that particular visualization. Now you can then add this viz to your report and configure just like you would any other pre-built visualization. As you can see right here, in the bottom, you can see your spleen chart visualization that we just downloaded. Now Microsoft provides a number of free and interesting custom visualizations like this one, and it's certainly worth familiarizing yourself with what's out there. So you can create reports that are even more engaging than you can achieve with the built-in visualizations. Best of all, Microsoft has made it exceptionally easy to pull the custom visualizations into Power BI Desktop, so you have little to lose by trying them out. Now, the integration of the R language into the Power BI Desktop provides a powerful tool for transforming and presenting business intelligence data. R is a comprehensive statistical computing and graphics language that is extensively implemented and has a very large and active user community. In Power BI Desktop, you can use R to import and modify data as well as create a wide range of visualizations that provide in-depth insights into the data. Those already well versed in R should find that using R in Power BI is simple and a pretty straightforward process. Even those less experienced with R could find it well worth the effort to try out the Power BI Desktop R features.
After our integration, we'll dive into Power BI Azure. You will learn about integrating Power BI with Azure services to expand its capabilities and enhance your data solutions.
So if you talk about Azure, then Azure is the second leading platform in the entire globe after AWS, because AWS has been on #1 position since its inception back in 2006. And Azure has multiple services under its portfolio. So it has services for computation, networking, database, migration, IoT, artificial intelligence, machine learning, on databases, on unstructured databases. So there are multiple services offered under Microsoft Azure, almost more than 100 services in different categories that we can choose to get started with. To see the list of all the services offered under Azure, we can refer to the link here, azure.microsoft.com. So here we can refer to this link here, azure.microsoft.com, where we can see the list of all the services offered under this platform, where we can see the services offered under AI/ML, under computation, containers, hybrid solutions, Internet of Things, and there are more than 200 plus services offered under different categories that we can get started with. So AWS currently offers almost 175 services, whereas Azure offers more than 200 services offered under different categories. All right, so Azure, as you know, is one of the leading platforms for cloud computing through which we can choose multiple services and different categories, and then we can get started. So why people prefer Microsoft Azure? Because here we have everything offered on on-demand basis. That means there are no upfront costs here. We have to pay only for the services that we have consumed. That's it. For example, if we have deployed 100 VMs and we have consumed them, let's suppose for 2000 hours, then we had to pay only for those 2000 hours, nothing less, nothing more. If we have a small testing requirement and we have used a server only for 2 hours, we had to pay only for 2 hours, that's it. And we had to pay also based on the configuration of the resources as well. That means if we have used a high-end server having more cores of CPU, more amounts of RAM, and a specific set of processor, then we had to pay for that. And if we are deploying a low scale server, I mean small scale server, then we have to pay accordingly. So it is all based on the requirement, and then we have to pay only based on the amount of services that we have consumed and for the time period we have consumed it. And then it offers abstract resources. That means we can focus only our requirement, not on the hardware specification, as it is already managed by Azure services. We can have the scalability done. That means we can easily scale up and down the resources as per the requirement. And then we can also have the efficiency of experts. That means we can utilize the skills, knowledge, and resources of the experts as per the requirement. Because again, here we only have to worry about making a solution available to everyone. And then we can let the Azure platform to take care of the entire maintenance, deployment of servers, and every other component that needs to be taken care of. And then we have to pay as you consume. That means we have to pay only for the resources and for the time period that we have used it, nothing less, nothing more. All right, so let's move forward. So we had discussed on the Azure platform. So Azure is currently having multiple services offered under its umbrella. As we discussed, we have more than 200 services offered under blockchain, computation, containers, databases, developer tools, DevOps, hybrid, identity, integration, Internet of Things, management and governance, media, mixed reality, mobile applications, networking, security, storage. So there are multiple solutions being offered under Azure that we can choose accordingly. All right, so first of all, before we jump into Azure ML, so first of all, let's see how we can work with Power BI individually so that we have a complete understanding on Power BI first. Now, Power BI is offered as a free tool for the individual users. So we can download the community version of Power BI that we can use for free. So we can refer to this link here for called powerbi.microsoft.com, and here we can click on Start for Free, where we have to enter our own details. And once we enter the details, we will be getting the direct download link that we can use for getting started. So here we can click on Power BI Desktop, and we can click on Download, and then we will be taken to the download section altogether. All right, and once we have the Power BI Desktop version downloaded, we can open this up. So here we can refer to Power BI. Now Power BI is one of the easiest platform to get started with. So once we have this one downloaded and then we have opened it up, we can see this dashboard being open in front of us. And first of all, to get started, now this is the entire canvas that we had to work on. So here we can work on the entire data set, and here we have different worksheets, as in we can create multiple worksheets. We can get started here. And then we, on the right side, we have multiple visualization tool that we can choose based on the data that we have currently selected. So let's open up a sample data with us that we can work on so that we can have a quick insight of what kind of visualization that we can create here. So let's use a sample data set. To get data here, we can click on get data, and here we can choose a source of data. So if we click on more, we have data integration available from multiple platforms. So either we can import a simple CSV Excel file directly, or if we have data stored in a database, we can have the data fetched from multiple data sources, including MySQL, Postgre, Teradata, IBM, Oracle database, Impala, Vertica. So we have multiple integrations available. We can make use of the Power Platform since these both solutions are offered by Microsoft. We have a direct integration available for the data solutions offered by Microsoft Azure that we can integrate this with. We have multiple offline services available where we can integrate this to Salesforce, to Google Analytics, to Adobe Analytics, to Facebook, to Marketo, MailChimp, LinkedIn, Facebook, Zendesk. We have multiple other solutions integrations available here that we can make use of. Let's say we want to work with the Excel sheet, a simple Excel file that we may have the access to. We can click on Excel. We can click on connect, and here we have to choose the source of the Excel file. So let's say we want to work with a simple financial sample workbook. So here we can open this financial sample workbook, or we can open up the Superstore orders as well. We can use both the data sets. For example, let's say we want to work on Superstore orders. We can click on open. And first of all, this is going to read the data, and this is going to allow us to fetch a portion of the data that we are currently importing, or we can perform multiple ETL activities as well as per the requirement. So let's say here we have two tables. Here we have orders, and whichever table we choose, whichever sheet we choose, we can see a preview of the data available in this sheet. And then we have a people. We can see the data available for people as well. So now let's say if we want to import both or just one, we can choose one. Let's say we want to choose work with this order table, that we can click on load. And now the entire sheet is going to be loaded. All right, so now once the table has been loaded here, we can see all the columns available in the right side. And to visualize the entire data set, we can click on this option which says data. And here we can see that means we can see the entire data set in terms of the entire rows and column that we have currently imported. As you can see, currently there are 51,290 rows available in the current data set that we have imported as a part of our Power BI desktop. Now, once we have imported the entire data set here, we can come back to our visualization screen where we can start creating multiple reports out of it. So first of all, let's say here we want to work on importing city, or we suppose here we want to work on importing the quantity, or let's say we want to see the profit ratio here, right? So here we can see the profit, and now we want to see the order date, as in we want to see now we don't want to use this map here, we can remove this. We want to work on the profit and the order date. That means we want to segregate and see how it has been the profit in terms of different year-wise performance. And once we choose any two data set, we can see multiple the best suitable format for this given data set is going to be chosen in terms of visualization. So first of all, we can see the entire bar graph has been chosen, and we can easily increase and decrease the size of the visualization as per the requirement. So we can, suppose here we want to create we want to focus only on this one for the entire page, and here we can choose entire page, or we want to focus on different components as per requirement. Here we can choose the size accordingly. Means how exactly we want to increase or decrease the size for different parts of visualization. We can choose accordingly. All right. So now let's say here we have, in terms of access, here we have year, quarter, and date available. In terms of legend, for example, suppose here we have year, right? Here we have day. Here we have, so suppose here we want to visualize this based on suppose month. Then here we can define, here we can simply cross check. Let's say here we want to see the report based on different months, right? Based on the year and based on, suppose not just based on year, but based on the quarter, as in quarter one, quarter two, quarter three. And then we want to see the entire report based on the month itself instead of quarter. We want to simply segregate them based on month. So we can see which month has performed really well and which month has not been able to set as per the current, or we can say current expectations. We can see the entire report here. And now we want to, now let's say here we want to work on the date hierarchy itself. For example, suppose here we want to work on year, quarter, month. Let's say here we want to display the quarter, right? So here we have this quarter data set here. And now here we want to display another table for quarter. We can choose that. Or suppose here we want to work on this table only. But here we want to make sure, let's say, just to avoid confusion, we can remove this. Now here we can choose this table, and now we want to display the variation in terms of year. But again, here we also want to display in the legends here, we want to display the multiple quarter data set as well. For example, we want to display the year-wise data set, but again, here we want to make sure that we are segregating them based on the year-wise performance. For example, now here we have seen that we were earlier projecting the entire data set just in year. That means year-wise performance. And now we want to see the detailed performance in terms of quarter, and again and that too for a different year. So what we can do, let's say here we can keep the under the axis here for the main, we can keep it to year. And now we can expand order data. So in order date, we have segregation based on year, quarter, month, and day. Now we want to see a detailed report in terms of quarter. So here we can pick quarter, and here we can drop it under legend. So now we can see here we have detailed report on the performance, not just in one quarter, but again in terms of different quarters as well. That means how has been the performance for in 2012 in terms of different quarters, so that we have a better insight how we have performed in which quarter accordingly. And we can see here the entire legend has also been added here for quarter one, quarter two, quarter three, quarter four, correct? So we can segregate the entire data set. Plus, let's say here we want to segregate them further. So let's say we want to also showcase the segment as well. Segment also in terms of the legend. For example, segment as in which segment we have spent the most. For example, in which year consumer goods have been sold the most, or the corporate segment has been sold the most, or the home and office has been sold the most. We can define it as a part of segment. So it depends upon us how exactly we are going to map it out, what kind of problem statement we are going to solve. Suppose if a company asks us, okay, what has been the profit distribution for different segments in different quarters of the year? So we can simply use a segment to help them visualize, okay, now for the consumer products, the worst year was 2012 and the best year was 2015, where the consumer goods were sold the most, correct? And the worst year for the corporate customers, or for the corporate profit, was 2013, or was 2012 itself, where we saw a profit of almost 84,000, whereas in 2013 we saw a profit of 90,000, and the best year was 2015 itself, and so on. Correct? So here we can quickly visualize the entire report of how has been the entire profit distribution in terms of different segments as well, by quickly showcasing the category report as a part of the requirement. And depending upon data set, here we have multiple integrations available with that we can make use of. For example, say here we want to visualize if we have some kind of geospatial data set. For example, here we can click on add, and here we can visualize the entire geospatial data set as well. For example, let's say here we want to see the profit distribution, and that too based on different cities. So now if we have this kind of data set, and now we can choose how exactly we want to visualize it. So instead of using the bar graph, we have the option for map. Now in map, we have the start support from ArcGIS map for Power BI, or we can make use of simple maps section available that we can use it for visualization. If you want to use ArcGIS map, then we can simply choose the ArcGIS map, or we can make use of simple map tool offered itself by the Power BI itself. So here we can see here we have plotted the entire report in terms of different cities for the global level. We can see the entire data set has been plotted. And now in terms of profit, right? So let's say if you want to see the segment as well. So here we can add segment as a part of the color. So suppose here we can add different colors, different tooltips also added here as a part of segment that we can use it for visualization part. So now we can see here we had different colors defined, right? And we can see the entire in terms of now why we because we have added different segments and different colors. So you can see different reports here, right? So here red has been given to consumer, then we have the green given to the home office, and the blue has been given to the corporate as a part of the color segment. So we can simply visualize how exactly the entire distribution has been in different cities all around the globe as a part of the color segment. Or if you want to add this as a part of tooltip, then you can add tooltip as well. Tooltip as in if we hover over the over different items here, then only we are going to see the detail as a part of tooltip. So we can define it either as a tooltip, or we can define it as a part of the color scheme that we want to visualize. And once we are done, we can simply go to the file section, and here we can save the entire report. We can export this to the PDF as well, or we can generate a complete visualization dashboard where we can click on publish. And then when we simply publish, then we can create a complete dashboard through which the end users, they can interact with the entire data set that we have defined. So that they will be able to interact how the data has been defined, and then they can work accordingly. Now we can see how we can easily integrate the Azure ML Studio with Power BI. So let me showcase you how we can integrate the ML Studio as well. So Azure ML is what? Azure ML is basically useful in making sure that if we want to create a model for testing use case, then we can do that easily by using the ML Studio itself. Now, ML Studio is a really good platform, one of the best services offered by Azure. And we can say that it is even better than any of the cloud computing platforms that we have present currently. So its ML Studio is really easy to use platform through which we can create the entire testing models. We can deploy it right away as per the requirement. We can easily do that. So first of all, to get started, we can start by signing up on Azure platform. Let me showcase you how we can sign up on these. All right, so to get started working on Azure, we can simply click on this link here, which says create free account on top. And once you click on free account, we will be taken to a complete sign up form where we can register. So for signing up on Azure platform, we can click on the link which says free account on the Azure website. And there we have to sign up just like we sign up for any other website, where we can specify the account details. And just like we need to have an active payment method for Netflix and Prime Video, we also need an active payment method for signing up on Azure. And once we sign up, we won't be getting charged once we sign up for an account on AWS. We would be getting $200 of free credit that we can use against our billing for a period of 1 month. And just like we get $300 of credit when we sign up on Google Cloud product, which we can install in 1 year, and in AWS, we get the access to some selective free tier services that we can use under limitation. So same way here, we can also get the access to the services that we can make use of. So you can sign up on the platform. Here you go. And once we log into AWS or to Azure platform, this is the dashboard that we are going to look at. And here we can click on the menu icon where we can see all the resources, resource group, app services, function app, SQL databases, on storage accounts, on virtual networks, Azure Active Directory, monitoring, advisory, security center. We can see the entire report as per the requirement. We can see the entire report. So to get started working on the ML Studio, we can search for a link directly called ML Studio from Azure. So here we can type in as studio.azureml.net, where we can log in via our own Azure account that we have signed up for. Here we can click on sign in, and once we sign into this link, we would be taken to the Azure ML Studio that we can use for getting started with the machine learning models deployment. So in the Azure Machine Learning Model Studio, here we can work on creating multiple experiments. So for example, suppose here we want to work on experiments. We can see these are a list of all the experiments that we have already created. And now we want to work with new one. Then here we can click on create a new assignment. So here we can click on new. And here we can choose what kind of experiment we want to work on. For example, we want to work on the experiment tutorial. We want to work on a blank experiment on dataset processing. So there are multiple templates available that we can choose here. So let's say here we want to work on blank experiment. So here we can click on blank. And here we can simply map out the entire dataset. And here we can create the entire experiment as per the requirement. We can do that directly here. All right, so here we can define the entire output and create the entire testing script so that we can run those testing scripts automatically and that to as quickly as possible. All right. So first of all, we have to work on uploading the current data set as well. So if you do have the access to data set, so here we can refer to save data set where we have my data set. So now currently, let's say we have our data set available for COVID-19 and let's say we want to work on it. So here we can simply import the COVID-19 India.csv. For example, here we can pick this data set and then now we can use this current data set to use or to suppose, let's say, to create a complete model out of it. Now for this, we have to, again, in case we don't have a data set available, and here we can click on samples where we have sample data set already available that we can play around with, or if we want to work on our own data set, so here we can click on this option data set, and to start new, then here we can simply click on new. We can choose from a local file. Let's say we have used a local file for the sales data, right? And now we want to create a sales prediction out of it. Then here we can create a model for that sales prediction as well. For example, here we can choose a local file that we want to work with. Let's say here we had the access to that Excel file, correct? To that Excel file, XLS. So where we have the access to this global superstore, we can make use of this data or we can make use of any old data that we may have the access to. So for example, we want to work on this one. So here we can click on upload, open, and then we can click on add. So this is what, okay, we haven't saved that in the CSV file. So let's see if we do have the access CSV that we've already imported as a part of COVID India analysis. Where we have data set for the active COVID patients, for the recovered patients so far. So we can make use of this data for now. Now to work on creating a model out of this current data. So here we can go back to the experiments where we can create our own experiment. So here we can come back to experiments. We can click on new. Here we can click on experiment, not tutorial, on blank experiment. We can have the access to this one, and here we can simply drag and drop it here. Now to see it, now here we can simply click on data set, and here we have visualize. So we can simply get a complete visualization created so we can see how, like, what are different pointers available in this current data and then how exactly we have to work with these. So let's start again. So first of all, let's say we don't want to use the entire data set available here. We only want to make a selection. So for doing that, we can search for select data set here, and here we have select column. So let's say here we want to be selective in terms of the column that we want to choose. So here we can drag and drop the select part. And now we can define select. Here we can click on launch column selector. So here we can choose which all columns we want to work on. And then we can, currently we have these different data pointers available. So we have to choose from these data pointers only, that which data pointer we want to work with. So here we can make a selection accordingly. Let's say here we are going to work on the prediction for the survival rate. So let's suppose here we want to work on, here we want to include confirm international. Here we want to confirm the cured, and that's as well as a part of the data pointers that we want to work on. So here we can define the data as well. Now these all columns you want to work work on here, and here we can click on select. So again, these different columns have been selected as a part of our model building. Now here we can search for another data pointer here as split. So here we can make use of split. Now we want to split the current data set into equal components here. We want to have the train data and test data defined. So here we can split the entire data into training and test data because we don't use the entire data set. We split the entire data set, and that's how we start working on it. So here we can split the entire data set into one training and the other component to be testing data. So here we can define the fraction with which we want to test here. Let's suppose here we want to make a selection of 75% of the current data set. So here we can define 0.75. That means again, suppose if there are 100 columns, there are 100 different rows here, then 75% of those rows are going to be split. That is what we have currently defined. If you want to make a selection in terms of 50% or 75%, generally we keep it to 75%. So we have a good amount of data that you can use for the training purpose. We can define it. And then if you want to randomize splits, then here we can simply click on randomize splits, or we can keep it to just one. So now we have defined in the splitting data how data is going to be split in 75 and 25%. And here we have defined for 75% for the first component. Here. So here we can define machine learning. So here we can search for machine learning algorithms. Now there are multiple machine learning algorithms available here. So let's say here we are going to make use of. Now here we can make use of, let's say, which model shall we select? So here we can make use of, let's suppose two class decision forest. So here we have two class decision jungle, and this one is forest. So here we can simply drag and drop two class decision forest. We can place it here, and then here we can insert the training model as well. So here we have on the machine learning. Here we also have train model also available. So here we can also drag and drop the train model. All right, so here we can split the entire data set and again we can use it for training the model. And then we have decision tree, and here we have decision tree. So basically here we can use a training model here, and then the decision tree we can integrate with this with the entire training model that we can create here. So once we define the entire training, once we have connected the two decision forests with the training model, so again for training model as well, we can simply launch the column selector in terms of which column we want to make use of. So here we have rules, and here we have defined the column names. If we want to include the column names, or let's suppose here we want to search for the confirmed national. Here we want to search for not just for confirmed, the number of patients cured, deaths, and the time frame as well. So we can remove the confirmed national. So here we can choose these pointers, click on select. Or suppose here we want to make use of the confirm as a main parameter. We can choose confirm, we can select, and here we can simply define the score model. So here we can search for score model. We can define the score model, and here we are going to link the score model here along with the components that we want to integrate this with. And once we are done, we can simply run it to see. Now, if each and every step is correct, we will be able to see the entire model created one by one. That means currently each and every model statement is currently being executed one by one. And if there are no issues, it is going to be deployed automatically. And now if we want to visualize, and here we can right click on it. Here we can click on score data set, and here we can visualize to simply see the entire score based distribution that has been currently derived for each and every data pointers here to what we have defined. And here we can set up the predictive web services, which is currently recommended. So as you can see here, the entire model is going to be defined and deployed for creating the entire predictive experiment. So the entire experiment is currently being deployed automatically. And same way, we can integrate this entire component by taking care of a simple R script back in Power BI, through which using that R script, we can easily create the deployment and have it done.
With Azure integration covered, we'll discuss Power BI certifications. This module will help you understand the certification process and prepare for Power BI certification exams.
Now, you might just think this is something that business intelligence experts or data analysts should get their expertise on. But how you use Power BI will depend solely on your role in a project or on a team, and sometimes even your own interests. What other people do with Power BI in other roles might be very different from what you're using it. For example, you might primarily be using Power BI services to view reports and dashboards as a business user. Your number crunching, business report creating, data analyzing coworker might be making a more extensive use of Power BI by using the Power BI desktop or the Power BI report builder. He or she might use it to create reports, then publish those reports to the Power BI service where you were viewing them previously. Let's take, for example, another coworker who is in sales. He or she might mainly be using the Power BI Android or iOS application to monitor the progress on sales quotas and to drill into the new sales lead details. If you're a developer, you will then also be using the Power BI APIs to push data into datasets or to embed dashboards and reports into your own custom applications. Also, if you have an idea for a new visual, you could go ahead and build it yourself and share it with others using Power BI. There will also be people who use each element of Power BI during different times in their very role, depending on what they're trying to achieve or their role in a given project. How you use Power BI can be based on which feature or service of Power BI is the best tool for your current scenario or situation. You can use the Power BI desktop to create reports for your own team about customer engagement statistics, and you can also view inventory and manufacturing progress in a real-time dashboard using the Power BI service. Creating a paginated report of mailable invoices based on a certain dataset. Don't worry, Power BI is still here for your rescue. Each part of Power BI is available to you, which is why it's so flexible, it's so versatile, it's so eclectic, and that is partly why it is so compelling to individuals and enterprises alike. You can be a business user, a report creator, an enterprise person, an administrator, a developer. Power BI serves each and every one of these roles alike and with equal integrity. Now that you know why Power BI is so compelling to businesses and enterprises, let's try and answer the question about you and why you should be looking forward to getting Microsoft Power BI certified. Now, there are a couple of reasons, and I'd like to start with one which is most common, and that is Power BI being known as a leader in the field of analytics and business intelligence platforms. It has been crowned the best by the IT research giant Gartner. For those of you who might not know, Gartner's Magic Quadrant is a series of market research reports published by the IT consulting firm Gartner that relies on proprietary qualitative data analysis methods to demonstrate market trends such as direction maturity and participants in a certain tool or technology. And for the past couple of years, Microsoft Power BI has been acing it on its ability of execution and completeness of vision in the Magic Quadrant for analytics and business intelligence platforms. In addition to having this accolade, the market also shows great demand for Power BI practitioners and experts, and they are ready to reward you equally well too. If you browse through job portals such as Indeed and Payscale, you can find plenty of job listings where the key skill required is a hands-on knowledge of Power BI. Apart from that, Power BI professionals are also getting into a higher salary bracket in the IT industry with an average of $117,000 per annum. And with tons and tons of jobs available in the business intelligence and analytics market, and the skill gap when it comes to proficient and eligible data analytics and business intelligence experts, it creates a sea of opportunities for you if you are ready to get on the bandwagon. So if you want to get Microsoft Power BI certified, this is a great year for you. Moving on, let's discuss the meat and potatoes of this session, which is the Power BI certifications for the year 2021. Now, there are 4 certifications in total, 3 associate and 1 expert certification, and 4 exams which act as prerequisites to those certifications. We're going to discuss each of those certifications in depth in the following section. But before I begin, let me just mention this one thing. One extremely popular certification known as MCSA on BI reporting, which had exams such as 7778 and 7779, is discontinued as of the year 2021, which is why we will not be discussing that certification. So let's go ahead and start out with our first certification, and that certification is the Microsoft Certified Data Analyst Associate, which is targeted mostly towards data analyst and business analyst positions. Now, data analysts basically enable businesses to maximize the value of their data assets by using Microsoft Power BI. As a subject matter expert, data analysts are also responsible for designing and building scalable data models, cleaning and transforming data, and enabling advanced analytic capabilities that provide meaningful business value through easy to comprehend data visualizations. Now, the skills measured through this certification exam is your ability to prepare the data, model data, visualize the data, analyze the data, and deploy and maintain deliverables. As a prerequisite, or the required exam that you need to give, is your DA 100 exam, which basically equips you with the understanding to become a subject matter expert for designing and building scalable data models, cleaning and transforming data, enabling advanced analytic capabilities to provide business insights to your stakeholders. This exam has around 40 to 60 multiple choice and multi-response questions, and to pass the exam, you need at least 70% or 700 on the scale of 1 to 1000. This exam is available in English, Japanese, Chinese, and Korean, and you will be getting 180 minutes to complete the exam. Now, the cost of the examination is $165 or 4,800 Indian rupees. And the price of this examination is based on the country in which the exam is proctored. Next, we have the Microsoft Certified Power Platform Functional Consultant Associate Certification. Now, this examination's demographic includes business analysts, developers, and functional consultants. So if you are a functional consultant, data analyst, or developer looking to hone your consulting and configuration skills, or you are a solutions architect on the path to a solution architect certification, this is the exam for you. This is also a very good choice for an IT professional with the knowledge and experience configuring Microsoft Power Platform. Now, if this basically describes you and you're familiar with using the Power Platform components to extend and customize Microsoft applications and services such as Teams, Dynamics 365, and Microsoft Office, you can explore the Microsoft Power Platform Functional Consultant Associate Certification. This can basically help enhance your career and make you a key member of your team. This certification indicates to the world that you're considered qualified to build and implement solutions that use Power Apps, Power BI, and Power Virtual Agents. Now, as a candidate for this certification, you will basically work on an organization's stakeholders and subject matter experts such as solution architects, developers, and testers to gather requirements and then implement Microsoft's Power Platform solutions. You will build model-driven Canvas and portal apps, and you shall create Power Automate flows and design chatbots using Power Virtual Agents. You will also be analyzing data using Power BI visualization and dashboards. You will even create application enhancements, custom user experiences, system integrations, data conversions, custom process automations, and custom visualizations through the same. As a functional consultant, you can use this certification to market yourself more effectively for projects and other engagements. The Microsoft Power Platform Functional Consultant Associate Certification lets organizations know that with no code or low code, you can build solutions that would normally require a senior developer level expertise. If you need more experience before you try this certification, we would like to suggest to build a basic dashboard using Power BI, take an available learning path on Microsoft Learn, or sign up for an instructor-led training course on various platforms available to you. Now, about the skills measured through this certification, you will first of all need to configure the common data service, create applications using Power Apps, as well as create and manage Power Automate. You will also have to learn how to implement Power Virtual Agents via chatbots and integrate Power Apps and other applications and services. Now, this exam is available only in the English language and costs 4,800 Indian rupees or 165 US dollars. Now, the exam you'll have to take for this is the Microsoft Exam PL200, which has basically come in place of the Microsoft Exam MB200, which expired on December 31st, 2020. And again, the passing score here is 70% or 700 marks or more. The test contains 129 questions and covers objectives to configure the common data service, create apps by using Power Apps, creating and managing Power Automate, implementing Power Virtual Agents or chatbots, and integrating Power Apps with other apps and services. The quality test content, it's extremely important to us that you understand the quality of the test content so that you can be prepared on your exam day. Moving on, you have the Microsoft Certified Power Platform App Maker Associate. So if you are a business professional with a deep expertise in your solution domain and you want to leverage your passion for building Microsoft Power Platform solutions, which basically simplify, automate, and transform tasks and processes for your team, this certification is designed for you. You must have the skills to accomplish key technical business analyst tasks such as data modeling, basic UX design, requirements analysis, and process analysis. So as you might have guessed, this is basically aimed at job roles such as business analyst, business owner, business user, data analyst, developers, DevOps engineers, application developers, and technology managers. So if you fit the profile for an application maker role, if you are self-directed and solution-focused and you work with the maker tools of Microsoft Power Platform to solve business problems, this is a great certification for you. Now, you might have experience with Visual Basic for applications, Excel, pivot tables, Teams, and other tools. Although you might not have formal IT training, you're comfortable working with IT administrators and Microsoft Power Platform developers using technology to solve business problems. So basically, you're responsible for designing and creating applications and automating workflows. You will be analyzing and visualizing data in the context of an application and automated workflow. You will also be implementing and managing applications and automated workflows. So if you need more experience before you try this certification, you could definitely try and volunteer on a project to get some real-life experience with data modeling, basic UX design, requirement analysis, and process analysis. You could also take up one of the learning paths provided to you on Microsoft Learn or sign up for an instructor-led training course with us. And that should serve as a solution for all your hesitations regarding this certification examination. Again, for this, the required exam that you have to take is PL100, and the skills measured would be design solutions, creation of solutions to analyze and visualize data, to implement and manage business intelligence solutions. Again, as I had mentioned before, the certification costs 4,800 INR or 165 US dollars, and the prices are based on the country in which the exam is proctored. This exam too can be taken only in English and has no retirement date. Now, this exam also has multiple choice and multiple answer questions, and you have to solve 50 questions in 120 minutes. So if you're a business professional with a deep expertise in your solution domain and you want to leverage your passion for building Microsoft Power Platform solutions, this is the best way to showcase your skill in the business intelligence market. And finally, we have the Microsoft Certified Power Platform Solution Architect Expert. So if you're looking to prove your expertise as a Microsoft Power Platform or Microsoft Dynamics 365 solution architect, or you're a developer or a senior consultant ready to take the next step to becoming a solution architect, this expert certification can help you move forward in your career. Now, as a candidate for the Power Platform Solution Architect Expert Certification, you have to work with stakeholders and focus on solutions that affect your organization's broad business and technical needs. You have to have the functional and technical knowledge of the Power Platform, Dynamics 365, customer engagement apps related to Microsoft Cloud solutions, and third party technologies for this certification. Now, to pursue this certification, you need a minimum of 1 to 3 years of Power Platform Solutions Architect or 7 to 10 years as a senior consultant or developer, along with a deep knowledge of Power Platform architecture, including Power BI platforms. Now, if you need additional experience before you try the certification out, a few suggestions would be to work as or to act as a shadow for a solution architect on Power Platform Power BI projects, or you could sign up for a live instructor led training course with us, or explore available learning paths on Microsoft Learn. This certification will be available March 17, 2021 onwards, and its target demographic is basically developers, functional consultants, and solution architects. Now, the prerequisites would be two certifications, which I previously mentioned: the Microsoft Certified Power Platform Functional Consultant Associate Certification and the Microsoft Certified Power Platform Developer Associate Certification. Your skills measured would be to perform solution envisioning and requirement analysis, to architect a solution, and to implement that very solution. So basically, you can either choose between both of your prerequisite options, or you could take one exam, which is the Microsoft Power Platform Solutions Architect exam, to earn your Microsoft Certified Power Platform Solutions Architect Expert certification. Now, again, this costs 165 US dollars or 4,800 Indian rupees to take this examination. So, to be certified, you will be giving the PL 600 exam, which will soon be a replacement for the MB 600 exam. You will have about 50 questions, which would have a variety of yes, no, multiple choice, drag and drop, and different kinds of solutions. And you will get 180 minutes for this examination. So, with that, we have discussed all the certifications available to you by the Microsoft Power Platform.
Having explored certification, our next topic is top 10 reasons to learn Power BI. You'll discover the key benefits and opportunities that come with mastering Power BI.
So the first reason to learn Power BI is the industry leader. Among the business intelligence platforms, Microsoft Power BI already has a majority market share of 36%, followed by Tableau, which has about 20% market share in the data analytics market. Because it is already being used by most, Power BI is often chosen by others as it already has a huge support for enterprise business needs. And it's not just a coincidence. Power BI is used by most because it has so many features that makes it very versatile to stick to. Moving on to the second reason. Power BI makes it extremely easy to connect to your data. Power BI has greater accessibility to bring data into a single place and work with it and help generate useful reports. Power BI supports over 70 connectors, letting businesses load their data in whatever format they might have saved the data, whether it is stored in local drives or online cloud storage such as Azure Data Warehouse, Dropbox, OneDrive, or even from your database like SQL. With these connectors, it is incredibly fast to load and perform data analysis within minutes. It is also possible to customize your visualizations according to your liking to make it visually appealing and more presentable. Reason number 3. The high performance. Power BI's Power Pivot data modeling engine, shared with Excel, is a highly performant columnar database, compressing databases to ensure sufficient memory loading for the best possible performance. This is why the Power BI file PBIX is usually significantly smaller than the original datasets. That may be usually even multiple of MBs or GBs. It is like 1 GB of your data can be compressed to 50 to 200 MB in size with Power BI. Whereas if you were to use Excel for the same, Excel will incrementally start to slow down. And Power BI is made for this, as it is optimized to deal with larger datasets in excess of 100 million records without a hiccup. Power BI also refreshes data in increments to ensure that data is always up to date. This advantage makes visual reporting great for the end user, as they can get insights without too much processing times in between the data analysis steps. Another reason to learn Power BI is the added benefit of customized visuals. You can customize your visualizations, which are more often than not open source. Although Power BI already comes with standard data visuals, in case you require more, you can get them in the Microsoft market. Although in most cases, the standard visualizations such as bar charts, plot charts, or scatter plots, or even histograms and slices will be sufficient for business analysis. Having the option and access to other charts at your disposal is a very great thing to have. In addition, the Power BI community is also a great place where you can get custom visualizations that tells your data story in the best possible way for your specific data story. Thus, the developers and Power BI community is a great place to get more help and become more proficient in Power BI. And the flexibility of Power BI to make your own visuals to tell your own data story makes it not rigid, allowing for better presentation and understanding of the data story. Reason number 5 is Power BI's familiarity to Excel. Most of you know that Power BI and Microsoft Excel come from the same family. Those who are medium to advanced level person in Excel and uses the DAX can easily dive deeper into Power BI to make complete use of its features with relative ease, as there is no reason to relearn much. And thus developers can utilize Power Pivot features such as clustering, forecasting, grouping, and even quick measures and so on without too much expertise. The Power Query tool will also seem familiar to Excel developers, making it very easy to understand and work with. On top of it, Power BI very easily integrates with Excel. Therefore, exporting data and working with it becomes a cakewalk. The next reason to learn Power BI is its amazing security and governance. Power BI lets you manage user access and security with ease. There is no need to use any other tool to ensure that compliance and regulatory requirements are met. The service also has Azure Active Directory or AAD. This mainly is for user authentication and allows you to leverage single sign-on or SSO along with regular Power BI credentials for logins for accessing data. The next reason is the access to the updated information. Data keeps on changing and Power BI is built to handle the real-time information updates in the database. As the data is streamed in or pushed into Power BI, the dashboard automatically updates, which gives stakeholders the correct updated information to make intelligent business decisions, whether it be identifying problems or opportunities. Social media sources or database information is streamed and updated in real time in the dashboards or Power BI reports. Moving on to the next reason. It is accessibility and simplicity of the Power BI. It is not mandatory for someone to be a data scientist or a data analyst or even be working in the field of data to start using Power BI for data analysis. The tool is very intuitive and easy to use, making someone build visual reports as easy as possible. Whether you are a beginner or advanced user, you can build simple or as detailed reports as you like. You can build overviews of business, heat maps, scatter plots, bar charts, histograms, or even use customized visualizations to build your own reports. You can also interact with dashboards to get specific information relevant to a subject just with the click of a button. Reason number 9 is probably the most important, and that is the advanced data modeling Power BI offers. It is the ability to model data that makes it crucial to build useful business intelligence solutions. This has made it possible to forecast trends and predict future outcomes relatively accurately. Power BI is an amazing tool capable of providing not just insights into the data, but also having predictive analytics capabilities and forecasting features to explore or predict future outcomes. It is possible to run comparisons of what if scenarios. Let's say we have some financial information. We can use financial forecasts and we can add forecast to, let's say, our line chart without much coding required at all. Power BI uses predictive forecasting models built into its software to detect seasonality and next reporting period, whether it be for week, month, or year, to provide forecast relatively easily. The built-in models use statistical algorithms to learn from historic data to derive meaningful probable results and provide them as results in visualization. Thus, you don't need to learn machine learning or deep learning to derive useful probable results almost automatically and with minimal effort. And now, let's talk about the final reason to learn Power BI. It is the ability of Power BI to bring data sets from multiple sources to one place and work on it. Everyone has their own requirements for business intelligence needs. A data analyst might be keeping tabs on data sources from multiple countries and using it in their metrics. The head of a manager from one country might want to see the overall business metrics, but not in detail. Maybe they might be more interested in seeing a consolidated view of the business. And this is where Power BI helps. Power BI helps create different dashboards. For instance, you can create a separate report for business critical data that may be useful for CEOs. And on the manager level, you can mostly create a different dashboard which will be useful to managers. You can also use official free add-ons, and these apps provide highly customizable graphics that can be used for reporting purposes, whether it be simple or complex, as required. And with that, we conclude the top 10 reasons to learn Power BI in 2023. Data analytics and data science is here to stay, and becoming proficient in understanding data will and currently is shaping our future. Data analytics and business intelligence tools are helping countless operations optimize and run efficiently while providing tools and solutions for better strategic understanding on how to move forward. Getting smart insights from data is crucial, and it is not difficult to comprehend why the Power BI is growing in popularity among businesses and enterprises who need actionable insights, interactive dashboards, and great reporting. So now is the time to learn Power BI and get better understanding of how business intelligence works.
After learning why Power BI is valuable, we'll now have a look at Power BI versus Tableau. This module will highlight the differences and similarities between Power BI and Tableau to help you choose the right tool for your needs.
Starting off with data visualization. Tableau is well known for its ability to visualize data. Users can create interactive and customized dashboards that are device agnostic. In Power BI, on the other hand, have a large number of data points to offer data visualization. Its simple drag and drop functionality is a deal for both technical and non-technical users. Next is the products. Tableau and Power BI both have released new data analytics and business intelligence products. Here are the various types of products which are used in Tableau and Power BI. First is the Tableau Serve. Next, Tableau Public, Tableau Online Cloud, Tableau Reader, and finally, Tableau Mobile. Power BI is a part of Microsoft Business Intelligence. It offers a wide range of products which are Power BI Desktop, Power BI Services, Power BI Pro, Power BI Premium, and finally, Power BI Mobile. Next is the security. Tableau comes with the following predefined user roles: viewer, interactor, and editor. The publisher can configure access permission for these roles. Tableau offers data security, network security, and RLS option for administrator. It recommends SSL and HTTP configuration for network communication between the client and the Tableau service. On the other hand, we have Power BI. Power BI stores and manages data storage security using Azure Blob Storage, Azure SQL databases, and role level security is also provided for role based data access. And the final one is the dashboard. Tableau features are comparable to those of Power BI. In comparison of Power BI, however, many of the features are hidden behind the menus. Tableau is well known for its attractive dashboards that are simple to build with drag and drop. On the other hand, Power BI includes modern features that assist in converting raw data into interactive and visually appealing dashboards. It allows users to visualize data insights, even if they have no prior knowledge or experiences. Creating dashboards with Power BI tiles or visible matrices which directly interacts with the reports and data sets. Moving on to data cleaning in Tableau and Power BI. Data cleaning in Tableau entails preparing and shaping raw data so that it can be efficiently analyzed and visualized. Here are some of the common Tableau data cleaning steps. Connecting to data. Connect to your data sources in Tableau using one of the available connectors, which are SQL, Excel, CSV, etc. Handling missing values. Identify and manage missing values. You can filter out or replace missing values within Tableau using data sheets. Removing duplicates. Check for or remove duplicate row if necessary. You can do this in Tableau by using the remove duplicate function. Finally, data type conversion. Ensure that the data type conversion are appropriate for each file. Tableau automatically assures or assigns data types, but you can change them manually if necessary. Data cleaning in Power BI. Power BI is a process of preparing and transforming raw data into a clear and structured format for analysis and visualization. Here are some of the common data cleaning steps used in Power BI. Data loading. Load your raw data into Power BI using the data source connector, which are SQL, MySQL, Excel, CSV, and etc. Handling missing values. Identify and address missing values. You can use Power Query Editor to filter out or replace missing values. Next is the data type conversion. Ensure that data types are appropriate for each columns. You can change data type by using the Power Query Editor. Finally, handling errors. Identify and handle errors in your data. Power BI provides option to replace errors with default values or remove error rows. Now, we will take a look at the parameters of Tableau versus Power BI. Performance. It improves performance while dealing with large amount of data. Source of data. Having access to a large number of services and database sources. Ease of use. Tableau is known for its simple drag and drop interface that allows users to create visualization quickly. Visualization capability. Tableau is well known for its powerful and versatile visualization capability. Tableau is famous for its ability to provide complex and detailed visualization. Finally, data preparation. Tableau has data preparation feature, but it is less advanced than the Power BI's Power Query. A separate tool, Tableau Prep, is available for advanced data preparation. Next is the parameters of Power BI. Performance. It can handle only limited amount of data. Source of data. It can handle only limited sources to access databases. Ease of use. Power BI is well known for its user-friendly interface, particularly for those who are more familiar with Microsoft products. Visualization capability. Power BI provides a wide range of visualization options, as well as the ability for the user to create custom visuals. It focuses heavily on interactive and dynamic dashboards. Finally, data preparation. Power Query provides robust self-service data preparation capability, allowing users to clear and transfer data into the Power BI interface. Now, we will move on to the use cases of Tableau versus Power BI. Here are some of the common Tableau use cases from various industries. Business dashboards. Create interactive and dynamic dashboards that display key outcomes. Track performance against target by monitoring real-time data. Data exploration and analysis. Quickly explore and analyze large sets of data to discover trends and patterns and how analysis is used to answer specific business questions. Financial analysis. Create visual representation of financial data such as revenue, expenses, and profitability by using interactive dashboards and performing financial modeling. Finally, operational analytics. Visualize key functional matrices to monitor and maximize operational process, identify errors, and process improvement opportunities. Next is the use cases of Power BI. Data exploration and analysis. Discover insights and trends by exploring and analyzing large data sets. Perform independent analysis with Power BI user-friendly interface for quick decision making. Inventory and supply chain management. Visualize and analyze supply chain data to improve inventory management. Monitor supplier performance and maximizing the supply chain to reduce cost. Project administration. Monitor project status, resources allocation, and team performance. Create a visual representation of the project timelines and achievements. Finally, data monitoring in real time. To monitor and visualize real-time data, use Power BI streaming capability. It deals with the requirements which are immediately made as insights, such as manufacturing or IoT applications. Now, we will discuss about which should you choose. Both Power BI and Tableau performs well in business intelligence and data visualization, making it difficult to say which is superior. The only conclusion that is relatively easy to draw is that Tableau is more robust than Power BI, whereas Power BI is easy to get started with and it is more affordable. Learning both can be a best option, and the salary for Tableau and Power BI may differ in India and in United States. In India, the salary for Power BI is 5 lakhs to 9 lakhs per annum, whereas in United States it ranges from $117,000. And Power BI salary in India is 5 lakhs to 8 lakhs per annum, and in United States it is $110,000. If you still need to choose which tool is best for you, then try both of them and find out which is perfect for you.
Here is another simple question. Which tool is known for offering more robust visual analytics and interactive dashboards in its free version? And the options are A. Power BI, B. Tableau, C. Both, D. Neither. If you know the correct answer, please leave it in the comment section below. With the comparison complete, we'll move to comparing Power BI and MSBI. We'll gain insights into how Power BI stacks up against Microsoft Business Intelligence tools.
Now, before I begin, let me make it very clear that when I say MSBI, I'm going to talk about only one of its SQL Server data tools, which is the SSRS. I'll let you know the difference in a bit. Now, the MSBI is a Microsoft product with ETL capabilities, which basically means it can extract, transform, and load data. It has this multidimensional data organizing and visualization ability. So MSBI comes with 3 subcomponents or tools to support the earlier mentioned functionalities. The following are the components of MSBI. So we have the SQL Server Integration Services, or the SSIS, which is a component which basically works as a data integration service and perform up to some level of ETL activity. Next, we have the SQL Server Analytics Service, which is a component which works as multi-dimensional data storage using Cube to store the facts and dimensions. Finally, this is what we are going to be comparing Power BI with. This component, the SSRS, or the SQL Server Reporting Service, works as a data visualization and reporting layer, and it allows to create dashboards and reports for MSBI. I'm doing this because we can't really compare MSBI with Power BI, which was basically just designed to improve the self-service capabilities of the older SSRS, which is just one of many services of the MSBI. So let's start with the comparison. But first of all, what are these two tools?
So the SSRS, or the SQL Server Reporting Services, is a BI service for data analysis and generating reports on the server-based data. It was developed in 2004 by Microsoft, along with its data analytics and data integrating counterparts. Now, it is a comprehensive, extensible reporting platform, which includes integrated set of processing components and programming interfaces. It is used to design, test, and deploy the report. So mainly it's a server-based platform. On the other side, we have Power BI, which was also developed by Microsoft in the year 2017, which is a data analysis and reporting tool, which can be used for reporting from a wide range of data sources, both traditional and untraditional. Now, the Power BI desktop allows you to create reports on the fly and publish them. Using any browser, end users can view these reports. So the Power BI is simple and user-friendly, which helps business analyst skills and Power BI users to work easily on it. For the complex and huge data analysis, Power BI is very useful as it is widely used for modeling and structuring of unshaped data. So this comparison is going to be based upon the following criteria. We have implementation, benefits of each of these tools, accessibility and use on various platforms, license and pricing, a learning curve, user experience, data dependency, and finally, the conclusion. So without much ado, let's begin with the comparisons. First of all, we have implementation of each of these tools. Now, the SSRS is used for server-based reports only, while the Power BI is used for server-based as well as cloud-based reports. Now, the biggest difference between these two systems is how they are deployed. Since cloud-based software is hosted on the vendor servers and accessed through a web browser, and on-prem software is installed locally on a company's own computer and server, the fact that these services are equally promising has led to an ongoing discussion about the superiority and the security concerns of one over the other. The fundamental point is that not all solutions work equally well in the cloud or in the on-premise hosted solution. There are benefits and disadvantages to both the platforms. Your choice between these platforms will depend mostly on the type of need, service, or software you're considering. Now, what about the cloud platform? Hardware failures do not result in data loss because of network backups. So cloud computing uses remote resources, saving organizations the cost of servers and other equipment. Also, a utility pay structure on the cloud platform used by Power BI means that users only have to pay for the resources they use. However, with the rise of cloud-based services, an additional fear comes into play. After all, you're trusting someone else to host your data, aren't you? The fear is so widespread that many IT leaders believe that this powerful internet services are a security nightmare. So in that case, server-based reports are definitely safer, which gives 1 point to SSRS and 1 point to Power BI. Next, we have benefits of each of these tools. Now, both of these services have their own benefits, while the SSRS by MSBI has a better drill-down capacity, which basically means in a GUI environment, you can move from one place to another information to detailed data by focusing in on something. The Power BI, on the other hand, has a plethora of rich visuals, which represent data so much better. Also, since it was designed to improve the self-service capabilities of the older SSRS, anyone who can visualize data can use it easily. Next, we have accessibility. This is a pretty simple point. The SQL Server Reporting Service, or the SSRS, can be operated using the web and desktop, whereas the Power BI can be used with the desktop, the web, and the mobile app. You can also generate a QR code from a report in the Power BI, just in case you want limited people to have access to your reports. Next, we have the license and pricing, pretty important. So the free version for the SSRS lasts 180 days, which is followed by a base charge of $931, whereas a free version for Power BI lasts only 60 days, but the base price is less than $10. Note that the pricing I have mentioned here are only the base prices of both, and there are other versions of these services and the prices vary for each of them. Next, we have a very important aspect, which is the learning curve for each of these tools. Now, the Power BI is a graphical tool, so through drag and drop, you can easily complete your report. but the internal processes are hidden, so you can't really understand how it works. But in the SSRS, the developer has to do all the coding and designing of the report, so the developer has a better picture of the process and a better understanding of how this data works. Next, we have user experience, which is a complete win-win for Power BI, as it has a lot of graphical component as compared to SSRS. It makes Power BI way more efficient and easier to use, whereas in SSRS, it has more manual effort to be put in for analysis and generating the reports, so it's not really the easiest option for beginners. With that, I come to my final point, which is the data dependency. Now, the Power BI can deal with structured as well as unstructured data, but due to that, its data capacity is limited to only 10 MB or 33,000 rows of data, whereas the SSRS deals with structured and semi-structured data, so you can create really large reports on it. I think with that, we are ready to conclude. So as you can see, I've made comparisons on both sides for the SSRS as well as the Power BI. Now, the SSRS is for your pixel perfect operational reporting. So that is why it ensures a better background understanding of data, a higher drill down capacity. It works with structured data, does not have any size limit to reports, and most importantly, it has a design first approach. And the Power BI, on the other hand, is first and foremost an analysis tool. So it allows you to visualize your data in different ways in order to allow deeper understanding of your business and not the process. So that is why it is rich in visuals. It is supported by cloud service. It is interactive and pretty user friendly. It is portable and low cost. So till now, SSRS has had a lot of presence in the IT market, but now Power BI has made its presence known across all domains. The choice between Power BI and SSRS will likely be straightforward and likely be driven by requirements. So if your organization uses only paginated reports on premises, you shall decide that SSRS is more cost effective as an option. On the other side, if you have the need to render interactive or analytical reports on the business, then possibility is Power BI reporting services will likely be your preferred choice.
Finally, we'll wrap up with Power BI interview questions and answers. This module will prepare you for job interviews by discussing some common questions and effective responses related to Power BI.
And obviously, what is self-service business intelligence? So needless to say, Power BI, the very fact is that Power BI is one of the most popular SSBI tools in the marketplace today. And any of you who have worked on other BI tools coming from the world of Tableau or ClickSense or Spotfire, you can also relate to this. So if you are asked a question, what is self-service BI? I think the first approach to take is to explain what is SSBI. Okay. Now, any of you, as I said, if you have come from the world of traditional business intelligence, right? If you have worked on tools like SSRS, Cognos, if you come from MSBI world, or if you use the business objects, you typically have used tools where it's not exactly built for end users, right? So essentially building reports or building any kind of project used to take a lot of time. Obviously for developers, it's a very easy tool to use. But if you think of end users, at the end of the day, if you think of the business users or the end users or non-technical people would find it very difficult to use something like, say, a Visual Studio to develop MSBI SSRS reports. Okay, so that's the world of traditional BI, where development cycles were long and there's a big hindrance, right? So if business users want answers to certain questions, let's say if a mutual fund manager wants to know how has my fund performed over the last 10 years in the form of a very simple line chart, that mutual fund manager has to go back and depend on his internal IT team to go back and build that chart for him. It could be a very simple line chart, but as I said, the mutual fund manager may not be that well versed in a traditional BI tool like an SSRS. Okay, so they will be depending on the internal in-house IT team, and that way the overall process will become pretty slow because the IT team will have their own requirement gathering process. They'll have their own software development framework which they'll follow, and probably a very simple activity which would ideally have taken less than 10 seconds to build, right? On paper, line chart is so simple, but then it could easily take 2-3 weeks depending on a lot of factors. So this is exactly where self-service BI comes in. And self-service BI is an approach to data analytics that enables business users to filter, segment, and analyze their data. And this is the key where the key is really to focus on business users, and you can either say business users or you can say end users, customers. So essentially non-technical people who are the real consumers of this particular tool. Okay, and what is the benefit of using this? And if you just compare to the scenario just I discussed just a while back, now here the mutual fund manager can directly use a tool called Power BI, and he can directly connect to the data. He can directly build the line chart all by himself. Okay, so obviously the development cycle will be much faster, and the business user will be happier because he has control of his data, he has control of exactly what he is seeing, and he's not dependent on any external team. Okay, so it's a win-win approach. It's a win-win approach. The end user is happy. The IT team is also happy because sometimes what happens in traditional BI projects, especially if there is a requirement involved, typically in requirement gathering phases, as we have all encountered, right? There are so many iterations that take place, right? You do requirement gathering, you do one phase of requirement gathering, and then something misses, something gets missed, and you come back, you build a product, and the customer is not happy with the product. So you go back and build it again, you iterate over it, right? So those kind of problems can crop up, especially in traditional approaches. But that is something that's completely out of the picture in an SSBI approach, because the business user himself or herself is building the report, and there is no question on dependency, and whatever they want, they are building. So essentially, it's a win-win situation. And as I said, it's a very easy process, and anybody who has basic understanding of data can create reports to build intuitive and shareable dashboards. So when you answer this question, it's very important to give the understanding, give the basic understanding of what are the challenges of traditional BI, what are the challenges of some of the other top BI tools, and where does SSBI fit in? It shouldn't be a very bland answer, just that what is SSBI and that Power BI is an SBI tool, but try to be as broad as possible. Try to give context on where SSBI comes from, why is SSBI important, and what are some of the other tools. Remember, Power BI is a very small part of the whole landscape. The BI landscape is dominated by tools like Tableau, like Spotfire, like ClickSense in the data visualization SSBI landscape. And if you talk about SSBI in analytics, there's also tools like Alteryx, which are really revolutionary. And you can take these examples, and that will really get to show your depth and breadth of knowledge in the entire BI space. Okay, so moving on. Next question, what are the parts of Microsoft Self-Service BI solution? So as I mentioned, the SSBI question in the beginning was purely a very general question. Now we are being more focused on Microsoft stack. So we are focused on the entire Microsoft stack. And obviously, when you talk about the Microsoft stack, we are talking about primarily two toolkits here. So one is obviously the Excel BI toolkit, and the other is the Power BI toolkit. Okay, now some of you might be wondering, why am I using Excel BI toolkit? So if this question is asked to you in the interview, what do you actually say? Do you actually mention Excel BI? Do you mention Power BI? Because obviously we are discussing Power BI, so it's natural we'll be talking about Power BI. But it is also very, very important that you mention Excel BI, because remember, Power BI is nothing but an extension of the Excel add-in components, right? So if any of you have worked in Excel, and I'm assuming all of you have worked in Excel, and I don't mean to say working in Excel in a spreadsheet application. So obviously Excel is a spreadsheet application. We have, all of us have used it. Even if we say that we don't work in Excel, all of us have seen Excel spreadsheets, right? But what I really mean to say is Excel from the standpoint of some of its add-in components, some of its add-in components like the Power BI components of Excel, like Power Query, Power Pivot, Power View. And when you think about these components, what are they? They are actually helping you build BI solutions right within Excel. Now, I know it comes as a surprise for many people initially to believe that Power BI actually came from Excel, but that is the truth. When you think about the origins of Power BI, when you think about how Power BI came into existence, it came into existence from Excel. So whatever you have in Power BI is nothing new, right? So all these components have already been there in Excel for a long time. Okay, so when you think of Power Pivot was actually launched as an add-in. Okay, when you think of Power Query, again, Power Query was launched way back. Power View is again a very, very integral component of Excel. So all these components were already existing in Excel. And all that Power BI Desktop did was it repackaged all these components, which they now call Power BI Desktop. Okay, but it is very important to understand that they were all already there. So the obvious question that I sometimes face from candidates is, why did Power BI build a tool like that? Why did I build a tool like that? If Excel had already had this component, then why not use Excel? And the challenge was that, and this is, I'm sure most of you who have actually worked in these tools would have faced similar challenges, is in Excel you have so many different versions. Especially if you use a 2013, 2010 version, 2016 version, and within each version there are so many different editions. And then the other thing is that these add-in tools are not exactly part of Excel. There are different releases. You have to separately add them. You have to install updates. So all those challenges are there. So if you're migrating, if you're moving from one edition to another edition, the compatibility issues crop up. So all those problems used to happen with this particular stack. In fact, as I told you, and as I'll show you in some of the upcoming discussions, that all these components, the behavior of these components are exactly the same. When you compare the Excel BI components and when you compare the Power BI components, that is the Power BI Desktop components, they are exactly the same. There is no difference at all. Okay, barring a few very, very minute differences, they borrow most of the features, right? However, as I said, the idea of using the Power BI Desktop was to package it in one single solution tool and present it to end users, which is just much neater. It's just much easier to use. And overall, it's just a good solution. It's just a clean solution that Microsoft has built. Okay, so again, coming to the question, it's very important that you mention about Excel BI, because most people will actually go back and say, okay, Microsoft self-service BI to solution will only be Power BI, which is obviously that's Power BI interview. So you'll actually say only Power BI, but actually it's no. So you should mention that it actually came from Excel. And Excel, by the way, is also a very, very powerful self-service BI solution, because remember, even without the Power BI components of Excel, even without these Excel components like Power Query, Power View, or Power Pivot, think of a very, very simple use case where you have a simple spreadsheet application. A business manager has a very, very simple spreadsheet application, and he has some data on an Excel spreadsheet, and all he wants to do is create a very, very simple chart out of it. Can he not use the charts function in Excel? Answer is yes, right? All he will do is he will connect to his Excel data. He can simply create either a pivot table, or he can create a pivot chart, and he can analyze that particular data right within Excel. And I'm not even talking about Power Query, Power Pivot, and Power View. I'm talking about simply creating pivot tables and pivot charts in Excel, which you can do without using any of these components, right? And when I mentioned about that particular use case, what the business manager is actually doing is that business manager is actually performing self-service BI, right? He's performing self-service BI right within Excel. Okay. Moving on, what is Power BI Desktop? Obviously, Power BI Desktop is the free desktop application, and typically this question can sound a very, very generic question, and they just want to test out your overall understanding of the tool that we are obviously going to do much of our development in, which is the Power BI Desktop tool. So it is very important to, a few keywords are very, very important. One is obviously it is a desktop application. One other keyword that I would really like all of you to use is the client tool. It is a client tool. Okay, remember Power BI, the entire architecture of Power BI is a client server architecture, where you have the Power BI Desktop, which is sitting in the middle as a client tool. So Power BI Desktop is where you actually do all your development stuff. Okay, that is where you actually build your reports, you actually build all the cool visuals, you actually build your model right inside Power BI Desktop, and then you publish it onto the cloud, which we call the Power BI service. So remember, it's a client server architecture. So mention those words, mention those keywords, mention those terms. And the other thing that you should also mention is, and again, as I said, when asked a question on what is Power BI Desktop, just focus a bit on the entire architecture generally. Okay, so they may want to know what is a desktop, but if you talk about the service, that just goes to show that you're overall having a pretty good breadth of knowledge. And just give them a picture. Just give them a picture. Don't mention about all the components, but just mention about what is the desktop and the service. At least mention about the desktop and the service generally. Okay. And I think this is also a very, very key part, the second point, where we are saying that Power BI Desktop works cohesively with the Power BI service. And as I mentioned here, just mention the part that this is the client and it's the server, essentially. Okay. What are the Power BI components? And this is again a very, very important question, and it's more of a follow-up to this initial question. So sometimes they might want to ask a more specific question like what is Power BI Desktop? And remember, when I ask this question, you should focus on desktop and the service. But now this is a much more broad-based question where they want to know your detailed knowledge on Power BI. What do you understand about the entire ecosystem of Power BI? And this is what the complete architecture is all about, right? You can see that it consists of Power Query, Power Pivot, Power View. These are obviously the add-in components. Okay, these are the Power components. Then you have Power Map, Data Management Gateway, Power BI Q&A is another revolutionary feature, natural language querying, which I'll just talk about in a while, and finally Power BI Service. Okay, so mainly theoretical. What I would suggest is just give them a picture, just give them the names of these 8 components, and just give them an idea of what each of these components mean. Okay, so if asked a question like this, just focus on Power BI. Again, when asked a question like this, just focus on Power BI. Give a very, very brief description about Power BI. Probably just you can just probably mention Power BI is a self-service BI tool, and it has obviously these are the main components. You have the Power Query, Power Pivot, Power View, and all these 3 are part of Power BI Desktop. So all these 3 you can just club it as part of Power BI Desktop. And then your Power Map, which also is a part of Power BI Desktop. And then finally your Data Catalog, Management Gateway, Power BI Q&A, and Power BI Service, which are obviously the service components. Okay. Obviously, there are a few things which keep changing in the overall ecosystem. So remember, one thing you have to understand in Power BI is that the product is very, very frequently updated. So for instance, the Power BI Desktop gets updated every month. So every month Power BI Desktop, it shoots out the releases every month. And the Power BI Service, which obviously lives on the cloud, that shoots out updates like every week or probably multiple times a week. Okay, the new features getting added every single time. And the reason why I mentioned this is because of the Q&A feature. Remember, Q&A feature for a long time has been on the service. And I just mentioned a while back the Q&A feature is in the service. It is still in the service, but then in the desktop, it has very recently been included as a preview feature. Okay, so when you talk about these things, if you have an understanding of what are the recent updates, what are the recent releases that are coming from the Power BI stack, if you keep yourself updated with what is the January updates, what are the December updates, and if you understand this, the length and breadth of everything that's happening in the Power BI landscape, I think that will just add more value to your responses and the answers to the questions that you give. So just as an example for this particular question, if you're talking about Power BI Q&A, one thing I will recommend is just mention that it's a service component, but also mention that of late Power BI has included that as part of the Power BI desktop. Okay, so now you can actually go to Power BI desktop and you can shoot Q&A features directly from there. And I know I haven't talked a lot about this yet, but I'll just quickly connect to my data here in Power BI. And as you can see, I'm just connect. This is my Power BI desktop interface that I've opened. Okay, and I can very easily connect to my Excel file. See how easy it is to connect to an Excel file here from Power BI desktop directly. And I will very easily connect to my Excel file from here. I'll just load this data. And now you get a very simple interface from where I can choose the sheet names. So this is an Excel workbook where I have 3 worksheets: orders, people, and returns. I'll select the order sheet. Okay, the edit is basically for opening up the query editor. If you click on edit, it will open up the query editor where you can edit your queries. Okay, and this is basically what you're going to get. You're going to get data in your Power Pivot model, and now you can go back and visualize your data. Okay, so if I want to, so remember the example of that fund manager, where the fund manager wants to see how much profit he has got based on every day. You can see how easily, just with 3 clicks, he can generate a very, very nice line chart. Okay, and you can see how easily we can build dashboards in Power BI. Okay, and how powerful it is as a self-service BI tool. Okay, and just to come back to the question on Q&A feature, and by the way, the preview features are turned on in Power BI desktop in this particular thing. You can go to File, Options and Settings, go to Options, and you can see all the preview features will be listed out here. Go to Preview Features, and you can see all the preview features listed out here. You can see I've turned on all the features except Spanish because I don't know Spanish, so I can't turn this on, right? All right. So these are all the preview features, and if you just double click on it, see something called Q&A is listed out here, and you can just double click on this particular thing, and you should be able to see that a very, very familiar Q&A feature which comes up in the service. That exact same thing is now built into the desktop. Okay, and I will talk more about the service later on, guys, but just to bring this up as an answer to this question, I just wanted to quickly cover this with all of you. So you can just double click on this and you can ask questions. You can ask some question like, sales by region. Pretty cool, huh? I'm just typing it, and if I want to see it as a pie chart, I can just say as a pie chart. Okay, so just by typing, I can see exactly what I want to look at, and it gives you some suggestions. It's more of a gives you some suggestions here as and when you type the values, and you can see if I look at a matrix, want to see this as a different kind of visual, let's say as a table. It gives me all these options. Okay, so that's the Q&A feature that is built right inside the Power BI desktop as a preview feature. And when you answer this question, the other important thing that I do want to mention here is just giving a brief description about all these components. Remember, guys, Power Query is the ETL component of Power BI desktop. So that's an ETL component. So the idea in Power Query is you're taking your data, you're connecting to various sources, and you're performing a very, very basic ETL operation there inside Power Query, right? So the idea is to just perform basic data cleansing operations, because remember, data from the source is never in the right shape. It's never in the right format, okay? It's what we call dirty data. So data from the source is always dirty. So you want to always clean it, okay? You want to always clean it. You want to perform some basic transformations before you use it for your actual analysis, okay? So that is the very, very first step in Power Query. Okay, so if you remember, what I've done as the very first step in Power BI is I connected to my Excel file, right? And typically, the way to open up Query Editor is either you can click on Edit Queries here, or you could have clicked on Edit in that particular dialog box I got just a while back. You could have directly clicked on Edit there. Okay, so click on Edit Queries here, and once you do that, it will open up the Query Editor where you can go ahead and edit your query. Okay, you can go ahead and perform basic ETL operations. Obviously, there's a lot that is here. We're not going to cover everything, but at a basic level, this is just for you to understand. Just to give you some context as to what this interface is all about. Okay, and just a simple example, you can probably give some simple examples here where, let's say you want to you're looking at the orders table and you don't want to look at all this data, so you were removing some columns. Let's say here you're going to go and remove all these columns. You don't need all these columns, so you want to remove the ship date. So you don't care about ship date, you don't care about customer ID. And see, whenever I perform any kind of operation here, whether it's a remove column or if I do an add column, just here I can also go back and do an add column. So I can actually just come back here and I can add a column. I can add a custom column. It's just like adding a calculated column. Okay, so I can add a column called cost, and cost is going to be equal to sales minus profit. Okay, and that gets added as a calculated column, and that again gets added as a step. So everything in a query is basically a step. Okay, so mention these keywords that you build queries, query editor, and behind the scenes you're creating steps. So mention these pieces when you're talking about this particular answer, and also mention data types. Very, very important part, setting data types properly. Okay, you can see what's happening here is when I build that particular column called cost, so this becomes loosely typed. It's not exactly in the correctly typed format. Okay, ABC123 basically means that it's not properly typed. So you have to go back and specifically set the type to decimal number. Okay, these are all the data types that are available in Power BI Desktop. And so that's it. That's all I have. And what I will do now is, once I'm happy with whatever changes I've done, let's say I've performed all my data cleansing and data transformation activities, I can go back and close and apply. And once I do that, what will happen is data will get loaded into my Power Pivot data model. You can see what happens here. It is going to get loaded into my Power Pivot data model. Okay, so the first step is Power Query, where you will perform the ETL, and the next step is from Power Query, the data goes to Power Pivot. And Power Pivot is nothing but an in-memory columnar database where your data gets loaded. Okay, that's your data model. In other words, we call it a data model. So the idea is that you perform your ETL, you clean your data, and then you load your data into the Power Pivot model. Okay, and from there, you're going to visualize your data using Power View. Okay, that's the very, very basic process that we have in the Power BI desktop. The same as we have in Excel. Okay, even if you use the Excel BI components, it'll pretty much be the same thing. And just to give you a brief glimpse of that, I'll not talk a lot about it. I've opened up my Excel. Remember, I have opened up my Excel, but I also have the add-in components loaded. So I'm using 2016 version of Excel, by the way. So it's very, very easy to do the same thing in Excel as well. So you can go to get data, you can go to file. You can see the interface is very similar to what you have in Power BI desktop, which is why I actually drawn those parallels in the beginning of our discussion where I said that both these components draw so much from each other. Okay, I'll connect with that same Excel file here. Click on import. It's connecting. I'll get the same interface where I can connect to that particular worksheet from that workbook. It is still establishing a connection. See the same interface, a very, very similar kind of interface opens up just a while back what we saw in Power BI desktop. It is taking a bit of time to load. And the idea is that the idea behind showing you this thing is just so that you're mentioning these things when you're asked this question, so that you get an idea that, okay, the same thing you can do in Excel as well, what you can do in Power BI desktop. I'll just quickly go ahead and expand it. I'll select my orders table from here, and you can see the very, very similar options are coming up: load, edit. It'll open up the query editor very similarly how it opened up in my Power BI desktop. Okay, so you can processing my queries. The concept of queries is very similar to what we saw in the desktop, and you can see it's opening up the query editor. And again, here you can see that the interface is very, very similar to what we saw in Power BI desktop. Remember, it's very easy to confuse that I'm actually opening up Excel, but this is actually Excel. It's not Power BI desktop. Okay, so I can do the same stuff I performed just a while back in Power BI desktop. I can go back and remove my columns. I can remove my order date, a row ID. See the steps are getting added. I can add the custom column. Go to add column, custom column. I can do pretty much the same stuff here. Okay, I can add that cost column, which is going to be sales minus profit. Click on OK, custom column added, and now we can go back to home and say close and load to. Okay, and when you're closing and loading, essentially what happens is you're loading that whole stuff into your model. Okay, and which is nothing but the Power Pivot. All right, so it's very, very important that you have this understanding that Power BI desktop is not to be learned in isolation. It's not to be learned in isolation, but you should have an appreciation of the fact that behind the scenes is nothing but Excel in action. Okay, so whenever you're asked any kind of questions on the entire architecture of Power BI or the components of Power BI, it is very, very important that you link it to Excel and you give them a very, very concise and holistic answer of what you can do in Power BI desktop and what you can do in Excel and how similar they are overall. Okay, so that's about Power Query, Power View, Power Pivot, and Power Map. Power Map is another add-in component in Excel, and essentially Power Maps are leveraged pretty much the same way within Power BI desktop as well, using the very, very powerful mapping feature here that you have. Okay, you can build some very, very cool maps directly from the Power BI desktop. Okay, and essentially you can do some pretty cool stuff in the Power Maps feature as well that you have within the Excel add-ins. Okay. We have data catalog. Data catalog is basically Azure data catalog, so it's pretty helpful for connecting to different sources, management of different sources. You have data management gateway, which is used for connecting to on-premises data. Another very, very essential component with something that you set up in the service level. So if you go to the Power BI service, basically, so whatever you see I have right now is what I call the Power BI service. So remember, guys, I talked about this in the initial session, beginning of the session, where I said, this is my client development tool. Okay, this is Power BI desktop. It's a client development tool. This is where I build my stuff. And after I build my stuff, I publish it onto what I call the service. And just to give you a quick demonstration of that, just to give you a very, very quick demonstration of that, I'll build a very, very simple line chart here. And I'll just go ahead and name this as, I'll just give it a name. Okay, probably I'll go ahead and name it as demo. I'll save it and call it demo. That's my demo Power BI report. Remember, Power BI reports get saved with the file name extension of PBIX. That's another very important interview question. They tend to ask you what are the different extension types, and it's not only with Power BI files. They actually something called template files also, which I call Power BI template file. This PBIT. Remember, these two types of extensions. PBIX stands for the Power BI file, that is the Power BI analysis file, and PBIT, which stands for the Power BI template file. Okay, so I'll save it with the name demo. Click on save. Remember, for publishing, it is very important that you're signed in. And once you're signed in, once everything else is set up, you can just go back and save it in your workspace. And once you've done that, you can just go to the service and check that your stuff has been published. Okay, like something very similar will be visible on your service, and you can look at the report section where you can see that has been published. This respective report has been published. And remember, this is the cloud environment. Okay, so this is my development tool. That's my development environment. That's my client. and this is the cloud environment, which is my server. Okay, I published my stuff here, and now all my end users can view my reports and dashboards from here. Okay, so from here I can further create what I call dashboards, and then I can go to my dashboard and say share my dashboard. I can go to share, and then I'll mention with whom all I want to share my dashboard and give the email IDs of all the folks I want to share my dashboards with. One very important thing to remember that in Power BI, you can only share stuff with everyone in your organization. So for instance, if you look at this link, this is where you can simply go ahead and specifically give access to who all you want to share it with. Just start typing the email addresses that you want to send them, and automatically they'll receive email notifications, or they will basically get notifications on their Power BI service interface, which is basically the tab here. It's a notifications tab that you basically have here. Okay, so very easy, very simple, very intuitive process overall, and just mention these pieces when you're talking about it. And again, it just goes to show the overall depth of knowledge that you have in the tool if you mention all these different components taken together while you answer these questions. Okay, what are the sources that Power BI can connect to? Actually, there is infinite. Okay, so ideally there are a lot of sources Power BI can connect to. If you go to get data, this is only from the desktop. Okay, from the desktop it can connect to a wide range of sources. So you can go to more, you can just take a look at the available sources that Power BI can connect to. We saw an example with Excel, but you can connect to files, XML, JSON, databases, ton of databases that you have. Okay, and if you don't see anything here, you can obviously set up an ODBC connection. Very easy to set up an ODBC connection also. And online services, this list just keeps growing. Azure services, and it's pretty cool list of services and sources you can connect to. Okay, another very interesting option is web data. Just to give an example on this, you can very easily connect to web data, and I'll take an example of money control. Okay, probably we can go online and I'll search for the website money control. Okay, and this is again to highlight to you how easy it is to connect to web data in Power BI. Okay, so typically it might involve writing a lot of scripts. If you just want to quickly connect to a website and take some Tableau data from there, so you can skip all the scripting, all that stuff, and just connect to the data generally. Okay, so I'll go ahead and copy that link and paste it. Click on OK. And once you do that, it will try to establish a connection with money control. It does take a bit of time initially to set this up. And once it does, what it will do is it will go to the website and it will try to look at the website, and remember everything's underlying based on HTML. It will try to search for tables, anything which is structured as a table. It will try to search for that kind of data. And once it finds it, will present to you a list of all those available tables. Okay. So I'm going to go ahead and just type this in once again. So the idea is it does take some time depending on the connection that you have. So I think the site is not working that well right now. So what it's doing is establishing a live connection with that site at this moment. And it'll ideally typically present to you a list of all the tables, tabular structures that you have. And you can see it takes a bit of time to connect to the site. And as you can see, finally, my list has come up. The initial case, there was some issue with the connection, so we were not getting all the tables. And as you can see, very nicely, it will present to me all the tables. So it basically looks at that entire website and will scrape that entire website for any HTML structures that it finds. And you can see very nicely, I get this bonds here. And what is this bonds? If I have to quickly go back and show you in money control, I've actually closed that website here. If I just have to show you quickly what that bonds is. So there's a section in that website where I have something very similar to this. And you can see how easily I'm able to get a very nice tabular format out of all this. You can go to web view where you get that website kind of view, or you can directly select your data from here. You can just click on bonds and you can just go ahead and load this table directly into your website, into your Power BI desktop file. Okay. It is loading. It further takes some time because remember, it is taking the data straight from your website. So it does take a bit of time. Just my money control site is opened up here. And if you just go down, you can just take a look at this whole piece here. That's the bond section that got loaded. Okay. So very easy, nicely, you can see these are tabular structures, the indexes, global markets. Okay. You have a section on bonds, you have a section on currencies, and Power BI, when it looks at that web data, it is able to very easily scrape through that data. It's very easily able to select that data from here because at the underlying layer, these are all HTML tables. Okay, so mention some of those examples when you talk about this particular question of what it can connect to. It can connect to a wide variety of sources, and that is only in the desktop. If you talk about the service, you can go to get data into service. Okay, and you have a further lots of services you can connect to from here. So just as an example, you can choose content packs. You can obviously connect on to content packs, which are nothing but pre-built and pre-packaged dashboards, we like to call it. Okay. In other words, another name for content packs is what we call apps. So nowadays, apps are a replacement for content packs. You can think of it, and they're nothing but pre-packaged. It's like packaged dashboards, like packages. Okay. Where you have already built a dashboard, where you have already built in the reports, the data sets, the dashboards, the model, everything, and the end users just consuming it. As an example, what I really like to show you here is something with Bitcoin. Okay, so something with Bing Maps as an example. So let's look at Bing Maps. Let's see if I can find Bing Maps here. Yeah, I have Bing Maps here. So what I can do is I can just get it now. It is just like installing an app from Google Play Store or just installing an app. Okay. And you can see what I'm trying to do is I'm trying to consume that app. Okay, it's like a pre-packaged stuff. All the data sets, everything is built in, and I have to enter a parameter. So Microsoft is asking me for a parameter. So I'll just type in Bitcoin just to see what is the search activity in Bitcoin. And just for those of you who don't know, Bing is a search engine by Microsoft. Okay, it's a search engine just like Google. Click on add, and you can see automatically that dashboard got added. I didn't create it, but that is something that got automatically created. Okay, and that's the reason why I say these are content packs, which are nothing but pre-packaged dashboards which are already built in. And now we can actually see that how people are searching, from where people are searching the most. And obviously US people are searching for Bitcoin the most. Okay, see some news mentioned here. Okay, and top languages. Interestingly, German and French are also pretty high. Okay, see the change, week over week change, how many more people are viewing, and you also get a pretty good line chart here where it actually shows you the activity. Okay, the activity is the last week, and pretty interesting. I mean, on this particular day, there was a big spike. You can see that 24,037 people actually searched for it. And slowly, gradually, people have lost interest. It seems like, okay, not many people are actually viewing it now. So anyways, the idea is to just highlight that there is something called content packs. And remember, there are two places where you can connect to data. One is from the desktop, and the other is from the service. Okay, from the service also, you get a very robust set of options to connect to data, where you not only can connect to files, databases, you can connect to files from here, OneDrive, local files, you connect to databases, Azure databases, and you can also connect onto services. And further, you can also connect onto your organizational content packs. If you're working for an organization, and you can also connect onto any organizational content packs that people in your organization have developed. Okay, so services are basically content packs from online services, typical online services like Bing, Salesforce, and all that. Okay, but then organization is only specific to your organization. So mention this piece as well when you talk about the sources you can connect to. What are the building blocks of Power BI? I believe this is something I've already talked quite a lot about, but when you ask this question, again, as I said, give a very, very broad-based view of the building blocks. And I think I'll really appreciate if you're answering this question as an interviewer. Definitely, they'll appreciate it if you're giving them a holistic view of the entire architecture, right? So talk about Power Query, talk a little bit about Excel, talk about those main components, which we call Power Query, Power Pivot, and Power View. Talk about those components, and then come to the building blocks. The building blocks obviously are the datasets, the visualizations, the dashboards, the tiles, which are some of the most fundamental things that you have in Power BI. Just to give you a brief context about what this stuff is. So when you build your stuff in Power BI desktop, obviously you're working with three main tabs primarily. That is obviously the query editor is where you did your ETL, you loaded your data into the model, and then you come to the data tab. Data tab is where you can actually view your model tables. Okay, so right now I have only two tables. One is the orders table and one is the bonds table. So you can actually view your tables over at the data tab. The relationships tab is again where you can quickly take a look at your underlying table relationships. And finally, the reports tab is where you can take a look at your reports, whatever reports you're building. Okay. And once you publish this stuff, then you come to the service. And the service, you basically have datasets, obviously the underlying model and data along with that, which you've exported out or published to the service. That's your datasets, the reports folder. And from the reports, you build dashboards, those dashboards folder. And also have a component called workbooks, which you can mention. And in dashboards, you further have what we call tiles. Okay, these are called tiles in a dashboard. Okay, as you can see, these are all tiles. Okay, so for instance, here I have created only a single line chart, right? If you look at this particular thing that I published, I created only a single line chart. Now I can opt to add one more visual to my report. So what I can do is I can look at my report here. And another beautiful thing about the service, and again, something that all of you can mention here, is the editing capabilities in the service that Power BI gives you. So you can edit a report straight within the service. So the amazing feature where you get a very, very desktop-like interface right within the service. Remember, however, when you mention this part, do mention that you can't build models and you can't do query editing within the service. You can only edit reports. Okay, so you can only edit reports and you can only work on the visualization layer within the service, right? And here I can opt to build a bar chart where I can look at sales in category wise. Let's say I want to stack this by segment, and I can do that. And you can see how automatically Power BI is able to fit these things into the respective components. And again, it just goes to show the SSBI capabilities, the self-service BI capabilities of Power BI. So if a novice user, if a business user is working on it and they have absolutely no clue, what to put, where to put which component, they can simply click on the fields and Power BI will automatically put them in the respective sections. Okay, this again goes to show the self-service capabilities of Power BI. And I can create multiple pages, of course. Okay, I can create another page where I can build a simple tree map here where I'm showing the category, subcategory, and I'm showing the profits now. And I can build a very simple tree map here. And if I want to saturate it with colors, I can further add some color saturations. Okay, I can further add some color saturation. Let's say I want to saturate this by sales. I can further saturate this by colors. Okay, and now I can go back and remember this the report that I've edited. So I need to go back and save it. So I need to go back and save this report. And once I do that, it will be directly saved within the service itself. Okay, it will be saved in the service itself. Now, one of the questions that people might ask you at times is they might ask you that so now that I've edited the report in the service, can I go ahead and download the report? And answer is absolutely yes. And again, remember, it's a preview feature. Previously, this was not there. This feature got included after a lot of requests by users. It was a major roadblock generally in the development process, but it's a very, very useful option that you have here. And now that you have saved the report, you can actually go ahead and download a copy of the report in your local machine. Okay, very useful feature. You can download it here. You can also export this to PowerPoint preview. Another very useful feature that you have in the service. You can actually export it to a PowerPoint. Okay, so remember, it won't be as interactive. It won't be an interactive presentation, obviously, but you'll still get a pretty cool view of, an introductory page will be created and the visuals will be there. So it's a pretty decent kind of interface that you will get. Okay, so that's another feature that you actually get in the service. And once you build that report, you can go back and obviously pin that to your existing dashboard. So my dashboard is going to be demo dashboard, which I built. And now in my existing dashboard of demo, if you remember, I now have two visuals. Okay, it says Power BI is ready to download. And now you can see these are the tiles that I have basically. Okay, so hope you all followed this particular discussion where I talked about what are the building blocks in Power BI. Obviously, you'll mention a bit about the components, and then you will talk a little bit about what are the primary building blocks, which are obviously datasets, visuals, reports, dashboards, and tiles. Okay, datasets, visuals. Using visuals, you create reports. Using reports, you create dashboards. And basically, using dashboards, essentially the tiles are part of the dashboards. Using reports, you basically create tiles, and using tiles, you create dashboards. Okay, what are the different types of filters in Power BI reports? Visual filters, page level filters, report level filters, and drill through filters. Now, the very, very important question. So typically, the way to answer this question is to go back and take scenarios. Now, what are the scenarios where you will implement each type of filter? So visual level filters obviously is present only at the visual level. So it is only, you can think of it like a report level filter. It's present only in a particular type of report, a particular type of chart. Okay, so when you come back here and come back to the desktop, and if you take a look at it, you will see that line chart that I built here. Go to the filters panel and you can see all the visual level filters are applied by default. Okay, and these are going to be by default all the fields that are already a part of the report. Okay, so these are, so if you place now the chart here, if you place a bar chart here, for instance, so whatever you do in that line chart will not affect that bar chart. Okay, so if I take a bar chart here and I say region wise sales, and now if I go ahead and filter that region, so remember, if I click on the region filter here, I will have a region filter here for the bar chart. And if I go ahead and change that region filter to central, it will not affect the line chart because, as I said, it's a visual level filter. So visual level filters are, in short, they are specific only to the visual. Then I have page level filters. I can go back and drag and drop that region now in the page level filters. And now if I go back and change central, if I filter into central, both will be affected. Okay, make it east, both will be affected. Okay, so that's why we call it a page level filter. All the reports within the same page will be filtered. Okay, then I can have something, but remember, if I have a report on a different page, it will not be filtered. So in a different page, if I go back and place region and sales, see how it will not be filtered. Okay, so although I'm filtering by central and east here, in the page 2, I'm not filtering by central and east because that's a page level filter. Okay, finally, if you want to implement that, you can implement something called a report level filter. Okay, I can remove the page level filter and then I can take the region in the report level filter, which means that all the pages in that report will basically have that filter. And here I can go back and include central and west and see in the first page, obviously it will be filtered, but because the report level filter, if you go to the second page also, you will see that in this particular section, it will be highlighted. Okay, it will also be filtered here, and report level filter will appear in this page also. If I click the third page, it will be here. Fourth page, it will be here. So that is what we call a report level filter. Okay, and finally, we call it a drill through feature, which you can use the drill through filter to basically work on drill through reports. So what you can do is, let's say you have a scenario where you have categories. So instead of region, let's say if I have categories here, and I can build another use case in page 2. Let's say I have a scenario where I have subcategories. Okay, so here I'm having subcategories and categories, of course. Let's say I have categories, subcategories, and I'm looking at category and subcategory by sales. Okay, very simple report type I'm looking at. It's a detailed view I'm looking at. So I can configure a drill through filter. So the idea is that if I right click on a particular category, I should be able to see subcategories of only that particular category. So in that particular case, I can go back and configure drill through filter. Okay. And again, you can mention where, let's say, the use case could be that if I want to click on a particular report, I want to navigate to another page, and I want to see subcategories in that particular page. Those are scenarios where you will basically go ahead and configure filter reports. Well, one other thing that I must mention to all of you here is there'll be certain use cases, there'll be certain scenarios where people will, I did mention the clause drill through reports, remember? Okay, just to quickly mention how, again, but just to clarify how you configure it, remember, one thing you must remember is the filter is something that you don't place here. Okay, the filter should always be placed in the page where you're configuring it. So if you're configuring this page, the category filter should be placed here. Okay, remember I'm filtering by category, right? What am I trying to do? I'll click on a category here, and based on that, I'll select a subcategory here. So the idea is that you're going to filter on the category in this particular page. So you should always place category in the drill through section in this particular page. And now when you go to page 1, and if you right click on that technology, you will see an option for drill through. Okay, you will see an option for drill through to page 2. And when you do that, you will see only technology getting filtered. And once that happens, you will automatically see that in the drill through filter section, category technology is automatically filtered. Remember guys, it's a very recent inclusion. It's not exactly again, drill through filters typically was not part of the filters panel even a few months back. Okay, this again came very recently, and it's again a very new feature, but it's always a very useful feature, because drill through reports is something that if you have worked across other tools, enterprise reporting tools, it's a very common feature where you click on a particular item and you want to go to another page where you're filtered with that particular item. Okay, and this is a very useful case, right? It's a very useful scenario where it enables you to do that, right? So you can not only configure stuff in one page, but you can actually configure stuff in another page. Another very common scenario, another very common use case for this could be that there could be initial introduction page, right? The initial introduction page could be like, you're showing the categories, right? You're showing all category related information. So you're showing technology, and you're basically showing all the categories, right? The categories are furniture, office supplies, technology. So everything about the categories you're showing. And then your page 2, and the page 2 will actually consist of everything about the subcategories, right? It is the subcategory page. It is a subcategory page for the category that you have selected. And page 3 could be the product page for the product that you have selected from that subcategory, essentially from the subcategory that you've selected. Okay, so I can further build another page. And guys, remember, this need not be a table. Okay, this could be anything else. This could also, and by the way, you don't need to have category also. This could be anything else. This could even be a bar chart. Okay, I'm just giving a table as an example, but this could be any kind of visual. It could be one visual, it could be multiple visuals. You could also have a pie chart here. Okay, I can do a Control C, Control V. I can build a pie chart here, and you could build any kind of visual. But remember, the concept is that whatever subcategories you see, so I'll call this a subcategory page, and that is basically my initial category page. And I can further build one more page called the product page. And the product page is where I'll probably have some detailed information, or probably I can build a bar chart here also, where I'll get my product IDs, or my product names in the values axis, the sales. Probably go back and sort this data, sort by sales. So I'm showing my highest sales up on top. Okay, and here I'm going to go ahead and sort this information by subcategory. So I can go back and sort this by subcategory. So what I'll do is I'll take the subcategory and put it in the drill through filters here. Okay, so now remember, category, this page I have no filters, so because that's my main page, there's nothing should be applied. Everything about my categories. And the subcategory page where I have everything about my subcategory. Here obviously I've selected a category, so that is filtered out. But then further I can go back and select my product from here. Okay, so the idea is that you will navigate from here. So you want to go to drill through, you want to go to subcategory. Okay, so I'm looking at a particular category. I want to know more about that category. So go to subcategory, show me more about furniture. Now whatever you're seeing right now is about furniture, right? You're seeing all the all the top subcategories in furniture. You're seeing all the top subcategories in furniture. Now, okay, interestingly, you see furnishings is not done that well. Okay, so furnishings is kind of a laggard. You want to see what's happening in furnishings. So you want to click on that, and now you want to go to drill through in product. You want to see all the products of that particular subcategory, and that's how you get to see all the products of that particular subcategory. Okay, so that's the idea of drill through filters. Again, it's a very important concept, very powerful feature in Power BI, and it's very important that you mention that. Okay, so those are the main types of filters that you have in Power BI desktop. Content packs and apps, I think I covered that already, so just skip through that right now. DAX, very important part, guys, and obviously DAX is a functional language, very important piece in the overall Power BI desktop stack. Remember, in Power BI, whenever you talk about Power BI, and something that you guys will anyways mention when you talk about the components, obviously you guys talked about Power Query. There was an instance where I actually wrote a custom column. I actually added a custom column a while back. Okay, remember that cost column I added where I write a very simple expression called sales minus profit. So the language behind the scenes that's being written is called M code. Okay, so this is called M code. So Power Query is equivalent to M, whereas Power Pivot is equivalent to DAX. Okay, the underlying language that you use in Power Pivot is DAX, whereas the underlying language that you write in Power Query is essentially called M. And just to give you a very brief flavor of M, what it is, and if you go to edit queries here, remember all these queries are nothing but a combination of steps. And if you want to look at just a brief idea of what is M, go to View, go to Advanced Editor, and you can take a look at the M query syntax here. Okay, that's the M query syntax that gets highlighted for you here. So remember, this is existing in query editor, whereas Power Pivot is something, DAX is something that exists in Power Pivot. So where do you see DAX? You can go to the modeling tab, or you can just enter the modeling from here. You can go to new column, and you can just start typing in your DAX queries here. Okay, we'll look at more about some of these examples just in a bit, but this is where you actually start typing in DAX. Okay, at a very simple level, I can say sum of sales. I'm creating a very simple calculated column here, and that is how you basically build DAX queries. Okay, I'll go back and just delete it. So very important, guys, when you asked about DAX, it could be a very generic question, but it's very important just to not be theoretical. It's very important that you mention a couple of things like it's a functional language and give some examples of how DAX is related to stuff that you can do in the Power Pivot, that is in the data model. And essentially it helps you add more meaning to your data, because your underlying data could be in a certain format, but there are certain kinds of calculations, a certain kind of complex measures that you want to add, which could only be done in the Power Pivot layer and nowhere else. Okay, and we'll look at some examples of this just in a bit, of certain things that you can do only in the Power Pivot layer and nowhere else. You can't do that stuff in the ETL layer. Okay, might sound surprising, but I'll just show you some examples of why that is the case. Okay, these are some of the common DAX functions, and again this kind of goes hand in hand with the ninth question. So when you're asked about DAX, just mention some of the functions. Again, this goes to show the length and breadth of your overall knowledge of DAX, because any kind of job interviews on Power BI, DAX is an integral component, because people expect you to be good in DAX, right? Because it's not all about the visualization layer. It's not all about point and click on a visual, you get a visual, knowing the underlying features, which is fine, but people do expect you to understand the DAX queries very well. And not only DAX, even at some level the M query language also you need to be good at least have a basic understanding, so that if there are errors, you want to do some debugging, at least you're able to pinpoint on those issues. Okay, filter function, it goes hand in hand with calculate basically, and this is again a very important component in Power BI desktop, and something that you will use a lot. And whether you know any other function or not, this is one function that you have to know and have to understand. Okay, and calculate function basically operates in the filter context. I'll just briefly explain to you what this is and what are some of the use cases behind using it. So what I will do here is I'll create a very simple table. So what I have here is an example where, let's say I have year. Okay, so I have year information. I'll take order date and I'll take sales information. Okay, so I'm seeing a bar chart. I'll convert this to a table, and right now what you're seeing is a very nice tabular information. Right now, what I want to know is a percentage. Okay, so let's say the scenario is that I need to know. Okay, right now what I'm seeing is the total sales across the total absolute value of sales, right? But what if I want to quickly figure out the percentage of the total? So for instance, right now you're looking at quarter wise, or maybe another good example will be taking subcategory. Instead of taking order, let's take subcategory. Okay, so right now what you're seeing is sales across different subcategories. But what if you want to know what is the total percentage of paper sales compared to the total? So right now you're seeing absolute values. How do you convert it to a percentage? And the way to do that is using a calculate function. Okay, so you can't just divide this by total. So I mean, conceptually it's very easy, right? So you'll take this number, you will divide by this. So you will take 107532, you will divide by this. Okay, just to expand it, go to the focus mode. Now I hope you can see the numbers correctly now. So 203412.73 divided by 2297. So you're dividing each of the row values by the total at every step of the process, right? To calculate the percentage. Okay, and that is something you can do using the calculate function. You have to build a DAX calculated column here. Okay, there are some lot of cool ways of doing it, and again there are some pretty cool ways of doing it manually without creating DAX. So you can go to show value as, and you can actually say percent of grand total. So this is the easy way of building it. But remember, even when you're doing this behind the scenes, Power BI is implementing the DAX for you. Okay, there is also another revolutionary feature called measures. So again, there are some lot of new things that you have in Power BI. There's something called quick measures that you can also implement. But again, remember, whenever you're doing any of this stuff behind the scenes, you are implementing DAX. Okay, you have some new quick measures. If I go to new quick measures, I will see a ton of stuff that I can build in Power BI. Okay, you can just take a look at this now, and you can see a ton of stuff that you can do here. Okay, and again, there are a lot of these things tend to be added from time to time. New things tend to be released. You can see time intelligence calculations, totals, running totals, star rating. Really cool thing, star rating. It's an amazing feature. So you can actually give a star rating, highest value. Let's say my highest value is going to be something like 250,000. I'll probably say. Okay, that's my highest value. That's my lowest value. I can give the number of stars, and I can enter a new quick measure called star rating. Okay, and now you can see behind the scenes, I've actually got DAX. So whatever you're seeing here right now is actually a pretty complicated version of DAX. Okay, so whenever you create quick measures or any of these default point and click options, behind the scenes, Power BI is actually building that DAX for you. Okay, this is actually a pretty complicated bit of DAX that's written, and the final output is actually pretty neat. Okay, you can see that that's my star rating column I've created, and you can see that as a top value, 5 stars here, 4 stars here, 1 star here. It's pretty relative depending on the type of data, and the best part is that it is actually going to be dynamic. And what do I mean by dynamic? What I mean by dynamic is that this value will change depending on the underlying data. So essentially, if you take subcategory and if you further try to break it by region, that data will actually change. So now your stars will actually adjust based on the underlying granularity of your data. Okay, and now you can see nothing is now a 5-star. Everything's like 2 stars, 3 stars, because the maximum that you mentioned is no one's reaching that other than the total, obviously. Okay, so what I wanted to highlight again is that behind the scenes, although you can solve this particular problem in a very, very simple manner, but behind the scenes, Power BI will always write a DAX for you. So coming back to the underlying question once again, so I'm looking at my individual sales values and I want to calculate the percentage of it. So if I want to write a DAX formula for this, the way to write it would be to go back and implement it manually using the calculated column option. And I'll quickly go ahead and open up my wizard and fire in a quick bit of DAX here. So how do I do that? I'll go to the modeling tab and I'll go to new column, click on new column, because that is actually going to be a new measure. That's going to be a new measure. And I'll just in one of the upcoming questions, I'll talk a little bit about what is a measure and what is a column. Okay, this is a very, very important difference, by the way, between the two. So here is going to be a measure I'll create, and the measure is going to be called, let's say, sales percentage. I'm going to call it sales percentage, and let me quickly type in the measure. I'm going to take the sum of sales and I'm going to divide it by what? I'm going to divide it by the calculate of the sum of sales. I'm going to divide it by the calculate of the sum of sales. And here I'm going to apply what I call the filter context. Okay, and this is the important part. This is the key part. And okay, so whenever you use the calculate basically has 2 arguments, and as you would have observed, whenever you start typing any kind of function in DAX, it has a pretty nice kind of auto completion or a help suggestion wizard that comes up. It tells you that, hey, what are the arguments that I need to enter in calculate? And it very clearly tells me that the arguments I need to enter is the expression. The expression is the stuff I want to calculate, which is obviously going to be sum of sales. That is what I want to calculate. Sum of sales is the underlying expression. And then I have to give the filter context. Okay, you have to give the filter. Okay, evaluates an expression in a context modified by the filter. And this is the important part. So remember, when I am performing this operation, I should ideally not have any filters, right? Conceptually think about it. When I'm performing this operation, ideally I should not have any filters. And that's exactly what you're going to set here in this particular example. So you're going to set this up in such a way that you don't have any filters. Let me go ahead and quickly set this up now. So what I'm going to do is I'm going to go ahead and give all. So when I say all, I'm specifically telling Power BI that, hey, no matter what filter context is applied on that particular row, you're ignoring everything. Okay, and I'm going to take all of orders. Okay, I'm going to consider all of orders, and I'm just going to go ahead and close my parentheses here. Okay, I missed closing the brackets here. Let me go ahead and quickly edit the syntax. And whenever you make an incorrect syntax, what happens is it will give you this red squigglies, which will highlight that, okay, so the syntax is not right. As you can see, that's my DAX formula right now. And just to clarify once again, calculate, the way we are using calculate is we're calculating sum of sales as the first argument, and we are calculating sum of sales based on the filter context of all orders. Okay, that is where you'll mention the filter context. So you're saying that I will calculate the total sales irrespective of the filters applied. So I'm taking all of orders. So you're dividing individual rows by the total. That is the underlying meaning of this. Okay, and I can actually go ahead and multiply that with 100 just to add clarity on this whole formula. So because it's a percentage, so I'll just multiply that by 100 overall. And now I can go ahead and add that piece of code right into my table and see the results. Okay, as you can see, I was very easily able to achieve that using a very, very simple piece of DAX code involving calculate. Okay, so this is just one use case of how you use calculate. Very, very important DAX formula, calculate and filters, and something that gets asked all the time in interviews. Okay, and the best part about this is it's dynamic. So see how I've used subcategory here. If you want to use something else, let's say you want to use a region, you can do that as well. So I'll take a region, I'll remove the subcategory and see how that entire formula adjusts automatically depending on the kind of calculation you're using. Okay, the kind of grouping that you're doing. And you can see the region percentages are highlighted. Everything adds up to 100% and it comes up pretty nicely overall. Okay, if you don't like region, if you want to further split it by segment, you can go ahead and split it further by segment and see how again the entire calculation gets dynamically adjusted. Okay, and this is again the beauty of measures. Okay, this is again the beauty of measures, which the very fact that measures are dynamic in nature. It is dynamic in nature and it will basically adjust every time you change anything in the visuals, change anything, filter anything, your measures will always recalculate. Okay, and measures are always created with a small calculator icon. Okay, what are the benefits of using variables in DAX? Variables in DAX are no different from variables in any other programming language. Obviously, DAX is another kind of functional language. So variables, one of the most important use cases is that it can be reused multiple times so as to avoid any kind of duplication or redundancy in your overall code, right? There are some other examples that we have on, you can specify what are some of the time intelligence functions. Again, calculate is something that you can use for this. So we talked about calculate, all, and filter, and you can obviously use them in multiple ways to go ahead and create n number of different use cases. Okay, this is one use case I mentioned, but you can obviously use calculate to create trailing X month metrics via DAX. Okay, it's a non-standard calendar, for instance. Okay, and you can see what we are doing here as a second step is we are using all again to remove existing filters. Okay, remember the concept of all is you're still applying the filter context, but the only difference is in all what you're saying is you're removing all the filters. Okay, what is a calculated column in Power BI and why would you use them? And this is the part where I talk a little bit about calculated columns. And an example that I will show you guys here is related to, let's say, profit percentage. So what I will do here is I have a measure that I created here. I'll go back and delete it. So I have a cost column. What I will do is I'll build a calculated column. So you build calculated columns using the new column option. You build measures in the new measure option. So I can build calculated columns using this option here, and column name will be profit percentage. What is the formula for profit percentage? It is going to be profit by, I think I've selected the wrong table. Okay, so yeah, so one problem that happens is, and just to, I think good that we got this error. So one thing that happens is, when you create the calculated column, remember that you're clicking on the right table. So basically I'm trying to create a column on this table and I'm not able to find the profit column because obviously it doesn't exist in my bonds table. So obviously I'm trying to create a table, a column in the wrong table. Okay, so I'll go back and delete that from here. So ideally the profit percentage should be created in my orders table, right? So I'll go to my orders table, just click on it once, and that should pretty much be enough to select that table, and click on new column. Now click on new column, and that means that now that particular column is now, so you can see that that's now a part of my orders table. Okay, it by default comes with the column name of column, but I can absolutely go ahead and change it to something like profit percentage. And profit percentage is going to be profit. And now as I start typing profit, you can see automatically profit will come up. Orders of profit, that's the basic syntax that is applied. So orders is my table name and profit is the column. So that is profit by cost. That's my percentage of profit percent, right? So profit by CP into 100. So that's my calculated column. Everything looks okay up to this point. And what I will also do is additionally, I'll also create a measure. Okay, additionally, I'll also create a measure. Conceptually, there is a lot of difference, but syntax wise, there is very little difference. So what I will do is I'll create something exactly similar. Only difference is this time I'll call it profit percentage measure. See, all I've done is I've copied pasted the entire formula. So that is the measure. And the only other thing that I have to do for measures is I have to aggregate it. So that is the only other additional syntax difference in measures, that I have to pre-aggregate my fields in measures. Okay, because without aggregations, measures have no meaning inherently. So that is what I'm going to do. Oh, sorry, one small thing I have to change. So 100 is basically going to come outside the sum. That's my measure. So what I have is a profit percentage calculated column and the profit percentage measure. You can see that the difference in icons. Now conceptually, what is the difference? There is actually a lot. And as an example, if I show you region, and if I basically want to know what is my profit percentage across different regions, if I just try to see the profit percentage using calculated columns, look at my number. Is that even a valid number? I mean, 300,000 percentage. Is that a total profit percent? Answer is wrong. That is absolutely incorrect data. Okay, so even if I want to look at this data across in a granular level across different segments, you can see it's the same problem. I get very, very big numbers, which is definitely something wrong with my data. But the moment I take something like the measure, if I take that measure here, everything looks perfect. Okay, things look perfect now. Okay, the measure is giving me the right result, whereas this is giving me the wrong result. And why is that so? And that is basically the key difference, the key conceptual difference between a calculated column and a measure. Okay, I'll come to the performance aspect, when to use what, and obviously when you answer this question on measures and calculated columns, performance aspect is also very important, but you should always start with the conceptual difference first. What is the conceptual difference? What is actually happening in the model? And what is actually happening in the model is, when you look at the calculated column, all that it is doing is, it is basically summing this up. It is actually aggregating all the data that is already there in my model. Okay, in other words, when you go back to the model, and when you look at the orders table, if you just scroll over to the right, you will see that profit percentage is actually calculated and stored for every single row in my model itself. Okay, so whatever column you're looking at the end here, profit percentage is basically a calculated column that has been calculated for every single instance of the row. Okay, and that is stored in my model. So all that I'm doing in the table is I'm aggregating all these values together, which is obviously incorrect, right? So essentially what it means is, if I look at row number, let's say if I look at row number 1 and 2, and if I look at all the 20 rows here, which are all Western, okay, essentially what I'm trying to do is I'm trying to add up all these profit percentage values for West. Okay, it's just like doing a group by region and sum of profit percentage, which is obviously incorrect. Okay, it is obviously incorrect. And if you look at my table, that's exactly what I'm doing. I'm actually doing a sum of profit percentage across all those rows, which is actually incorrect. Okay, so that is the problem, that is the key problem, and that is exactly what you need to fix here. Okay, and even if you try to do a average of profit percentage, you might be wondering that, okay, so obviously if I try to do a sum of profit percentage, I'll get a problem. So why don't I just go back here and change this to average? Even by doing this, you will get incorrect output. Okay, you will get incorrect output even if you do this. This is not the right way of building it. Okay, the right way of building this is to actually do it using measures. Okay, and that is exactly what I want to highlight here. And the other thing that you would have observed is in measures, they are actually not stored in the model. Measures are always calculated ad hoc, dynamically on the fly. Measures are never stored in your model. Okay, your model calculates the value of the calculated column and it stores them on a row by row basis in the model, but it never stores the value of your measures. Measures are always calculated dynamically on the fly. Okay, so if you just look back at this particular example here, you can see these measures are always recalculated. So when I go back and remove that segment, those measures are actually getting recalculated on the fly. Okay, so I'm actually recalculating them on the fly. If I just go back and take something else, let's say instead of region, if I just go back and take a category, it's actually getting recalculated. Okay, so that is an important thing about measures that you should keep in mind. Okay, and that is the other reason why when you build a measure, you can just see that in measures, because they are not calculated on the fly, because they're actually not stored in my model, you have to define the aggregations here. Okay, they are calculated dynamically based on whatever filters you apply, whatever stuff you do, they're always calculated dynamically. Okay, and they are responsive to filters. That is the other important thing. They are responsive to filters. Okay, so for instance, if I go back and put some filters here, let's say I'm looking at category and I can actually further split it by subcategories. Okay, and now if I go back and put some filters, let's say I'll go back to region and I'll put some page level filters here for region. And if I look at for central data, you will see that now they're responding to filters. Okay, they're actually going to be responsive to filters as well, generally. Okay, and they're recalculating every time you're changing anything in your data, they're recalculating based on the aggregations that you've defined. Okay, so a couple of key things that you have to keep in mind when you talk about measures. A is they are not stored in your model. B is they are dynamic. They are always calculated on the fly dynamically as and when you're building your visuals. And C is obviously they're particularly useful for calculating any kind of data which is pertaining to percentages or anything that represents any kind of denominator. Okay, so divisions particularly are a very common use case where you will use measures, because divisions are where calculated columns will fail all the time. Okay, imagine building something like this in your query level. Okay, you cannot do it. You cannot build a visualization like that in query layer. Okay, so for instance, if you try to perform this profit percentage calculation row by row, it will not work. Okay, it will not work. And in these kind of scenarios where you have some kind of percentages, some kind of denominator, some kind of division involved, you should always use measures. Okay, and again, measures should be used for complex calculations. And the other really powerful aspect of measures is that, and as we have mentioned in the slides here, as you can see that here, calculated columns are not compressed and they consume more memory. And the reason why they consume more memory is because, as I said, they're stored in the model. And this is where again measures win out. Okay, measures win because measures are actually, they're not stored anywhere. Okay, it's more dynamic, they're not stored anywhere, they take less storage. And but the obvious disadvantage of a measure is that because they're not stored anywhere, because they're dynamic, because they're calculated ad hoc on the fly, they probably put more strain on the resources, right? So it'll probably take more time to evaluate. So as of today, the differences are hardly, you'll hardly feel it. It's almost negligible because of some of the performance improvements that have taken place. But generally, they'll give roughly the same performance. But still, measures do take a little lesser time comparatively because, as I said, just put more resources. And as you can see, the last point that you mentioned is they can also reduce processing and refresh performance if applied on large fact tables and can make a model more difficult to maintain or support. Okay, given that the calculated column is not present in the source system. That is another important point you should keep in mind. Power Pivot, I think we have spent a lot of time already on Power Pivot discussing the components at a very high level already. But when you're asked a question on what is Power Pivot, it's very important to link it with DAX. So again, it is a discussion on one of the components of Power BI. So I think it will be really appreciated if all of you could just spend a minute to go over what is Power BI, talk about the self-service aspect, talk a little bit about some of the components of Power BI, and then come to talk about Power Pivot, and the fact that it's the modeling layer, the fact that you have that X velocity in memory column database that you're maintaining, and essentially that's the layer that you actually build DAX, calculate columns and DAX measures in Power BI. Okay, so mention those pieces along with that. Another thing that I wanted to mention is the data model. Quickly, data model obviously is the model that you're building after you're performing the query editing and all that stuff. The place where you're loading all your stuff into is what we call data model. And data model consists of tables, and obviously tables are consisting of columns and rows, and essentially you have relationships. Okay, these are the key aspects of a data model. And just to briefly explain this whole piece to you, and what I'll do here is I will be connecting to my Excel once again, and I'll just be bringing in one more table. So what I'll be doing here is I'll be quickly going ahead and connecting to my Excel and bringing in one more table called returns, just to demonstrate to you guys what is a relationship and how to quickly build a relationship. And you can see it's the same process, and the only difference is that I'm going to bring in these two tables, people and returns, together. Okay, I'm just going to directly load them. You can see processing queries, and I've loaded the data into my model right now. it is loading my data. So this is a step where I'm loading my data, creating connection, loading data to model. You can see these steps. And I have to make a small change. Actually, I go to edit queries and my data is actually not in the right shape. So I need to go back to returns, and there's a quick thing I'll change here. Let's go back and make this first row as headers. You can see headers are not in the first row. Very, very simple ETL operation I'm going to perform. Go back to people and convert that to first row as headers. I'm not really using bonds, so I'll just go back and go back and remove bonds. So I'll just delete the bonds and close and apply this. Okay, so what I have as the end result is I have 3 tables. Remember, in query editor they're called queries, but the moment you load that into the model, that is Power Pivot, we call them tables. Okay, so everything is a table now. And if you go back to the tables tab, you will see the 3 tables that are present here, obviously orders, people, and returns. And if you go to the relationships tab, you can actually see the relationships. Okay, so Power BI will do a pretty decent job in automatically creating relationships based on column names. So if there are 2 similar column names, Power BI will automatically relate them, but then it will not do a very good job always. Okay, so for instance here you can see region and region are automatically related. Just double click on the relationships tab and you can see the relationship. Region and region are related. You can see the types of relationships: cardinality, many to one, one to one, one to many, the typical standard relationship types. And it's an active relationship. That's something you can turn on and off. Okay, and you can also, I can see, but returns it was not able to relate. Let's just go back and manually do it. Order ID, just it's as simple as a drag and drop, and now we've related orders and returns as well. It's very, very important to build relationships, guys. And it's always a consideration that you have to decide whether you want to keep everything in one table or you want to go back and keep things in separate tables. It's always a very, very key question that you might get. So at what level do you decide should you normalize further? At what level do you decide that? So that's a very tricky question, and I think there's no easy answer to that, but it really depends. Just like so many other things, it really depends on a lot of different scenarios, because you can decide to have everything in one table. So for instance, if you look at this particular use case, you can decide to have orders, people, and regions, returns all in one single table. Okay, you can just go to query editor, do a merge queries. You can just join all these 3 together and have everything in one denormalized table. Things are good, but the obvious disadvantage is that it's going to be a big table, it's going to take a lot of space, and that's not a good thing. Okay, and on the contrary, you can keep them in separate tables, but the obvious problem will be that because the relationships are there, whenever you're trying to query data across, when you're trying to visualize something across 3 different tables, it's just going to take a little bit more time compared to when you're trying to do it in one table. Okay, so there are obvious pros and cons in both approaches, but it's important to understand the relationships are very, very important. And mostly in Power BI, as I said, you will mostly have these normalized scenarios where you will typically have a lot of these split out tables, and you will typically have to combine them with relationships. Okay, and why is relationships important? Because without relationships, you cannot visualize data across multiple tables. So for instance, you have orders here, people here, returns here, and if you go to my visualization layer now, I can opt to see sales by and you can see sales I've selected from the orders table. I can go to the people table. I can visualize that by person. Okay, I can actually visualize that by person. Remember, I have selected fields from 2 completely different tables, and I can actually filter that whole stuff by the return status. Okay, pretty cool, isn't it? And this is something I could not have done this if I have not related the tables. Okay, so you can see the visualization that I have here. I have selected fields across 3 different tables, and this was possible only because I've related the tables. If I have not related the tables, for instance, if I had not related my tables, if I just go back and remove the relationship here, if I make them independent tables without any relationship, you can see that it will give the same values. At times, Power BI will give an error like this, and at times it will actually go back and say give the same value. Okay, so that's an important thing to remember and understand exactly why relationships are required. And these are some scenarios that you should actually point out when you talk about the data model and what is Power Pivot, and when you talk more about relationships. Okay, so the X Velocity in-memory analytics engine is something I talked about. That's basically the underlying engine behind Power Pivot. That's something that drives Power Pivot. It can handle a huge amount of data because at the underlying layer, it is nothing but a columnar database. Okay, it stores data in columnar databases, and columnar database, as some of you may know, is a very special kind of database which is optimized for storing huge amounts of data, and overall data access is very, very fast in a columnar database. It doesn't maintain data in a typical relational database format where data is stored in the form of rows and columns, typically the way we understand it. But columnar database is a very, very special way of storing data, and I'll encourage all of you to go look at it more. And if you can stress a little bit more on columnar database when you talk about this particular concept, just spend a little bit of time talking about what is a columnar database, because as I said, everything about Power Pivot and the in-memory engine of Power Pivot is based on columnar database. So talk about a columnar database, mention a bit about what it is, and if you can get into those aspects of why data is fast, why access is fast, nothing like it. But it's not required, and that's getting too much in advanced aspects, but that's not required, but it's an optional thing that you can take a call on. Relationships, obviously, there's an option that you can set. You can either have one active relationship, you can have multiple active relationships. Obviously, if you go to the relationship types here, one very common use case of this will be order dates, the date thing. Okay, you can have order date, ship date, due date, and a very common use case of this is especially if you're dealing with role-playing dimensions. And this is a very common scenario that you should mention. Role-playing dimensions is a term that you should mention where you can only have one active relationship. Okay, very important that you mention that, guys. With role-playing dimension, you can only have one active relationship. Okay, and how do you make a relationship inactive? So we talked about that already. Let's say region and region related here. It's a solid line. You can actually double click on that and you can make that relationship inactive. Click on OK, and that is an inactive relationship. Power Query, I think we spent a lot of time on this already. So needless to say, when you talk about Power Query, mention a couple of key terms: ETL tool, shaping, cleansing, transforming data. Very important pieces, and also mention the M query bit, that every query is a combination of steps and you can build multiple queries, and ultimately the underlying layer you're writing M code. Okay, query folding is actually another very important feature in Power BI, and obviously it's more of a performance enhancement question that can get asked. Very important question actually that sometimes tends to get asked here from a performance optimization standpoint. And query folding basically relates to the fact that the kind of operations that you can perform at the source get transferred to the source. Okay, so at a very basic level, you can see that there's something called view native query. There will be something called view native query that you will see. So if I just quickly go ahead and get some data from SQL Server here, real quick, I'll try to pull in some data from SQL Server. I think this is also the first time that you're seeing how we connect to a SQL Server. So I give it dot as my server name, and I'll try to connect on to my local instance. I have a database called AdventureWorks as a demo. So I'll connect to my AdventureWorks database, and here I'll go ahead and connect to, let's say, dim customer, or let me go back and connect to dim product. Connect to dim product. Click on OK, and there goes my SQL Server table. And if I try to add in some columns here, let's say what I'll do is I'll try to remove all this stuff. Okay, try to remove all the stuff that I have here. Remove columns. Obviously, these are things that's going to work as expected. Just like as we understand, steps are going to be created. I can go back and remove all this stuff from here. Okay, I don't need this. So I kept only 3 columns. And what I can do here is further thing, I can actually add columns, whatever. And the idea here is to show you something called view native query. And what happens here is that I've actually got data into Power BI desktop now. Okay, you remember I connected to my SQL Server, I got data into Power BI desktop. And after that, whatever transformation I performed here, I performed this within Power BI desktop. Okay, so whatever transformation I did it within Power BI desktop. But using query folding, Power BI will actually transfer that operation to my source. So what is my source? My source is my SQL Server. So instead of performing this operation within Power BI, that is, instead of performing this in memory inside Power BI, I will be performing this in database. Okay, so you're transferring in-memory operation to an in-database operation. Now that stuff will be performed in your database, that is in your SQL Server, and the resultant will be returned. So if you just go to right click on that and go to view native query, you can see that this is the resultant stuff that will be returned from my underlying table from my database. Okay, it's a very powerful feature, and what it means is that when you're actually getting the data into Power BI, you're not going to get all those 50 columns, right? If you need only 3 columns, then Power BI will bring in only those 3 columns. And actually, as I said, it's a very powerful feature, and it not only works with removing columns, you can actually go back and remove columns, and you can see that at this layer also, if you go to view native query, it actually gets renamed as alias gets applied. Okay, so let me give some different name here, like color name. Let's say English product name, I'm going to call it, let's just going to call it product name. Okay, and here I'm going to call it product ID. So I've actually renamed all my columns here. And as we understand in as part of the SQL language, when you rename a column, all you're doing is you're actually applying an alias. And again, as you can see, although this step I'm performing within Power BI desktop, Power BI desktop will just go back and offload that operation or transfer that operation back to the source, which is the SQL Server. And if you go to view native query, you can actually check that. Okay, and again, it's a very important piece that you should keep in mind. If you try to do a split here, let's say I'll try to do a split here, split by delimiter. Okay, and let's say I want to split this by a space and click on OK and see how I've split that stuff. And if I right click on this, now you will see that view native query is disabled, because in the native SQL language, in native SQL Server, this operation is not supported. So up to a certain point, you can do query folding, but beyond a certain point, you can't do query folding. That is another important thing to keep in mind. So if you perform any transformation in query editor, for which query folding is not possible, obviously view native query will be grayed out in that case. Obviously that means that at the native database layer, that particular operation is not supported. So that's another important thing to keep in mind. Okay, what are some of the common transformations? Another very important question that might get asked at times, because just to test your basic level of knowledge, changing data types, very fundamental thing. You'll do it always, all the time. Another thing that I will add is adding, header rows. You want to basically modify your header rows. Filtering rows, another very useful thing. Typically, if you're connecting to Excel data or some kind of CSV sources, initial few rows might just be, gibberish. It might just have merge cells, some kind of image, some kind of introduction, headers, all those stuff. And you'll always want to filter out rows initially. Columns, such an important thing. You don't want to see all those columns, right? If you have 50 columns, you don't really care about. Just take out 3 or 4 columns out of it. Very important option. Grouping, aggregations, again, very important. Splitting, another very common kind of transformation that you might want to use. Okay, like some delimiter or some characters based on which you want to split the columns out, subset something out. So very, very important option over adding new columns. Needless to say, it's something that you do all the time, right? Can SQL and Power Query be used together? I think I just answered this question in this example here. Answer is absolutely yes, you can. And the best part is you don't have to, obviously you can do it in the graphical user interface, or you can directly go ahead and type out your query. You can straight away type out your SQL query here, more customized SQL query across multiple tables. What are query parameters? Query parameters are, again, a very, very important topic in Power BI. And query parameters, the whole idea is that they are very similar to filters, but they are a more dynamic sort of filters. And the way you set them is using the parameters wizard here. I will go back to my orders query right now. Go to manage parameters and set up a new parameter called region. So I can actually define a parameter like this. It's a region parameter. Type is going to be text type. Okay, suggested values is going to be, let's say I'm going to give a list of values, and when you say any, basically you get a text box, and if you give a list of values, you get a drop down. That's the only difference. I'll show you both the examples. Okay, current value is a default that you can give. Actually, I'll go back and put it as central, right? So as my region parameter I've set up here, and now what I can do is I can go to my orders table and see how I can filter by region here. In the query editor, I can go here, I can filter by region. I can directly type out a value here. Instead of doing this, what I can do is I can go to text filters. I can say equals, and here I can go back and select the specific parameter type. Okay, and this is really the amazing thing about parameters. So now instead of saying equals to a particular region, instead of typing out a value here, I can go back and say it is equal to that parameter region. Okay, so now that filter is actually equal to that parameter region. Okay, and what is that parameter region equal to? Remember that parameter region equal to was set as central. So now that central parameter is set to central, and that is why it is filtered on central. Okay, if you go to the region, it is seen as filtered on central right now. And it's very easy to change it, by the way. Go to edit parameters, go to edit here and see that text box comes up. Because the list type was any, it is actually set as a text box. And actually go back and set it as something else. Let's say east, and now we can see it's automatically going to change it to east. Okay, that's the real beauty of using parameters generally. You just have to go back and click on that interface once for it to reflect, just to refresh it once for it to reflect. And now you can see it's reflecting as east. If you go back and set this as west, let's say go back and set this as west. And if I go back to orders now, you should be able to see that now the entire thing is automatically filtered to west. So you can see how dynamic the whole thing is. And remember, this is not only at the query editor level, even at the visualization layer. When you're using parameters, when you've actually loaded this query in, you can straight away go to edit parameters. So something very similar to what we are seeing here, you will see in the visualization layer also. You will see in the modeling tab, here, you will see the edit parameter section coming up here, where you can go back and directly modify your parameters straight away from the visuals itself. And one other important thing is the other use case where this is actually required, and the question that we're asking here is Power BI templates. The other thing that you should all mention. What is the use case of this? As I mentioned, the use case of this is, one very common use case of this is you don't want to load all your data, right? So if you have data for all the 4 different regions, central, east, west, and south, you don't want to load all your data, right? You can have hundreds and thousands of rows of data, but you don't really care about all your data, right? If you want to look at data only for west, then you want to select west. You want to see data only for east, you want to select only east, right? But what you don't want to do is you don't want to select all your data. You want to get all your data into Power BI desktop, and then you want to filter it. Okay, there are 2 options, right? One option is to include all your data, load all your data, and then put a filter. The other option is, first you give the user a prompt, and based on whatever option they select in the prompt, you go back and load your data. And the second option is obviously the parameter approach, which is preferred any day, because you're loading in only the requisite amount of data that you require. You're not loading in any additional data. And the best part about the second approach is, again, as I said, you're loading in only the amount of data that's required. So obviously the amount of data that you're loading in is very, very less. And obviously the performance will be much better. So another common use case is with dates, right? So if you have data for the last 10 years, and you don't care about that 10 years data, right? So you care about only data for the last 1 month. So you always give people a filter option. Or in this case, when I say filters, I mean parameters, right? So you configure filters with parameters, and now people get a prompt. When they open up the dashboard, they get a prompt. And when they want to view the dashboard, they will actually have to select the date. They'll have to go to the prompt, select the date. And now, depending on what they enter, data will be filtered. And from the source, only that data for the last 3 months will be picked up. Okay, so that's the use case of parameters and how parameters are different from the normal standalone filters. Which language is in Power Query? We talked about it already, M code, and it's very important to also mention a bit of background when you ask this question. Just talk a little bit about the background of what is Power Query. Why do we need Power Query when Power Pivot can import data from mostly sources? And I think this also has been answered before. I've talked about this as well previously, but it's also important when you get this question to give some context on what is Power Query and what is Power Pivot, and essentially mention the part that although yes, you can get data in Power Pivot, but it's also very, very important that you address the part that it is Power Query that is an ETL tool. Okay, Power Pivot is not an ETL tool. Power Pivot is only used for loading data into the model. That's it. I mean, essentially, Power Pivot can only be used for performing calculations and analysis. Okay, the whole point of Power Pivot is analytics. Okay, it is not for data cleansing. Okay, if you want to perform data cleansing, that is not Power Pivot's role. So the two add-in components, the two tools have two very different roles. And that is the thing that you have to bring out in this particular question. Power Maps obviously is the mapping interface of Power BI. So I'm just going to briefly focus a bit on this particular piece. Obviously, maps are extremely powerful in Power BI desktop. And if you just go to the maps section, one very, very important thing, guys, you have to keep in mind is when you're configuring, especially working with maps, is to set the correct geographical type. So if you go to modeling, you have data category, something called data category. It is very, very important that when you inherently have data like city, it is very important that you go to data category and set this as a city. Okay, extremely important that especially when you're working with map data, you have to set this as geographical data type. And when you do that, you will see a small globe sign will come up. Okay, so now it signifies that city is actually of a data category city, which is a geographical type, and a small globe sign will come. I will do the same for country as well. Do the same thing for country. I'll do the same thing for postal code and see how postal code is actually summarized. So this is another thing that will happen from time to time in Power BI, which you have to fix in modeling. So sometimes something will be summarized. So obviously postal code is something I don't want to summarize. So I'll actually go to don't summarize. Okay, because if I give you two postal codes 560102 and 560103, you can't, I mean, it makes no sense to say the average postal code is 560102.5. Makes no sense, right? So I'll never summarize that kind of data. Go to postal code and set it to postal code as a geographical type. See, the globe sign will come up. And finally, the only thing that's remaining here is state. I'll go to state and set a type here as state. And once that is done, I will go ahead and, okay, you can see that it says apply changes. And the problem here is that I've actually made some changes to my underlying query, which is something that's okay. I'll not go back and load it right now. So I'll directly straight away go to the maps. And there are two kinds of maps mainly in the desktop interface. Obviously, there are a lot of custom visuals that you guys have. So just to give you a sneak peek into custom visuals real quick, and we're going to spend a lot of time on that, but just to give you a sneak peek on this whole piece, I have a lot of custom visual maps where you can do a lot of cool things. But at a basic level, obviously, you have only the kind of maps that you're seeing here right now. I'm going to quickly go ahead and close that query. Because I'm connected to my SQL server, it is creating a bit of issue. Give me a second here. Guys, I'm just reconnecting. So my session got ended actually. I'm sorry for the interruption here. Okay, so next step is I'm going to go ahead and quickly replicate and just kind of repeat what I just now did. So I'm going to quickly go ahead and set this to city. Set my state to the state type. Set my postal code. And finally, I'll go ahead and set my country. Okay, so the idea again is that I wanted to highlight here is the concept of setting geographical types correctly, because this again, when you try to visualize this data finally in maps, it just ensures that you're more accurately able to represent data. Remember, Power BI will do a pretty good job in understanding exactly what a particular thing is. So if it's a city name, if it's Delhi, Bangalore, Mumbai, Power BI knows it is a city. So you don't have to specifically tell it's a city. But remember, if it's something that Power BI is not able to perfectly recognize, in certain cases, it will be very, very useful, because remember, the column names are not always going to be exactly what you're seeing right now. Although it's recommended that you use proper column names, but that may not be the case. And again, the underlying data may not be exactly what Power BI is able to recognize. So those kind of scenarios is very helpful if you set data categories accurately. Remember, even if you don't set it properly, Power BI will still display your data properly. Okay, but then there are certain use cases where it will not come accurately. Okay, and I can go ahead and represent this in a map. And all I have to do is just take my country, I'll take my state, I'll look at my city, and see how Power BI is not able to do it the best way all the time. So sometimes it will fail, and I'll represent this data based on sales. So sales is basically going to be my size, let's say. Okay, I can further do a color saturation based on sales. Okay, I can look at this data across, and now you're seeing, right? And you might be wondering what's exactly happening. Why am I only seeing, Western United States? And the reason is because if you remember, I have filters applied. So the underlying model that I've taken, I have filters applied based on parameters. Okay, And again, that is something I can further configure within Power BI. Okay, just to quickly clarify this once again, where do you set the edit parameters? Remember, parameters is something I applied just a while back, and you can further look at the visualization layer. You can further go to edit queries, go to edit parameters. You don't have to open edit queries, just go back here and set it as east or west or central, whatever you want to set. This is east now, click on OK, and you will see now this whole thing will automatically go ahead and convert to east. Okay, you have to apply the changes because remember, we're actually doing it as a query level change. So idea is that when you set this as east, it will go back to the query, it'll take all your data, it'll take your eastern data, and now it will show you only the eastern data. Okay, so that's the idea now. Now it is only showing you eastern data. You can further go to edit queries. Now you go to see the central data. Just type in central here, and now you're going to see only central data. Okay, so apply changes for the filter to actually go back to the source and get only the relevant central data. And this is the part where I mentioned that at every point in time, you're prompting the user. And again, it's a very, very good performance optimization technique that you can use, especially when you're dealing with very, very large data sets. Okay, few of these things I've already talked about. These are a few additional questions that we have. Power View, Power BI Designer. Can we refresh our reports, Power BI reports? This is an important question. Again, this is related to scheduled refresh. Scenarios are you will want to refresh your data, right? You will want to typically have a schedule. And when you're publishing your data on the cloud or a dataset section, you basically have an option for schedule refresh. And this is exactly where you can go ahead and set up your refreshes specifically for the kind of data that you have. And you need something called a gateway. Right now, my gateway is not configured, but you need something called a gateway to set up a schedule refresh. Remember, if you are connecting to an on-premise source, especially a SQL Server database or something like that, on-premise source, then you need to have a gateway. And you can actually download your gateway from here to configure it further, right? And you can also go to the Manage Gateways tab to basically go and manage your gateways. So if you already have a gateway installed and you want to go back and set your gateway specifically, so this is one other place where you can go back and check your gateway. Everything's working fine there. Okay, so it's important that you mention a couple of these things that obviously, yes, you can refresh. There is something called schedule refresh, and also mention about gateways. Gateways are that they are the interface between the cloud and the on-premise world. Okay, so gateways are what allows you to transfer your data from on-premise sources to your Azure cloud, where your cloud server, that's the Power BI service, is hosted. What are the different types of refreshing data? Package refresh, model refresh, tile refresh, and visual container refresh. So this is another important question. So typically when we talk about refreshes, how many ways can you refresh? The package refresh is basically the concept wherein, let's say you have a Power BI desktop file or an Excel file, which you have in the service. And I mean, obviously the same file is there in OneDrive or SharePoint Online, and you want to ensure that they are both synced. Essentially, whatever data you have here, you have there, and vice versa. And that is something you do using what we call package refresh. Okay, that ensures that whatever files you have in your Power BI service is exactly in sync with what you have in the OneDrive or SharePoint Online. Remember, it is not going to pull data from your source. It's not like the typical kind of refresh that you're thinking. So that is basically going to be the model or data refresh. So the refresh that you're thinking, or the refresh that I showed you here, is basically the model or data refresh. Okay, this is basically what we call the model or data refresh. Okay, that is what you do using refresh now or schedule refresh. Okay, then we have something called tile refresh, which is something that we can go to the different dashboards, and as we all understand in dashboards, whatever stuff that you see, remember these are just views of the underlying reports. Okay, and you can just click on the tiles and it will take you to the underlying report. So dashboards are nothing but cached views of the underlying reports, which typically get refreshed every 15 minutes or so. Okay, but if you want to specifically refresh a tile, you can go back and say refresh dashboard tiles. Okay, that is how you refresh the dashboard views to reflect according to the data changes, which anyways get refreshed every 15 minutes. Okay, those are the types of views refreshes that you have. Is available on premises? Answer is absolutely yes. And when you answer this question, it's also very, very important for you to specifically mention about the gateways and also to talk a little bit about the kinds of sources that you can connect to. Okay, remember, for Power BI to connect to cloud sources, it doesn't need a gateway. So if you have something living on Azure, if you have something living on an online service, you do not need a gateway. If you have something living in SharePoint Online or OneDrive, you do not need a gateway. Okay, so even if you want to perform a schedule refresh, you don't need a gateway. So gateways are only required if you want to connect onto on-premise source, either to perform a schedule refresh or to get data directly from a direct query. Okay, which is nothing but a live connection essentially. What is Power BI Q&A? And Power BI Q&A, as I briefly showed you sometime initially in the discussion, was it's a natural language querying tool. So you can just type in queries and essentially it just gives you results on the fly. It's not that intelligent right now. Remember, it's still a very, very preview feature. It's a feature under constant development, but it's fairly accurate. It's pretty good overall. and there's a lot of artificial intelligence built in overall there in how the tool performs, especially in the app. And I don't know if you guys have used the, just do take some time. It may not be an interview question, obviously, but take some time out to explore this on the Power BI app. And in Power BI app, what they rolled out a feature called conversational Q&A. Okay, so here is a standard Q&A, but if you use the app, they have something called conversational Q&A, where it is just like as if you're having conversation with Google Assistant or Siri, something like that. Just like you're having a conversation, asking them, hey, what is the sales? And they'll go back and respond something. And then you can just go back and carry on the conversation from there. You don't have to type in a new question every time. Okay, you can just carry on the conversation, just like having a conversation with a friend. It's pretty cool feature overall. And remember, this feature is there as a in the service, but it is there in the desktop as a preview feature, which is something you should also mention. Okay, so what are the ways Excel experience can be leveraged with Power BI? And there are a couple of things that we can do in Excel, by the way, which I wanted to briefly talk about. And just to discuss about this piece, what I want to do is I just quickly open up Excel. So there are two things particularly that you have in Excel. So one thing we call the Power BI Publisher for Excel, obviously the personal gateway and the on-premise gateway, the gateways that we have. But there's one additional component that is worth mentioning called Analyze in Excel Updates. As you can see, there's something called Analyze in Excel Updates. So these are both add-ins that you have to install in Excel. So Analyze in Excel allows you to go back and analyze a data set in Power BI from within Excel. Okay, so if you have a data set in Power BI service, just go ahead, click on it. Okay, you can click on it and you can basically just say Analyze in Excel. And when you do that, basically you download a file, you download an ODC file. ODC file basically stands for Office Data Connection File. Just going to show you what that Office Data Connection File is and how it looks like. So this is what an ODC file looks like. Okay, if you guys see my screen right now, you will see that it's an Office Data Connection File. Okay, it's an ODC file. Right click, go to Properties, you will see it's an ODC file. Okay, and now what I can do is I can directly just double click on it and it will open up within Excel and it will straight away open up in the Power Pivot interface. Okay, what I did was I took data from the data sets in Power BI service and I'm analyzing that straight away within Excel and see how it opens up. Okay, that's my orders table and see how it comes up now. Remember, in my original service also I had only the orders table. Okay, so now I'm looking at the same orders table and I'm analyzing that table within my familiar pivot table interface. Okay, fine. So this is a great feature that we have in the Power BI. The overall interaction and overall the interaction that you have between Excel and Power BI is just phenomenal generally. Okay, and a lot of these things tend to be included. A lot of these things are happening where there is more interactivity that's been built in, but the overall concept is that the integration has to be seamless between both the environments, right? So you can very clearly take data from service, from the Power BI to Excel and Excel to Power BI and vice versa. So that's the seamless integration that exists right now between these two tools. So right now we have learned how we can get something from the service onto the Excel, but the other way around, from Excel to the service, essentially from Excel to Power BI, how do you do that? And for that, you need something called Power BI Publisher for Excel, which I have already added as an add-in. And remember, again, for this, you need to go ahead and sign into your service. And I can just go ahead and hit a publish now. And all I have to do is I can just pin it, just usual way I can pin to my dashboard. Just a very simple example, AAA. I go ahead and pin to my existing dashboard. And you can see it's published, it's pinned to my dashboard now. And if I go back to the service and if I take a look at my demo, I can see that AAA is now pinned. And you can see how seamless integration is and how these two environments, Power BI and Excel, are talking to each other. Okay, so it's very, very important that you mention some of these use cases as examples. And if you can do that, if you can highlight some of these things, it'll be really appreciated than just giving a theoretical answer. So give some of these examples and use cases and what. Okay, these are the Excel BI add-ins. I spent a lot of time discussing this. So do mention a very, very brief about all these different tools that you have. How is data security implemented in Power BI? This is actually a very, very important question, especially which pertains to row level security, RLS as we call it. Okay, and the way you do that in Power BI is using the concept for roles. Okay, so you first do this in the desktop. So for instance, right now here you can see I have data. One of the first things I'll do probably here is remove that parameter. Okay, and go ahead and remove that parameter. Okay, it's being referenced by the query, so I can't remove obviously. So I'll just go back and first go ahead and quickly remove that filter. And now go back and remove that parameter. Okay, and close and apply. So what I'm looking at right now is obviously the entire United States data because I have no filters applied. So everything's perfect. I can go to manage roles. And the way I do this is using something called manage roles. Okay, so if you go to the modeling tab, you see something called manage roles in security. Go to manage roles and here you will have an option to set roles. Okay, so what I will do is I will want to create separate roles for separate people, right? So let's say it's a big company that I have as I operate and I have different people from different regions. I have central people, I have eastern region people, I have western region people. So central region people should not be able to look at data for eastern region people, right? If you belong to central region, if you're a manager for central region, you don't care about eastern region or western region, right? So it might be confidential data or whatever the use case, but you only want to focus on data which is central. So what I will do is, in that case, I will basically create roles. I will create what I call a central role, and I will create what I call a eastern role. And as a next step, what I need to do is I need to go back and write some basic DAX. And what I will do is I'll go ahead and type in my quick expression. I'm going to say region is equal to central. And remember, this is the role I'm setting for central role. The DAX filtered expression, this is always going to be a filtered expression. And the result always has to be a true or false, right? So this is going to be region equal to central. And for the remaining, I'm just going to go back and hit save. And for Eastern, I'm going to put it as region is equal to Eastern. Okay, so see how I set up two different roles here. One is for the central role. So if anyone is viewing it from the central region, this particular filter will be applied by default. And if anyone is viewing it from the eastern region, this particular filter will be applied by default. Okay, click on save. And now the DAX role has been configured. Okay, one way you can preview this feature is by clicking on view role as. Okay, and a good way to do this is just to go back and put some additional information. Let's say I'll have a region here. And I'll have region-wise sales and profits mentioned here, just to give some clarity on the exact data that you're seeing. And now if I go back and click on view roles as or view as roles, this is the way you can preview your stuff. Okay, that how the central people will view this. They're looking at only central data, and how the eastern people will view this. Now they're looking at only eastern data. Okay, so this is how you can go and see that stop viewing as option will come up. You're actually viewing it as the role of east role. So as a developer, you can preview exactly what people will see when they see your dashboard. Okay, so it's a very, very important feature. Now, all this is good. So all that we have done right now is we have implemented this in the desktop. How do we publish this out? So obviously we already understand publishing. So all that we have to do is obviously we're going to go ahead and save it first. And I'm going to go ahead and publish this out, save it in my demo file. So remember to obviously to implement this in the service, you have to publish it first. So right now I've just implemented my desktop. So the final step is I have to publish it. So I will publish to my workspace. So replace because the exists another dataset with the same name is already there. So it will by default replace because they both are the same names, right? And once I do that, go back to my service now, and you can go to datasets now. You can go to manage security. There's a security section here, and here you should be able to add. You should see the roles present here. Okay, this is where you can basically now go back and add the email addresses of all the people. And remember, this further will be linked to your AD groups, right? Because remember, you've configured, it depends on the admin settings, how you've set it and all that. But basically, you can type email addresses of all those people who are belonging to the East role and email addresses of all the people who are belonging to the central role. Now, if anyone who is in the Eastern role and if they try to view your dashboard, now they will basically be looking at only Eastern data because I've said that filter, remember, region is equal to East. And if anyone who is belonging to the central role is trying to view your dashboard, they will look at only central data. Okay, and that depends on what email addresses you enter here. Okay, so as an administrator, you can basically go ahead and enter all this stuff. And that is how you, at a very, very simple layer, you can implement row level security. Remember, I've done it at a very simplistic level, but this could be a far more complex DAX expression. So you can come back here and you could probably go back and write a far more complex DAX expression. The idea is that it has to be a boolean by as the end product. Power BI does support mobile. So there is a Power BI mobile app which is supported across multiple platforms. And many relationships are something that's another very, very important point that it tends to gets asked a lot. So does it support many-to-many relationships? Answer is actually no. It only supports one-to-one, one-to-many, and many-to-one. But many-to-many, if you have to implement using what we call bridge table. Okay, so that is something you have to specifically replicate or create either in the model or in the Power Query. So first create that bridge table, a one-to-many to many-to-one. A very good example could be authors and books. One author can write many books. One book can be written by many authors. Or doctors and patients, also a very good example. One doctor can has treated multiple patients, and one patient has been treated by multiple doctors. In both these cases, you have to create a bridge table. Okay, and then you will set up the one-to-many relationships in Power BI Desktop. That is how we will typically implement this. Power BI publish for Excel. We have talked about this already. The differences we have briefly talked about. Edit interactions typically work at the visual layer of Power BI. Another very, very important component, especially in the visualization stack, is edit interactions. So here, it's a very simple bar chart I have. I can parallelly build a line chart here. And now my line chart is going to be showing my sales based on order date, let's say. Okay, very simple line chart I have here. So the idea of edit interactions is you want to specifically choose how you want these two to interact with each other. Okay, so I can further have that map. Okay, so I'm going to take that map, I'm going to copy paste it across here. Okay, so now I have 3 different visuals on the same page, and I'm going to try to set up an interactivity between each one of them. Okay, just going to try to align them a bit, and the way to do that is using edit interactions. Okay, go to format, go to edit interactions, and that's how you turn on the interactions panel. And as you can see, when I click on the map, how are the others interacting? Okay, so you can see very clearly the line is being filtered, whereas the bar is being highlighted. What does it mean? It means that when I click on a particular value here, so if I want to know more about California or San Francisco, click on San Francisco and everything else is filtered on San Francisco. Okay, if I want to know more about, let's say, Colorado, city of Littleton in Colorado, click on Littleton and now you see everything about Littleton in Colorado. Want to know more about New Jersey, Lakewood? Click on Lakewood and you see more about Lakewood. And see how this particular line chart is filtered, whereas this is actually highlighted. If you want to turn on the filter for this, go to edit and make it a filter. Now it is actually filtered and not highlighted. Okay, if you want to turn this as none, you can turn this as none. So irrespective of whatever you select here, so you can see the line is not being impacted. Okay, and that is how you basically turn on interactions and specify interactions between different visuals in Power BI Desktop. And finally, how does SSRS integrate with Power BI? And this is again something that you guys should mention, especially when you're asked a question on components. So you will anyways discuss about the Microsoft BI stack and generally talk a little bit traditional BI. And separately, if you're asked the question, does it integrate? Answer is absolutely yes. Just the same way I showed you how Excel and Power BI integrate so seamlessly, the same thing applies with SSRS as well. In SSRS and Power BI, they interact very, very seamlessly. Okay, you can build SSRS dashboards and you can very easily pin them into Power BI the same way I pinned an Excel stuff into Power BI. Okay, so same thing happens in SSRS as well. Okay, so indeed there's a very, very rich interaction that happens between both. All right, so that's all that we have for the session here. So thank you once, thank you all for joining in, and have a good day, have a good night. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!